I finally got the desktop in the window. And I spilled water all over the pen tablet. And it's like bugging out, so that's cool. There's no reason for it to be this blurry or choppy. Let's turn these off then. I did want to check. Like guesstimate how many frames per second. I think it's probably at 60 because the monitor's at 60 right now. Or it's supposed to be at 60. The monitor might be at 30 FPS because sometimes I don't know. I'll see if this looks like 30 FPS. That does look like 30. Like 4. So that's like gonna enter every 4 frames. It's supposed to be like 15. 5. That's weird. 5. Catches it right between. You see a triangle, but I see like 2 screens. Oh no, it's now you can see the other one. So it's not in sync. Yeah, YouTube is not streaming at 60 FPS. It's streaming at like 30 or something. Or like 40-ish. I'm gonna do 60 and see if it takes a whole second per frame. It's a little bit faster. It's probably 60 FPS. 60 FPS. Probably. Let's move this out. I'm not gonna deal with performance right now. I'm just gonna get it running. It's like the laziest code here ever. Alright, so what I need or whatever is I have to like capture desktop F4K. It's like freaking CPU bound. It has to go to the CPU to copy it. I gotta do 4K because the GPU won't scale it and send it. I don't have access to that feature of the GPU because of NVIDIA. And even though you buy the video card, you don't actually have access to the whole product that you purchased. But with AMD you do. So I don't know, I'm gonna get AMD card. Later though. I'd have to like change everything. Rewrite the stupid code. So we gotta capture the desktop at 4K to capture like the normal desktop how it is now. But also it'll blur it. And I gotta blur it. I'll just use a shade or whatever. And scale it to like 640 by 400 something. And I don't know. That's the plan. I'm gonna get this done then. Now back to programming and the engine, JavaScript engine. I'll go from page 1 to page 816 in standard. And be the first JavaScript implementation to meet the entire standard. I'm gonna stream the whole thing, whatever. And timestamp in the description. Each category as we go through with the number that's tagged with. And go through each step of it, whatever. I don't know, yeah. I already wrote the JavaScript engine. It's 32-bit. I'm converting it to 64-bit. I switched over to Linux from Windows. I had to make this program because I couldn't find one that does what I need. So I had to make one. This took a whole freaking week. So now I'm a whole week, an entire week behind. Already being a week behind. Because this was last week. This was the week before. The week before took a whole week to install Linux. Because Linux is I have it running on a 16, 15-year-old computer. The first Gen i7. So I had to figure out how to install Linux with master boot record and a whole bunch of like other annoying stuff because it's not a UEFI, whatever the boot is for the new stuff. I don't know. That was a pain. That took like a tier 2. And then, so like, overall took a week to get on Linux. Now it's taken a week to write the shader program. I can't believe it's finally working. That took so long. So I'm like 2 weeks off from where I was, which is really annoying. Because I can't get to the standard until I have the computer set up. It's like, whatever. The standard, I'm planning on 2 months. So this put me off 2 weeks. Setting up Linux. So now this is bleeding in to August. I got September, October. Time keeps moving, and it's really, really annoying. I am getting the standard though. It's not too far away. I need some water. Alright, so I don't know. I'm gonna have Siri read the standard. I need to download a better sound software.
A superbinding. That has superbinding concrete method of a declarative environment record env-rect takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 1, 10 with base object. The with base object concrete method of a declarative environment record env-rect takes no arguments and returns undefined.
I don't know, so basically
return undefined, 1, 1, 2 object environment records. Each object environment record is associated with an object called its binding object. An object environment record binds the set of string identifier names that directly correspond to the property names of its binding object. Property keys that are not strings in the form of an identifier name are not included in the set of bound identifiers. Both own and inherited properties are included in the set regardless of the setting of their attribute. Note a regular declarative
should we just click all the image?
One that is neither
All the images.
nor a module environment record. Does not provide.
Okay, it didn't.
Note a regular declarative environment record. That is, one that is neither a function environment record nor a module environment record. Does not provide a superbinding. 38. Copyright sign, ECMA International 2024. Because properties can be dynamically added and deleted.
Put this on a USB.
Set of identifiers bound by an object environment record may potentially change as a side effect of any operation that adds or deletes properties. Any bindings that are created as a result of such a side effect are considered to be a mutable binding, even if the writable attribute of the corresponding property is false. Immutable bindings do not exist for object environment records. Object environment records created for with statements 14.11 can provide the binding object as an implicit this value for use in function calls. The capability is controlled by a Boolean field. Object environment records have the additional state fields listed in Table 17. Table 17, additional fields of object environment records. The behavior of the concrete specification methods for object environment records is defined by the following algorithms, 1, 1, 2, 1 has binding, n.
Is the bitmap better than PNG?
The NVREC takes argument
For the video card.
and returns either a normal completion containing a Boolean or a throw completion. It determines if its associated binding object has a property whose name is n. It performs the following steps when called.
Let's do PNG.
envrec let found binding b has property binding object n. If found binding is false, return false. If envrec is false, return true. Let unscopables b get binding object add at unscopables. If unscopables is an object, then a let block b to boolean get unscopables n. b. If blocked is true, return false. Return true. Point 2 create mutable binding n. d. The create mutable binding concrete method of an object environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates an environment records associated binding object to property whose name is n and initializes it to the value undefined. If d is true, the new property's attribute is set to true, otherwise it is set to false. It performs the following steps when called. Let binding object be envrec. Perform. Define property or throw binding object n. Property descriptor undefined. True, true. D. Return unused. Field name, value, meaning, binding object. An object. The binding object of this environment record is with environment. A boolean indicates whether this environment record is created for a with statement. Note normally envrec will not have a binding for n, but if it does, the semantics of defined property or throw may result in an existing binding being replaced or shadowed or cause an abrupt completion to be returned. ECMA International 2024 139 9 1 1 2 3 Create a mutable binding n. S. The create a mutable binding concrete method of an object environment record is never used within this specification, 1 1 2 4 Initialize binding n. V. The initialize binding concrete method of an object environment record envrec takes arguments n, a string, and v, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v.
What do you call this? Resources?
Vrec set mutable binding n. V. False. Return unused, 1 1 2 5 Set mutable binding n. V. S. The set mutable
Paste.
object environment record envrec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to set the value of the environment records associated binding object's property whose name is n to the value v. A property named n normally already exists.
It looks terrible.
Writable. Error.
I'll get a better one later.
Following steps when called.
So I'm gonna do this instead of...
Still exists to be. Has property. Binding.
I gotta like open up
If still
stupid window.
is true. Throw a reference error exception. Perform. Set. Binding object n. V. S. Return unused, 1 1 2 6 Get binding value n. S. The getBindingValue concrete method of an object environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its associated binding object's property whose name is n. The property should already exist, but if it does not, the result depends upon s. It performs the following steps when called. Let binding object be envrec. Let value be has property binding object n. If a value is false, then if s is false, return undefined. Reference error exception 4. Return get binding object n, 1, 1, 2, 7. Delete binding n. The delete binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that correspond to properties of the environment object whose attribute have the value true. It performs the following steps when called. Note in this specification, all uses of create mutable binding for object environment records are immediately followed by a call to initialize binding for the same name. Hence, this specification does not explicitly track the initialization state of bindings in object environment records. 2. Let binding object be envrec. Return binding object n. 40. ECMA International 2024 9 1 1 2 8 has this binding. That has this
Okay, so like this background.
environment record envrec takes no arguments and returns false. It performs
This is somebody else's program.
and false, 1 1 2 9 has super binding.
A shader program or whatever that runs on Windows. It didn't run on Linux.
Arguments and returns false.
So I had to like
When called, return false.
make my own shader and stuff because it doesn't work on Linux. So I had to make my own, basically.
Object environment
So I got the desktop in the window here,
or undefined. It performs the following
but I still need to pixelate it.
otherwise, return undefined, 1 1 3 function environment.
Like here, whatever.
Function environment record is a declarative environment record that is used to represent
So I can pixelate the screen when I'm working on code
not an arrow
that I'm not giving away for free.
binding. If a
Sometimes I can show the code, but sometimes I'm not going to show it.
its function environment record
Because if I always showed the code,
to perform
there'd be no engine release because everybody would copy me.
environment records have the
So I don't know, I need this program, but it doesn't work on Linux.
additional
So I had to make my own.
environment records. Note, object environment
Except this background around like the TV border and stuff.
is super binding. Field name, value, meaning this value, NEC
I don't want to like copy what this guy has
vocation of the function. This binding state
because then it's like taking from his program and putting it in mine.
initialized. If the value is lexical, this is an arrow function and does not have a local this value. Function object, NECMA script.
So like later on,
The function object whose
like another day, whatever,
environment record to be created.
I'll like get a video of this, cut out the middle.
This environment record was created by the internal method, is the value of the new target parameter. Otherwise,
I want to get the car in the background.
copyright sign, ECMA International 2024, 41. Function environment records support all of the declarative environment record methods listed in table 16 and share the same specifications for all of those methods except for has this binding and has super binding. In addition, function environment records support the methods listed in
So I don't know, instead of like copying the other guy's program,
environment records method
I'm going to use this as a background for mine.
and record that it has been initialized. Get this bind
I'm going to do like the video though, but for now, to just get done like today, because if I can get done today, I can start programming tomorrow.
object that is the base for super
And if I start programming tomorrow,
environment record.
I can actually get back to converting my engine to 64-bit, then I can do standard.
Specification methods for
So I'm gonna like fancy it up later. I'll make it look better.
1 1 3 1 bind this value v
But I don't want to copy what this guy did straight up from his program.
argument v any
So since I had to rewrite it,
value and returns either a normal completion containing an
I'm gonna do this for my background, whatever.
throw completion. It
Except this is for later, because it's gonna take too long to take a video of the video
call if
and then cut out the middle.
throw a reference error exception. Set env rec to v. Set env rec to initialized. Return v, comma 1, 1.
Because this took 7 days already.
As this binding
It's gonna take even longer if I keep dragging this out. I wanna get done.
arguments and returns a boolean.
So instead of that,
Steps when called. If env rec is lexical, return false. Otherwise,
for now, I took a crappy screenshot
3, 3
and I tried to like
binding concrete method of a function environment record
get rid of like the YouTube icons, but it's gonna take too long. It's gonna look like crap anyways. If I like, I even missed the corner here.
comma 1, 1, 3. Forget this binding. The get this binding concrete method of a function and
It looks like I didn't go to school for graphic design. That's how bad this looks.
an ECMA script language value
I don't care though. I just gotta get done.
when called. Assert. env rec is not lexical. If env
So at some point, I'll get a better video, whatever. This works for now.
rec 42
So my plan now
2024 9 1
is to get this picture into this window
is concrete method of a function environment
and to keep the inside transparent.
and returns either
So this window has this border with this video inside of it.
completion. It performs the following steps when called. Let
And at that point, I'll mess around with scaling the contents and getting the video,
comma 1
the desktop screen, what the screen capture desktop.
environment record is used to represent the outermost scope that is shared by
I'll work on getting that like scaled and fitting
a global environment.
inside of this whatever.
Globals, clause 19, properties of the global object, and for all top-level declarations, 8, 2, 9, the 8th of February 2000. Within a script, a global environment record is logically a single record, but it is specified as a composite encapsulated
I want to get this over with.
a declarative environment record.
I still have some programs to install.
As its base object, the global object.
If I get this done, this is out of the way, then everything else is like tiny little like download the last couple things, then unplug, and then I'm good to go.
Environment record component of a global
Then I can finish converting it to 64-bit,
are all built in
and I can go through the 800 page standard
introduce
and meet it from top to bottom and stream it as evidence that I met the whole standard
a sync generator declaration.
instead of standard on meeting standards.
Findings for all other ECMA script declarations in global code are contained in the declarative environment record component of the global environment record. Properties may be created directly.
So I'm gonna ask chatbot. I hate chatbot.
Object environment record component of a
I'm gonna get some water.
may contain both bindings created
Then get back to this.
by function declaration, generator declaration, async function declaration, async generator declaration, or variable declaration declarations and bindings created implicitly as properties of the global object. In order to identify which bindings were explicitly created using declarations, a global environment record maintains a list of the names bound using its create global var binding and create global function binding concrete methods. Global environment records have the additional fields listed in Table 20 and the additional methods listed in Table 21. Table 20. Additional fields of global environment records. Field name, value, meaning, object record, and object environment record. Binding object is the global object. It contains global built-in bindings as well as function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMA script object value. Declarative record. A. Declarative environment record. Contains B. Bindings for all declarations in global code for the associated realm code except for function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings. Var names, a list of strings. The string names bound by function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration declarations in global code for the associated realm. Copyright sign, ECMA International 2024. 43. Table 21. Additional methods of global environment records. Method. Purpose. Get this binding. Return the value of this environment records this binding. Has var declaration. N. Determines if the argument identifier has a binding in this environment record that was created using a variable declaration. Function declaration. Generator declaration. Async function declaration. Or async generator declaration. Has lexical declaration. N. Determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration. Has restricted global property. N. Determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding. Can declare global var. N. Determines if a corresponding create global var binding call would succeed if called for the same argument. N. Can declare global function. N. Determines if a corresponding create global function binding call would succeed if called for the same argument. N. Create global var binding. N. D. Used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding. N. V. D. Create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 1, 4, 1 has binding. N. The has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a Boolean or a throw completion. It determines if the argument identifier I is one of the identifiers bound by the record. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding n is true, return true. Let objrec be envrec. Return objrec has binding n, 1, 1, 4, 2 create mutable binding n, d. The create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and e, a Boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the name n that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If d is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding n is true, throw a type error exception. Return dclrec create mutable binding n, d, 1, 1, 4, 3 create a mutable binding n, s. The create a mutable binding concrete method of a global environment record envrec takes arguments n, a string, and s, a Boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the name n that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding n is true, throw a type error exception. Return dclrec create a mutable binding n, S, comma 1, 1, 4. For initialize binding, N, V. The initialize binding concrete method of a global environment record the NVREC takes arguments N, a string, and V, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is N to the value V. An uninitialized binding for N must already exist. It performs the following steps when called. Let DCLREC be NVREC. If DCLREC has binding N is true, then a return. DCLREC initialize binding N, V, assert. If the binding exists, it must be in the object environment record. Let OBJREC be NVREC. Return. OBJREC initialize binding N, V, 1, 1, 4, 5 set mutable binding N, V, S. The set mutable binding concrete method of a global environment record the NVREC takes arguments N, a string, V, an ECMA script language value, and S, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is N to the value V. If the binding is an immutable binding and S is true, a type error is thrown. A property named N normally already exists, but if it does not or is not currently itable, error handling is determined by S. It performs the following steps when called. Let DCLREC be NVREC. If DCLREC has binding N is true, then a return. DCLREC set mutable binding N, V, S. Let OBJREC be NVREC.
I gotta like
Mutable
find some music,
S, 1, 1, 4.
then ask chatbot, like probe chatbot for data, information,
Environment
figure out how to get this picture into this window.
and return
I think it'd be like the same way, using like 2D whatever,
completion. It
whatever I use to get this video here, whatever,
initialized binding throw a ref
or not. Maybe it's like a completely different method. That's be a lot of fun to figure out.
is determined.
So why would it be simple?
Following steps when
It could be like 7 days worth of like trial and error. You know, why would it just be simple?
DCLREC get binding
It wouldn't. So I'm not going to plan anything being simple,
145. 3. Let
because it's not going to be.
OBJREC get binding value N.
And I don't know. I'm going to get this image in the window.
Record the NVREC takes argument N.
Then I'm going to like clean up the pipeline or the buffers or whatever you call them.
Bindings that have been
I'm going to try to like figure out exactly how they're being called
forms the following step.
so I can call them and like get the transparency in the middle,
DCLREC has bind
scale it and everything.
turn. DC
And then I'll try to explain how I would assume the GPU works.
has owned
There's no way I could do a tutorial because it's like GPU specific and like operating system specific,
N.
and it's way too, there's no way to make a tutorial.
Then I
I'll like go through all the parts or whatever
untrue, 1, 1, 4.
of how I like assume it's working, though I'll probably be wrong because this stuff is like really funky.
Steps when called. Return true, 1, 1.
And all this video card stuff, it makes no sense. It's ridiculous.
The NVREC takes no argument.
Alright, I gotta stop complaining.
Performs the following steps when called. Return
I have to like get to the standard.
1, 0 with base
And the more I complain,
object concrete method of a global environment record
the more time it adds. Another day, it's another day, is another day.
steps when called. Return undefined 9, 1.
So many days.
1, 1 get this binding.
So I gotta find some music. I'm gonna try to like figure this stuff out.
Arguments and returns a normal complete
I need to get a new sound software later. Also,
called. Return
I'll do it later.
40,
Now, just getting
2020.
this picture into this window. That's my goal. I want to get this thing done today.
4.1.2 Hasvar Declaration. N. The Hasvar Declaration concrete method of a global environment record env-rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called. Let var declared names be env-rec. If var declared names contains n, return true, return false, 1, 1, 4, 1, 3 has lexical declaration. N. The has lexical declaration concrete method of a global environment record env-rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called. Let dcl-rec be env-rec. Return. dcl-rec has binding. N, 1, 1, 4, 1, 4 has restricted global property. N, the has restricted global property concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called. Let obj-rec be env-rec. Let global object be obj-rec. Let existing prop be global object. N. If existing prop is undefined, return false. If existing prop is true, return false. Return true, 1, 1, 4, 1, 5 can declare global var. N. The can declare global var concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if calls for the same argument n redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called. Let obj-rec be env-rec. Let global object be obj-rec. Let has property be has own property, global object. N. If his property is true, return true. Return. Is extensible, global object. Note properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147 9 1 1 4 1 6 can declare global function. N. The can declare global function concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called. Let obj-rec be env-rec. Let global object be obj-rec. Let existing prop be global object. N. If existing prop is undefined, return. Is extensible, global object. If existing prop is true, return true. If is data descriptor, existing prop, is true and existing prop has attribute values. True, enumerable. True, return true. Return false, 1, 1, 4, 1, 7 create global var binding. N. D. The create global var binding concrete method of a global environment record env-rec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called. Let obj-rec be env-rec. Let global object be obj-rec. Let has property be has own property, global object. N. Let extensible be is extensible, global object. If his property is false and extensible is true, then a perform. Obj-rec create mutable binding. N. D. Be perform. objrec initialize binding, n, undefined. If envrec does not contain n, then a append n to envrec7. Return unused, 1, 1, 4, 1, 8 create global function binding, n, v, d. The create global function binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMA script language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8, replaced. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object. N, if existing prop is undefined or existing prop is true, then a let desc be the property descriptor. V, true, true. D, else a let desc be the property descriptor. V, perform. Define property or throw, global object. N, desc. Perform. Set, global object. N, v, false. If envrec does not contain n, then a append n to envrec. Return unused. 48. ECMA International 2024. Note global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls, 1, 1, 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMA script module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms, 1, 1, 5, 1 get binding value, n, s. The get binding value concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called. Assert. S is true. Assert. envrec has a binding for n. If the binding for n is an indirect binding, then a let m and n2 be the indirection values provided when this binding for n was created. B let target envbm. C if target env is empty, throw a reference error exception. D return target env get binding value. N2, true, if the binding for n and envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n and envrec. Note S will always be true because a module is always strict mode code 9. 1, 1, 5. To delete binding, n. The delete binding concrete method of a module environment record is never used within this specification. Method. Purpose. Create import binding, n, m, n2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and N2 is a binding that exists in M's module environment record. Get this binding. Return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note module environment records are only used within strict code, and an early error rule prevents the delete operator in strict code from being applied to a reference record that would resolve to a module environment record binding. C13 5, 1, 1 has this binding. That has this binding concrete method of a module environment record env-rect takes no arguments and returns true. It performs the following steps when called. Return true, 1, 1, 5. For get this binding. The get this binding concrete method of a module environment record env-rect takes no arguments and returns a normal completion containing undefined. It performs the following steps when called. Return undefined, 1, 1, 5. 5 create import binding, m, and 2. The create import binding concrete method of a module environment record env-rect takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record, for an n2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called. Assert. env-rect does not already have a binding for n. Assert. When m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in env-rect for n that references m and n2 as its target binding and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9, 1, 2, 1 get identifier reference, env, name, strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called. If env is null, then a return the reference record. Unresolvable, name, strict. This value, empty. Let exists be env has binding. Name, if exists is true, then a return the reference record. env, name, strict, empty, else. 150 ECMA International 2024. Note, module environment records always provide this binding. AB, let outer be env, return. Get identifier reference, outer, name, strict, 9, 1, 2, to new declarative environment. E. The abstract operation new declarative environment takes argument D, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, for a new object environment. O, W, E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to O, set env to W, set env to E. Return env, 1, 2, for new function environment. F, new target. The abstract operation new function environment takes arguments F, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical, else. Set env to uninitialized. Set env to new target. Set env to F. Return env, 1, 2, 5 new global environment. G. This value. The abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let obj-rec be new object environment. G. False. Null. Let DCL-rec be new declarative environment. Null. Let env be a new global environment record. Set env to obj-rec. Set env to this value. Set env to DCL-rec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment. E. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env. ECMA International 2024 151 9.2 Private Environment Records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name. Value type, meaning, outer private environment, A, private environment record or null, the private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names, the private names declared by this class. 9. 2. 1 Private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 New private environment. Outer privy env. The abstract operation new private environment takes argument outer privy env, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy env, names, 2, 1. To resolve private identifier, privy env, identifier. The abstract operation resolve private identifier takes arguments privy env, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy env. For each private name pn of names, do if pn is identifier. Then I return pn. Let outer privy env be privy env. Assert. Outer privy env is not null. Return resolve private identifier. Outer privy env, identifier. Point 3 realms. Before it is evaluated, all ECMA script code must be associated with the realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24. 52. Copyright sign, ECMA International 2024. Table 24. Realm record fields. Field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal, parse node, and v, an array, f. The agent that owns this realm, the global object for this realm, the global environment for this realm, meaning the intrinsic values used by code associated with this realm, a list of records with fields are a string and a module record. Note 1. Once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2 as mentioned in host load imported module 16.2.1. 8. Note 1. In realm records is only used when running an import expression in a context where there is no active script or module. Field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9, 3, 1 create realm. The abstract operation create realm takes no arguments. ND returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec. Set realm rec to agent signifier. Set realm rec to undefined. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9 3 2 Create intrinsics. Realm rec. The abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, realm rec, return unused, comma 3.3 set realm global object, realm rec, global obj, this value. The abstract operation set realm global object takes arguments realm rec, a realm record, global obj, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called. If global obj is undefined, then a let intrinsics be realm rec, b set global obj to ordinary object create intrinsics, assert global obj is an object. If this value is undefined, set this value to global obj, set realm rec to global obj, let new global env be new global environment, global obj, this value, set realm rec to new global env, return unused, comma 3.4 set default global bindings, realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let global be realm rec, for each property of the global object specified in clause 19. Do a let name be the string value of the property name, b let desc be the fully populated data prop, rty descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4 the value of the attribute is the corresponding intrinsic object from realm rec. See perform. Define property or throw, global, name, desc, return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to an executable code that is not associated with that. 54. Copyright sign, ECMA International 2024, execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component. Purpose. Code evaluation state. Any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMA script resources. Script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in first-out manner. However, some ECMA script features require non-LFO transitions of the running execution context. The value of the realm component of the running execution context is AL, so called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component. Purpose. Lexical environment. Identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment. Identifies the environment record that holds bindings created by variable statements within this execution context. Private environment. Identifies the private environment record that holds private names created by class elements and the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let X be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding. Name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. Env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode code. Let strict be true, else let strict be false. Return get identifier reference, env, name, strict, 4.3 get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment 2. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name. ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has a this binding. 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion containing an ECMA script language value or a throw completion. It determines the binding of the keyword this using the lexical environment of the running execution context. It performs the following steps when called. Let envrec be get this environment. Return envrec get this binding. 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let envrec be get this environment. Assert. envrec has a field. Return envrec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, host enqueue promise job, and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract pair as keywords within certain syntactic productions, at places where identifier is not allowed, as async, from, get, meta, of, set, and target. The term conditional keyword, or contextual keyword, is sometimes used to refer to the keywords that fall in the last 3 categories, and thus can be used as identifiers in some contexts and as keywords in others. Syntax. Reserved word. 1 of await break case catch class const continue debugger default delete do. Else enum export extends false finally for function of import and instantia new null return super switch this throw true try type off var void well with a yield. 24. ECMA International 2024. Note 1 per 5. 1. 5. Keywords in the grammar match literal sequences of specific source character elements. A code point in a keyword cannot be expressed by a Unicode escape sequence. An identifier name can contain Unicode escape sequences, but it is not possible to declare a variable named else by spelling it else u. 65. The early error rules in 1.3. 1. One rule out identifiers with the same string value as a reserved word. Note 2 enum is not currently used as a keyword in this specification. It is a future reserved word, set aside for use as a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public are future reserved words in strict mode code. Note 3: the names, arguments, and eval are not keywords, but they are subject to some restrictions in strict mode code. C13 1 1 8 6 4 1 5 2 1 1 5 5 1 1 5 6 1 and 1 5 8 1. 2.8 Punctuators. Syntax: punctuator, optional chaining punctuator, other punctuator, optional chaining punctuator, look ahead decimal digit, other punctuator, 1 of, comma, equals, 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 plus, percent, plus, plus, and, equals, plus, equals, 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 percent, equals, 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 and equals, 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 and equals, 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 equals. Div punctuator, equals sign. Right brace punctuator, 2.9 literals, 2, 9, 1 null literals. Syntax: null literal, null. ECMA International 2024 225, 1 2, 9, 2 Boolean literals. Syntax: Boolean literal, true, false, 2, 9, 3 numeric literals. Syntax: numeric literal separator, numeric literal, decimal literal, decimal big integer literal, non-decimal integer literal, plus sep, non-decimal integer literal, plus sep, begin literal suffix legacy octal integer literal, decimal big integer literal, 0 big int literal suffix, non-zero digit decimal digits, plus sep opt begin literal suffix, non-zero digit numeric literal separator decimal digits, plus sep, begin literal suffix, non-decimal integer literal, sep, binary integer literal sep, octal integer literal sep, hex integer literal sep, begin literal suffix, n, decimal integer literal, decimal digits, plus sep opt exponent part, plus sep opt, decimal digits, plus sep, exponent part, plus sep opt, decimal integer literal exponent part, plus sep opt, decimal integer literal, 0, non-zero digit numeric literal separator opt decimal digits, plus sep, non-octal decimal integer literal, decimal digits, sep, decimal digit, decimal dig, it sep, decimal digit, plus sep, decimal digits, plus sep, numeric literal separator decimal digit, 1 of 0 1 2 3 4 5 6 7 8 9 26. ECMA International 2024. Non-zero digit. 1 of 123,456,789. Exponent part. Sep. Exponent indicator signed integer sep. Exponent indicator. 1 of EE. Signed integer. Sep. Decimal digit sep. Decimal digit sep. Decimal digit sep. Binary integer literal. Sep. 0b binary digit sep. 0b binary digits sep, binary digits, sep, binary digit sep, binary digit, plus sep, binary digits, plus sep, numeric literal separator binary digit, 1 of 0 1, octal integer literal, sep, 0 octal digit sep, 0 octal digit sep, octal digits, sep, octal digit sep, octal digit, plus sep, octal digits, plus sep, numeric literal separator octal digit, legacy octal integer literal, 0 octal digit, legacy octal integer literal octal digit, non-octal decimal integer literal, 0 non-octal digit, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, non-octal digit non-octal decimal integer literal decimal digit, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, 0 octal digit, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit, 1 of 1,234,567, non-octal digit, 1 of 89, ECMA International 2024 227, hex integer literal, SEP, 0x hex digits SEP, 0x hex digits SEP, hex digits, SEP, hex digit SEP, hex digit, plus SEP, hex digits, plus SEP, numeric literal separator hex digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, abdef ABCDEF. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 2, 9, 3, 1 static semantics, early errors, numeric literal, legacy octal, integer literal, non-octal decimal, integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note in non-strict code, this syntax is legacy 2, 9, 3, 2 static semantics, MV, a numeric literal stands for a value of the number type or the big int type. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal, plus the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal. 10e, where e is the MV of exponent part. The MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal, decimal integer literal exponent part is the MV of decimal integer literal 10e, where e is the MV of exponent part. The MV of decimal integer literal. 0 is 0, the MV of decimal integer literal, non-zero digit numeric literal separator op decimal digits is the MV of non-zero digit 10n plus the MV of decimal digits, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal digits. Decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of decimal digits. Decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer. Decimal digits is the negative of the MV of decimal digits. The MV of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 228. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or a binary digit. 0 is 0, the MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1, the MV of decimal digit. 2 or of non-zero digit, the MV of decimal digit. 3 or of non-zero digit, the MV of decimal digit. 4 or of non-zero digit, the MV of decimal digit. 5 or of non-zero digit, the MV of decimal digit. 6 or of non-zero digit, the envy of decimal digit. 7 or of non-zero digit, the envy of decimal digit. 8 or of non-zero digit, the envy of decimal digit. 9 or of non-zero digit, or of hex digit. 2 or of octal digit. 2 is 2, 3 or of hex digit. 3 or of octal digit. 3 is 3, 4 or of hex digit. 4 or of octal digit. 4 is 4, 5 or of hex digit. 5 or of octal digit. 5 is 5, 6 or of hex digit. 6 or of octal digit. 6 is 6, 7 or of hex digit. 7 or of octal digit. 7 is 7, 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the envy of hex digit, or of hex digit. A is 10, the envy of hex digit. B or of hex digit. B is 11, the envy of hex digit. C or of hex digit. C is 12, the envy of hex digit. D or of hex digit. D is 13, the envy of hex digit. E or of hex digit. E is 14, the envy of hex digit. F or of hex digit. F is 15, the envy of binary digits. Binary digits is the envy of binary digits 2 plus the envy of binary digit. The envy of binary digits. Binary digits numeric literal separated binary digit is the envy of binary digits plus the envy of binary digit. The envy of octal digits. Octal digit is the envy of octal digits 8 plus the envy of octal digit. The envy of octal digits. Octal digits numeric literal separator octal digit is the envy of octal digits 8 plus the envy of octal digit. The envy of legacy octal integer literal. Legacy octal integer literal octal digit is the envy of legacy octal integer literal times 8 plus the envy of octal digit. The envy of non-octal decimal integer literal. Capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, non-octal digit is the envy of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, times 10 plus the envy of non-octal digit. The envy of non-octal decimal integer literal. Non-octal decimal integer literal decimal digit is the envy of non-octal decimal integer literal times 10 plus the envy of decimal digit. The envy of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit is the envy of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, times 10 plus the envy of octal digit. The envy of hex digits. Hex digits. Hex digit is the MV of hex digits 16 plus the MV of hex digit. The MV of hex digits. Hex digits numeric literal separator. Hex digit is the MV of hex digits 16 plus the MV of hex digit 2, 9, 3, 3 static semantics. Numeric value. The syntax-directed operation numeric value takes no arguments and returns a number or a big int. It is defined piecewise over the following productions. Numeric literal, decimal literal. Return round MV result, MV of decimal literal. Numeric literal, non-decimal integer literal. Return, MV of non-decimal integer literal. Numeric literal, legacy octal integer literal. Return, MV of legacy octal integer literal. Numeric literal, non-decimal integer literal big int literal suffix. Return the big int value for the MV of non-decimal integer literal. ECMA International 2024-229. Decimal big integer literal. 0 big int literal suffix 1. Return 0z. Decimal big integer literal. Non-zero digit big int literal suffix 1. Return the big int value for the MV.
This is
Decimal big integer literal. Non-zero digit decimal digit.
like very slightly like
Big int literal suffix.
Photoshop, but not really.
Decimal digits. Excluding all occurrences of numeric literal separator. Let NV be the MV of non-zero digit 10n plus the MV of decimal digits. Return Z, MV, 2, 9, 4 string literals. Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. All code points may appear literally in a string literal except for the closing quote code points.
Where's red, green, blue?
T. Reverse solidus, U plus 000D, carriage return, and U plus 000 line feed. Any code points may appear in the form of an escape sequence. String literals evaluate to ECMA script string values. When generating these string values, Unicode code points are UTF-16 encoded as defined in 1111. Code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as 2 code unit elements of the string. Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character, a double string character sopt, single string characters, single string character sopt, double string character, source character but not one of or line terminator. LS, PS, escape sequence, line continuation, single string character.
I don't know how Krita works.
Terminator, LS, PS, escape sequence, line.
I don't really like this program.
Line terminator.
Somewhere in here,
ECMA International 2.
you can like set the red, green, blue channels.
Character escape sequence. Look ahead decimal digit. Legacy octal escape sequence. Non-octal decimal
But it's like,
escape sequence. Unicode escape sequence. Character
it's brutally painful to use this program.
escape characters.
But this program is open source,
Then RTV.
and it does actually work pretty good
Character or
between different operating systems.
sing.
So I'll give it that. That's all it gets. So the like interface and everything, not very good.
8, 9
But it's better at being cross-platform than other programs.
to 3 octal digit. Look ahead octal digit. 4 to 7 octal digit. 0 to 3 octal digit. Octal digit. Non-zero octal digit but not 0.
But this has like color blend,
7. 1 of 4
red, green, blue, alpha.
non-octal decimal escape sequence. 1 of 89. Hex escape sequence. X hex
And chatbot said,
escape sequence. U hex 4 digits. U code point. Hex 4 digits. Hex digit, hex digit, hex digit, hex digit. The definition of the
with alpha blending,
given in 1, 2, 9, 3. Source
I don't know. I gotta figure out how to like set it up like this
2024 231.
and like get rid of the triangle.
MCR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such.
I Okay, for the triangle.
4. 1 static semantics.
But like, there's so many steps
Non-octal.
for each of these little things.
It is a syntax
I can't just easily insert it
strict mode code.
here,
1 in non-strict.
so I have no fucking clue.
C 2 9 4.
If someone like sit here and read this a bunch of times,
Directed.
eventually it'll probably click. And I'll figure something out.
A string literal stands for a value of the string.
There has to be.
Says string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below or in 1 2 9 3. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters. Double string characters is the string. Concatenation of the SV of double string character and
I don't know. I'm gonna like clean up the code, try to make it more readable,
single string character
save it back up,
is the string. Concatenate
and get rid of this triangle.
the SV
I need to replace the triangle with the actual desktop
one of oral line terminate
and make a second layer for this screen overlay, whatever.
double string character
So I gotta like think and figure it out.
listing of the code unit 0 times 2020.
I also want to get a video in here.
The SV of double string character PS is the string value consisting of the code
Does Linux run Sony Vegas?
operator. The SV of double string character
So many things to figure out.
V of single string character source character but not one of oral line terminator is the
Not enough time. Everything takes so much time.
by source character. The SV of single string character LS is the string value consisting of the code unit 0 times 2028 line separator. The SV of single string character PS is the string value consisting of the code unit 0 times 2029 paragraph separator. The SV of single string character line continuation is the empty string. The SV of escape sequence 0 is the string value consisting of the code unit 0 times 0000 null. The SV of character escape sequence single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. Note to it is possible for string literals to precede a use strict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error, function invalid.
Yeah, no, it doesn't run Linux. I'm about to run Windows.
International 2024, Table 38. String single character escape sequences. Escape sequence, code unit value, Unicode character name.
So, how am I gonna like try to learn something
T
and get this running?
009 character tabulation HTN 0 time
I can't keep asking chatbot. It's gonna take way too long to get anything done.
V
So if I can figure something out,
tabulation
then I'll be better off later on.
00C
So that's what I'm gonna try to do.
FR
I gotta find some music too.
E carriage
I also need to find sound software because the sound software is so bad. I gotta focus.
027 apostrophe backslash 0005C reverse solidus comma the SV of non-escape character source character but not.
So I think I'm gonna like clean things up first. And I gotta turn on a fan. It's so hot. I need winter to come back. I can't stand this heat. It's terrible.
Value consisting of the code unit whose numeric value is the NV of legacy octal escape sequence, the SV of non-octal decimal escape sequence. 8 is the string value consisting of the code unit 0 times 0038, digit 8, the SV of non-octal decimal escape sequence. 9 is the string value consisting of the code unit 0 times 0039, digit 9, the SV of hex escape sequence. X hex digit is the string value consisting of the code unit whose numeric value is the NV of hex escape sequence, the SV of hex 4 digits. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex 4 digits. The SV of Unicode escape sequence, U, code point, is the result of performing UTF-16 encode code point on the NV of code point. The SV of template escape sequence, 0 is the string value consisting of the code unit 0 times 0 0 0 0, null 1 2, 9, 4, 3 static semantics, MV, the MV of legacy octal escape sequence, 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence, 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence, 0 to 3 octal digit is 64. That is 82 times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0. The MV of 0 to 3. 1 is 1. The MV of 0 to 3. 2 is 2. The MV of 0 to 3. 3 is 3. The MV of 4 to 7. 4 is 4. The MV of 4 to 7. 5 is 5. The MV of 4 to 7. 6 is 6. The MV of 4 to 7. 7 is 7. The MV of hex escape sequence. X hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits. Hex digit is 0 times 1000 the MV of the first hex digit plus 0 times 100 the MV of the second hex digit plus 0 times 10 the MV of the third hex digit plus the MV of the fourth hex digit. ECMA International 2024 233 1 2 9 5 regular expression literals. The productions below describe the syntax for a regular expression literal and are used by the input element scanner to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMA script regular expression grammar. 2.2.2.1. An implementation may extend the ECMA script regular expression grammar defined in 2.2.2.1, but it must not extend the regular expression body and regular expression flags productions defined below or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular expression chars, regular expression chars. Empty, regular expression chars, regular expression char, regular expression first char, regular expression non-terminated but not one of or. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression class, regular expression char, regular expression non-terminated but not one of or. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression class, capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression non-terminator, regular expression non-terminator, source character but not line terminator, regular expression class, regular expression class chars, regular expression class chars. empty, regular expression class char's regular expression class char, regular expression class char, regular expression non-terminator but not one of, or, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U. Note 1. A regular expression, literal, is an input element that is converted to a regexp object. See 22.2 each time the literal is evaluated. Two regular expression literals in a program evaluate to regular expression objects that never compare as equals to each other even if the two literals' contents are identical. A regexp object may also be created at runtime by new regexp or calling the regexp constructor as a function. C22, 2, 4, 34. ECMA International 2024. Regular expression flags. Empty. Regular expression flags identify part char 2, 9, 5. 1. Static semantics. Body text. The syntax-directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression body 1, 2, 9, 5. To static semantics. Flag text. The syntax-directed operation flag text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression flags 1, 2, 9, 6. Template literal lexical components. Syntax. Template. No substitution template. Template head. No substitution template. Template character sop. Template head. Template character sop. $. Template substitution tail. Template middle. Template tail. Template middle. Template character sop. $. Template tail. Template character sop. Template characters. Template character. Template character sopt. Note 2. Regular expression literals may not be empty. Instead of representing an empty regular expression literal, the code unit sequence starts a single line comment. To specify an empty regular expression, use Dart. ECMA International 2024 235. Template character. Look ahead. Template escape sequence. Not escape sequence. Line continuation. Line terminator sequence. Source character but not one of or $sign or line terminator. Template escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Not escape sequence. 0 decimal digit. Decimal digit but not 0. X. Look ahead hex digit. X hex digit. Look ahead hex digit. U. Look ahead hex digit. Look ahead. U hex digit. Look ahead hex digit. U hex digit hex digit. Look ahead hex digit. U hex digit hex digit hex digit. Look ahead hex digit. U. Look ahead hex digit. U. Not code point. Look ahead hex digit. U. Code point. Look ahead hex digit. Look ahead not code point. Hex digits. SEP. But only if MB of hex digits. 0 times 10FF. Code point. Hex digits. SEP. But only if MB of hex digits 0 times 10FF. Note template substitution tail is used by the input element template tail alternative lexical goal 1, 2, 9, 6. 1. Static semantics. TV. The syntax-directed operation TV takes no arguments and returns a string or undefined. A template literal component is interpreted by TV as a value of the string type. TV is used to construct the index components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code units of the Unicode code point represented by the escape sequence. The TV of no substitution template is the empty string. The TV of template head, $, is the empty string. The TV of template middle, $, is the empty string. The TV of template tail is the empty string. The TV of template characters Template characters is undefined if the TV of template character is undefined or the TV of template characters is undefined. Otherwise, it is the string concatenation of the TV of template character and the TV of template characters. The TV of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TV of template character, $sign is the string value consisting of the code unit 0 times 0024. $sign, the TV of template character, template escape sequences the SV of template escape sequence, the TV of template character, not escape sequences undefined, the TV of template character, line terminator sequences the TRV of line terminator sequence, 236, copyright sign, ECMA International 2024, the TV of line continuation, line terminator sequences the empty string 1 2 9 6 to static semantics, TRV. The syntax-directed operation TRV takes no arguments and returns a string. A template literal component is interpreted by TRV as a value of the string type. TRV is used to construct the raw components of a template object, colloquially, the template raw values. TRV is similar to TV with the difference being that in TRV, escape sequences are interpreted as they appear in the literal. The TRV of no substitution template is the empty string. The TRV of template head, $sign, is the empty string. The TRV of template middle, $sign, is the empty string. The TRV of template tail is the empty string. The TRV of template characters, template characters is the string concatenation of the TRV of template character and the TRV of template characters. The TRV of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TRV of template character, $sign is the string value consisting of the code unit 0 times 0024. $sign, the TRV of template character, template escape sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of template escape sequence, the TRV of template character, not escape sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of not escape sequence, the TRV of template escape sequence. 0 is the string value consisting of the code unit 0 times 0030, digit 0, the TRV of not escape sequence. 0 decimal digit is the string concatenation of the code unit 0 times 0030, digit 0, and the TRV of decimal digit, the TRV of not escape sequence, x, look ahead hex digit, is the string value consisting of the code unit 0 times 0078, Latin small letter x, the TRV of not escape sequence, x hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0078, Latin small letter x, and the TRV of hex digit, the TRV of not escape sequence, u, look ahead hex digit, look ahead, is the string value consisting of the code unit 0 times 0075, Latin small letter u, the TRV of not escape sequence, u hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, and the TRV of hex digit, the TRV of not escape sequence, u hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the TRV of the first hex digit, and the TRV of the second hex digit, the TRV of not escape sequence, u hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the TRV of the first hex digit, the TRV of the second hex digit, and the TRV of the third hex digit, the TRV of not escape sequence, u, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, and the code unit 0 times 007b, left curly bracket, the TRV of not escape sequence, u, not code point, Lookahead hex digit is the string concatenation of the code unit 0 times 0075, Latin small letter u. The code unit 0 times 007b, left curly bracket, and the TRV of not code point, the TRV of not escape sequence, u, code point, lookahead hex digit. Lookahead is the string concatenation of the code unit 0 times 0075, Latin small letter u. The code unit 0 times 007b, left curly bracket, and the TRV of code point, the TRV of decimal digit. 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of character escape sequence. Non-escape character is the SV of non-escape character. The TRV of single escape character. 1 of BFN RTV is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of hex escape sequence. X hex digit is the string concatenation of the code unit 0 times 0078, Latin small letter x. The TRV of the first hex digit, and the TRV of the second hex digit. The TRV of Unicode escape sequence. U hex 4 digits is the string concatenation of the code unit 0 times 0075, Latin small letter u, and the TRV of hex 4 digits. The TRV of Unicode escape sequence. U, code point, is the string concatenation of the code unit 0 times 0075, Latin small letter u. The code unit 0 times 007b, left curly bracket, the TRV of ECMA International 2024-237, code point, and the code unit 0 times 007d, right curly bracket, the TRV of hex 4 digits. Hex digit is the string concatenation of the TRV of the first hex digit, the TRV of the second hex digit, the TRV of the third hex digit, and the TRV of the fourth hex digit. The TRV of hex digits. Hex digit is the string concatenation of the TRV of hex digits and the TRV of hex digit. The TRV of hex digit. 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 A B C D E F. A B C D E F is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of line continuation. Line terminator sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of line terminator sequence. The TRV of line terminator sequence, LF, is the string value consisting of the code unit 0 times 000 line feed. The TRV of line terminator sequence, CR, is the string value consisting of the code unit 0 times 000 line feed. The TRV of line terminator sequence, LS, is the string value consisting of the code unit 0 times 2028 line separator. The TRV of line terminator sequence, PS, is the string value consisting of the code unit 0 times 2029 paragraph separator. The TRV of line terminator sequence, CRLF, is the string value consisting of the code unit 0 times 000 line feed. 2.10 automatic semicolon insertion. Most ECMA script statements and declarations must be terminated with a semicolon. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. 2.10.1 Rules of automatic semicolon insertion. In the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are 3 basic rules of semicolon insertion. When, as the source text is passed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar, then a semicolon is automatically inserted before the offending token if one or more of the following conditions is true. The offending token is separated from the previous token by at least one line terminator. The offending token is, the previous token is, and the inserted semicolon would then be passed as the terminating semicolon of a do-while statement 147. 2. When, as the source text is passed from left to right, the end of the input stream of tokens is encountered, and the parser is unable to parse the input token stream as a single instance of the goal non-terminal, then a semicolon is automatically inserted at the end of the input stream. When, as the source text is passed from left to right, a token is encountered that is allowed by some production of the grammar, that the production is a restricted production and the token would be the first token for a terminal or non-terminal immediately following the annotation, no line terminator here, within the restricted production, and therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line terminator, then a semicolon is automatically inserted before the restricted token. Note TV excludes the code units of line continuation while TRV includes them. CR, LF, and CR line terminator sequences are normalized to LF for both TV and TRV. An explicit template escape sequence is needed to include a CR or CR, LF. Sequence 38, ECMA International 2024. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted automatically if the semicolon would then be passed as an empty statement or if that semicolon would become one of the two semicolons in the header of a for statement C14. 7. 4. Note the following are the only restricted productions in the grammar. Update expression, yield, await. Left-hand side expression yield await. No line terminator here. Plus left-hand side expression yield await. No line terminator here. Continue statement, yield, await. Continue. Continue. No line terminator here. Label identifier yield await. Break statement, yield, await. Break, break. No line terminator here. Label identifier yield await. Return statement, yield, await. Return, return. No line terminator here. Expression, plus and yield await. Throw statement, yield, await. Throw, no line terminator here. Expression, plus and yield await. Yield expression, in, await. Yield, yield. No line terminator here. Assignment expression in, plus yield await. Yield, no line terminator here. Assignment expression in, plus yield await. Arrow function, in, yield, await. Arrow parameters yield await. No line terminator here, equals. Concise body in, async function declaration. Yield, await. Default, async. No line terminator here. Function binding identifier yield await. Formal parameters. Yield, plus await. Async function body, plus default. Async. No line terminator here. Function. Formal parameters. Yield, plus await. Async function body. Async function expression. Async. No line terminator here. Function binding identifier. Yield, plus await opt. Formal parameters. Yield, plus await. Async function body. Async method. Yield, await. Async. No line terminator here. Class element name yield await. Unique formal parameters. Yield, plus await. Async function body. Async generator declaration. Yield, await. Default. Async. No line terminator here. Function binding identifier yield await. Formal parameters. Plus yield. Plus await. Async generator body. Plus default. Async. No line terminator here. Function. Formal parameters. Plus yield. Plus await. Async generator body. Async generator expression. Async. No line terminator here. Function binding identifier. Plus yield. Plus await opt. Formal parameters. Plus yield. Plus await. Async generator body. Async gener. At a method. Yield. Await. Async. No line terminator here. Class element name yield await. Unique formal parameters. Plus yield. Plus await. Async generator body. Async arrow function. In. Yield. Await. Async. No line terminator here. Async arrow binding identifier yield. No line terminator here. Equals. Async concise body in. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R yield await. No line terminator here equals async concise body in ECMA International 2024 239 async arrowhead async. No line terminator here. Arrow formal parameters yield plus await. The practical effect of these restricted productions is as follows. When a plus plus or token is encountered where the parser would treat it as a postfix operator, and at least one line terminator occurred between the preceding token and the plus plus or token, then a semicolon is automatically inserted before the plus plus or token. When a continue, break, return, throw, or yield token is encountered and a line terminator is encountered before the next token, a semicolon is automatically inserted after the continue, break, return, throw, or yield token when arrow function parameter s are followed by a line terminator before it equals token. A semicolon is automatically inserted and the punctuator causes a syntax error. When an async token is followed by a line terminator before a function or identifier name or token, a semicolon is automatically inserted and the async token is not treated as part of the same expression or class element as the following tokens. When an async token is followed by a line terminator before a token, a semicolon is automatically inserted and the punctuator causes a syntax error. The resulting practical advice to ECMA script programmers is a postfix plus plus or operator should be on the same line as its operand. An expression in a return or throw statement or an assignment expression in a yield expression should start on the same line as the return, throw, or yield token. A label identifier in a break or continue statement should be on the same line as the break or continue token. The end of an arrow function's parameter s and its equals should be on the same line. The async token preceding an asynchronous function or method should be on the same line as the immediately following token. 2, 1, 0. Two examples of automatic semicolon insertion. This section is non-normative. The source, 12, 3, is not a valid sentence in the ECMA script grammar, even with the automatic semicolon insertion rules. In contrast, the source, 1, 2, 3, is also not a valid ECMA script sentence, but is transformed by automatic semicolon insertion into the following 1, 2, 3, which is a valid ECMA script sentence. The source, 4, A, B, 40, copyright sign, ECMA International 2024, is not a valid ECMA script sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source, return, a plus b, is transformed by automatic semicolon insertion into the following. Return, a plus b. The source, up equals b plus plus c, is transformed by automatic semicolon insertion into the following. Up equals b plus plus c. The source, if B else C equals D, is not a valid ECMA script sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point. Because an automatically inserted semicolon would then be passed as an empty statement. The source, up equals B plus C, D plus C print, is not transformed by automatic semicolon insertion, because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call, up equals B plus C, D plus E print. In the circumstance that an assignment statement must begin with a left parenthesis, it is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. 2, 1, 0. 3 interesting cases of automatic semicolon insertion. This section is non-normative. Note 1. The expression a plus b is not treated as a value to be returned by the return statement, because a line terminator separates it from the token return. Note 2. The token plus plus is not treated as a postfix operator applying to the variable b, because a line terminator occurs between B and ++. ECMA International 2024-241. ECMA script programs can be written in a style with very few semicolons by relying on automatic semicolon insertion. As described above, semicolons are not inserted at every new line, and automatic semicolon insertion can depend on multiple tokens across line terminators. As new syntactic features are added to ECMA script, additional grammar productions could be added that cause lines relying on automatic semicolon insertion preceding them to change grammar productions when parsed. For the purposes of this section, a case of automatic semicolon insertion is considered interesting if it is a place where a semicolon may or may not be inserted, depending on the source text which precedes it. The rest of this section describes a number of interesting cases of automatic semicolon insertion in this version of ECMA script. 2.1.0.3. 1 interesting cases of automatic semicolon insertion in statement lists. In a statement list, many statement list items end in semicolons, which may be omitted using automatic semicolon insertion. As a consequence of the rules above, at the end of a line ending an expression, a semicolon is required if the following line begins with any of the following: an opening parenthesis. Without a semicolon, the two lines together are treated as a call expression, an opening square bracket. Without a semicolon, the two lines together are treated as property, access, rather than an array literal or array assignment pattern, a template literal. Without a semicolon, the two lines together are interpret it as a tag template. The 13th of March 2011, with the previous expression as the member expression, unary plus or. Without a semicolon, the two lines together are interpreted as a usage of the corresponding binary operator, a regexp literal. Without a semicolon, the two lines together may be parsed instead as the multiplicative operator. For example, if the regexp has flags 2, 1, 0, 3, 2 cases of automatic semicolon insertion and no line terminator here. This section is non-normative. ECMA script contains grammar productions which include no line terminator here. These productions are sometimes a means to have optional operands in the grammar. Introducing a line terminator in these locations would change the grammar production of a source text by using the grammar production without the optional operand. The rest of this section describes a number of productions using no line terminator here in this version of ECMA script. 2.1.0.3.2. 1 list of grammar productions with optional operands and no line terminator here. Update expression, continue statement, break statement, return statement, yield expression, async function definitions, 15.8, with relation to function definitions, 15.2. 42. ECMA International 2024, 13 ECMA script language. Expressions, 3.1 identifier syntax, identifier reference, yield, await, identifier, yield, yield, await, await, binding identifier, yield, await, identifier, yield, await, label identifier, yield, await, identifier, yield, yield, await, await, identifier, identifier name but not reserved word. 3. 1. 1 static semantics, early errors, binding identifier, identifier. It is a syntax error if the source text matched by this production is contained in strict mode code and the string value of identifier is either arguments or eval. Identifier reference, yield binding identifier, yield label identifier, yield. It is a syntax error if the source text matched by this production is contained in strict mode code. Identifier reference, await binding identifier, await label identifier, await. It is a syntax error if the goal symbol of the syntactic grammar is module. Binding identifier, yield, await, yield. It is a syntax error if this production has a yield parameter. Binding identifier, yield, await, await. ECMA International 2024-243. Yield and await are permitted as binding identifier in the grammar and prohibited with static. Note, semantics below. To prohibit automatic semicolon insertion in cases such as let await 0, it is a syntax error if this production has an await parameter. Identifier reference, yield, await, identifier binding identifier, yield, await, identifier label identifier, yield, await, identifier. It is a syntax error if this production has a yield parameter and string value of identifier as yield. It is a syntax error if this production has an await parameter and string value of identifier as await. Identifier. Identifier name but n but reserved word. It is a syntax error if this phrase is contained in strict mode code and the string value of identifier name is one of implements, interface, let, package, private, protected, public, static, or yield. It is a syntax error if the goal symbol of the syntactic grammar is module and the string value of identifier name is await. It is a syntax error if the string value of identifier name is the string value of any reserved word except for yield or await. 3. 1. 2 static semantics. String value. The syntax-directed operation string value takes no arguments and returns a string. It is defined piecewise over the following productions. Identifier name, identifier start, identifier name, identifier part. Let id text unescape be identifier code points of identifier name, return code points to string. Id text unescaped, identifier reference, yield binding identifier, yield label identifier, yield, return yield, identifier reference, await binding identifier, await label identifier, await, return await, identifier, identifier name but not reserved word, return the string value of identifier name, private identifier, identifier name, return the string concatenation of 0 times 0023, number sign, and the string value of identifier name, module export name, string literal 1. Return the SV of string literal. Note string value of identifier name normalizes any Unicode escape sequences in identifier name, hence such escapes cannot be used to write an identifier whose code point sequence is the same as a reserved word. 44. ECMA International 2024. 1.3. 1. 3 runtime semantics. Evaluation. Identifier reference. Identifier. Return. Resolve binding. String value of identifier, identifier reference, yield, return, resolve binding, yield, identifier reference, await, return, resolve binding, await. Note 1. The result of evaluating an identifier reference is always a value of type reference. 3.2 Primary expression syntax. Primary expression, yield, await. This identifier reference yield await, literal, array literal yield await, object literal yield await, function expression, class expression yield await, generator expression, async function expression, async generator expression, regular expression literal, template literal yield await, tagged, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield await, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield, await, expression, plus and yield await, expression, plus and yield await, dot, binding identifier yield await, dot, binding pattern yield await, expression, plus and yield await, binding identifier yield await, expression, plus and yield await, binding pattern yield await. Note 2. In non-strict code, the keyword yield may be used as an identifier. Evaluating the identifier reference resolves the binding of yield as if it was an identifier. Early error restriction ensures that such an evaluation on, like can occur for non-strict code. ECMA International 2024-245. Supplemental syntax. When processing an instance of the production, primary expression, yield, await, capital C O V E R, capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N yield await. The interpretation of capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N is refined using the following grammar. Parenthesized expression yield await expression plus in yield await 3 2 1 at this keyword 3 2 1 runtime semantics evaluation primary expression this return resolve this binding 3 2 2 identifier reference C13.1 for identifier reference 1 3 2 3 literals syntax literal null literal boolean literal numeric literal string literal 3 2 3 1 runtime semantics evaluation literal null literal 1 return null literal boolean literal if boolean literal is the token false return false if boolean literal is the token true return true literal numeric literal return the numeric value of numeric literal as defined in 1 2 9 3 literal string literal return the SV of string literal as defined in 1 2 9 4 2 46 ECMA International 2024 1 3 2 4 array initializer array elements may be elided at the beginning middle or end of the element list whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma. The missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax array literal yield await elision ought element list yield await element list yield await elision ought element list yield await elision ought assignment expression plus in yield await elision ought spread element yield await element list yield await elision ought assignment expression plus in yield await element list yield await elision ought spread element yield await elision spread element yield await dot assignment expression plus in yield await 1 3 2 4 1 runtime semantics array accumulation the syntax directed operation array accumulation takes arguments array an array and next int x an integer and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision let len be next index plus 1 perform set array length len true note the above step throws if len exceeds 232 1 return len elision return array accumulation of elision with arguments array and next index plus 1 element list elision ought assignment expression if elision is present then a set next index 2 array accumulation of elision with arguments array and next index let init result be evaluation of assignment expression let init value be get value init result perform create data property or throw array to string next int x init value return next index plus 1 note an array literal is an expression describing the initialization of an array using a list of 0 or more expressions each of which represents an array element enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247 argument raw. Let last be template string, template middle, raw. Return the list concatenation of front and last. 3, 2, 8, 3 static semantics, template string, template token, raw. The abstract operation template string takes arguments template token, a no substitution template parse node, a template head parse node, a template middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called. If raw is true, then a let string be the TRV of template token, else a let string be the TV of template token, return string. 3, 2, 8, 4 get template object, template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called. Let realm be the current realm record. Let template registry be realm for each element of template registry. Do if E is the same parse node as template literal, then I return E. Let raw strings be template strings of template literal with argument true. Assert raw strings is a list of strings. Let cook strings be template strings of template literal with argument false. Let count be the number of elements in the list cook strings. Assert count 232 1. Let template be array create count 0. Let raw obj be array create count 1. Let index be 0, 2. Repeat while int x count a let prop be to string index be let cooked value be cooked strings index c perform define property or throw template prop property descriptor cooked value writable false true false d let raw value be the string value raw strings index e perform define property or throw raw obj prop property descriptor raw value false true false f set index plus 1 3 perform set integrity level raw obj frozen 4 perform define property or throw template raw property descriptor raw obj false enumerable false false 5 frozen 6 append the record template literal template to realm 7 return template. Note this operation returns undefined if raw is false and template token contains a not escape sequence. In all other cases, it returns a string. ECMA International 2024-255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the evaluation of tag templates. 1 3 2 8 6. The template objects are frozen and the same template object is used each time a specific tag template is evaluated. Whether template objects are created lazily upon first evaluation of the template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMA script code. 1 3 2 8 5 Runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMA script language values or an abrupt completion. It is defined piecewise over the following productions. Template spans. Template tail. Return a new empty list. Template spans. Template middle list. Template tail. Return. Substitution evaluation of template middle list. Template middle list. Template middle expression. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Return sub. Template middle list. Template middle list. Template middle expression. Let precede and be. Substitution evaluation of template middle list. Let next ref be. Evaluation of expression. Let next be. Get value. Next ref. Return the list concatenation of preceding and next. 3 2 8 6 Runtime semantics. Evaluation. Template literal. No substitution template. Return the TV of no substitution template as defined in 1 2 9 6. Substitution template. Template head expression. Template spans. Let head be the TV of template head as defined in 1 2 9 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Let tail be. Evaluation of template spans. Return the string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3. Future editions of this specification may define additional non-enumerable properties of template objects. Note 1. The string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Template spans. Template tail. Return the TV of template tail as defined in 1 2 9 6. Template spans. Template middle list template tail. Let head be. Evaluation of template middle list. Let tail be the TV of template tail as defined in 1, 2, 9, 6. Return the string concatenation of head and tail. Template middle list. Template middle expression. Let head be the TV of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Return the string concatenation of head and middle. Template middle list. Template middle list. Template middle expression. Let rest be. Evaluation of template middle list. Let middle be the TV of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let last be. To string. Sub. Return the string concatenation of rest, middle, and last. 3, 2, 9. The grouping operator. 3, 2, 9. 1. Static semantics. Early errors. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Must cover a parenthesized expression. 3, 2, 9. 2. Runtime semantics. Evaluation. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Return. Evaluation of expa parenthesized expression. Expression. Return. Evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note 3. The string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type off may be applied to parenthesized expressions. ECMA International 2024 257. 13.3 left-hand side expression syntax. Member expression, yield, await. Primary expression yield await. Member expression yield await. Expression, plus and yield await. Member expression yield await. Identifier name member expression yield await. Template literal yield await. Plus tagged super property yield await. Meter property. New member expression yield await. Arguments yield await. Member expression yield await. Private identifier super property yield await. Super expression plus and yield await. Super. Identifier name meter property. New target. Import meter new target. New target. Import meter. Import meta. New expression yield await. Member expression yield await. New expression yield await. Call expression yield await. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Yield await. Super call yield await. Import call yield await. Call expression yield await. Arguments yield await. Call expression yield await. Expression plus and yield await. Call expression yield await. Identifier name call expression yield await. Template literal yield await. Plus tagged call expression yield await. Private identifier super call yield await. Super arguments yield await. Import call yield await. Import assignment expression plus and yield await. Arguments yield await. Argument list yield await. Argument list yield await. 58. ECMA International 2024. Argument list yield await. Assignment expression plus and yield await. Dart. Assignment expression plus and yield await. Argument list yield await. Assignment expression, plus and yield await. Argument list yield await. Assignment expression, plus and yield await. Optional expression, yield await. Member expression yield
This is kind of like struct hell.
yield await.
This is terrible.
Optional chain yield await. Optional chain yield await. Arguments yield await. Expression plus in
So, I don't know.
template literal yield await plus tagged. Private identifier. Optional chain yield await. Arguments yield await. Optional chain yield await. Expression plus and yield await. Optional chain yield await. Identifier name. Optional chain yield await. Template literal yield await. Tagged. Optional chain yield await. Private identifier. Left-hand side expression. Yield await. New expression yield await. Call expression yield await. Optional expression yield await. Supplemental syntax. When processing an instance of the production, call expression capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. The interpretation of capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A Y
I'm like planning to like
capital A R R
break it down and move the structs
expression yield await
into
arguments
the pipeline info struct,
semantics 3
because this is a struct that's actually like passed in
optional chain template literal
to this function, whatever, that does create the graphics pipeline.
matched by this production ECMA International 2024 259. Note this production
That's tied to the logical device.
version rules 12.10 from being applied to the following code A B C so that it would be interpreted as to
And graphics pipeline is passed in.
maintain consistency with similar code without optional chaining A B C, which is a valid statement and where automatic
That's a sign, I guess, result.
import meta. It is a syntax error if the syntactic goal symbol is not module 1.3.3 to property accessors. Note properties are accessed by name using either the dot notation, member expression, identifier name call expression, identifier name or the bracket notation, member expression, expression, call expression, expression. The dot notation is explained by the following syntactic conversion. Member expression, identifier name is identical in its behavior to member expression, identifier name string, and similarly, call expression, identifier name is identical in its behavior to call expression, identifier name string, where identifier name string is the result of evaluating string value of identifier name. 3, 2, 1 runtime semantics.
And then I guess the graphics pipeline
Expression, let base reference be E,
is binded
let base value be get value, base reference, if the source text matched by the
to the command buffers.
code.
So multiple command buffers
Turn, capital E,
have the same graphics pipeline.
A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital E, X, P,
So it's just a pointer.
expression, strict, 60,
It's not really binding.
and 24, member expression, identifier name, let base reference be, evaluation of member expression, let base value be, get value, base reference, if the source text
But then it's not just this. Of course, there's like another piece to it.
true, else let strict be, false, return, capital E, V, A, L,
So there's the frame buffers.
P, E, capital P, R, O, P, E,
What the heck is a frame buffer?
Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E,
This is by
U,
value, I think, passed around.
expression, member expression, private
It's assigned to malloc.
reference B, evaluation of member expression, let base value be,
Access by indice.
base reference, let field name string be the string value of private identifier, return make private reference, base value, field name string, call expression, expression, let base reference be, evaluation of call expression, let base value be, Get value, base reference. If the source text match call expression is strict mode code, let strict be true, else let strict be false. Return.
Why make this malloc?
E-A-L-U-A-T-E, capital P-R-O-P-E-R-T-Y, capital A-C-C-E-S-S, capital W-I-T-H, capital E-X-P-R, base value, expression, strict, call expression, identify a name, let base reference be.
So whatever render pass info is.
Get value, base reference. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. Return.
Takes the address.
V-A-L-U.
It's on the stack.
E-E.
It's the only way to pass it in.
E-R-O-P-E-R-T-Y, capital A-C-C-E-S-S, capital W-I-T-H, capital I-D-E-N, base value, identify a name, strict, call expression, private identifier, let base reference be. Evaluation of call expression, let base value be.
Subpass contents inline.
Field name string be the string value of private identifier.
Command buffers.
Base value, field name string, 3, capital E-V-A-L-U-A-T-E, capital P-R-O-P-E-R-T-Y, capital.
This is a define, I think.
E,
Like literal.
capital W,
Intermediate.
T,
Possibly.
capital E, X, P, R, base value, express.
Does that mean
The abstract operation, capital E,
render pass info is assigned?
U, A,
It can't be. It has to be assigned to command buffer.
R, O, P, E,
Why can't
Y, capital A, C,
this crap
S, S, capital W,
have a system to it? This is ridiculous.
X, P,
Freaking organize it left to right, right to left.
expression, an expression,
So fucking annoying.
limb, and returns I,
This is so annoying.
abrupt completion. It performs
God.
when called. Let property name reference be. If let property name value be. Get value. Name reference.
If the right hand side, all the way to the right, is going to be assigned,
Reference record.
why the fuck is a literal all the way on the right?
3,
Fucking flip it around or some shit. This is so annoying.
L, U,
I just want to read this and figure it out.
P,
I don't want to read it
O, P,
and piece everything back together wherever the fuck it's supposed to go.
A,
It's wasting my time.
E, S, S, capital W,
Like, come up with the convention and follow it through the whole thing.
D,
This is so annoying.
base value, identify a name, strict, the abstract operation, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E,
And then this one,
E, Y, capital A, C, C, E, S, S, capital W, I, T, H,
I would assume the right hand side
E, F,
is being assigned,
space value,
but really it's being assigned to left.
value, identify a name, an identify name parse node, and strict, a boolean, ND returns a reference record.
But like for this one,
Following steps when called. Let property name string be string value of identify name. Return the reference record. Base value.
the thing on the left is being assigned.
Empty. ECMA International 2024 261. 133. 5 Venue operator. 3. 5. 1 runtime semantics. Evaluation. New expression. New expression. Return. Evaluate new. New expression. Empty. Member expression. New member expression. Arguments 1. Return. Evaluate new. Member expression. Arguments. 3.
I hate chatbot.
1. Evaluate new. Construct expr. Arguments. The abstract operation of
Chatbot said
expr. A new
the thing on the right
member expression parse node.
is generally what's assigned.
Arguments parse node.
That's totally not even.
An ECMA script.
God.
Abrupt completion. It performs the
I'm gonna waste time asking chatbot another question.
of construct expr. Let construct to be. Get value. Ref. If arguments is empty, then a let arglist be new empty list 4. Else a let arglist be. Argument list evaluation of arguments. If this constructor is false, Throw a type error exception. Return. Construct. Constructor. Arglist. 3, 3, 6 function calls. 3, 3, 6. 1 runtime semantics. Evaluation. Call expression. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R.
So I'm asking, the Vulkan calls is argument furthest to the left or right, the arg that the rest of the parameters are being applied to.
L. Capital E X P R E S S I O N. Capital A N D. Capital A
The argument
Y N C.
is on the left? Okay.
R. Let member expa be the member expression of expa. Let arguments be the arguments of expa. Let ref be evaluation of member expa. Let func be get value ref. If ref is a reference record, is property reference, ref is false, and ref is eval, then if same value
Well, chatbot told me
percent is true.
that device gets passed in to the buffer.
Evaluation of arguments. 2.
That was really confusing.
Turn undefined. 3. Let eval.
So that makes a lot more sense.
5. If the source text matched by this call expression is strict mode code, let strict caller be true, otherwise let strict caller be false. V return. Perform eval. Eval arg. Strict caller. True. Let this call be this call expression. Let tail call be as in tail position. This call. Return. Evaluate call. Func. Ref. Arguments. Tail call. A call expression evaluation that executes.
I was here, so undo.
Eval. Call expression. Call expression arguments. Let ref be. Evaluation of call expression. Let func be. Get value. Ref. Let this call be this call expression. Let tail call be as in tail position. This call. Return. Evaluate call. Func. Ref. Arguments. Tail call. 62. ECMA International 2024. 1336. 2. Evaluate call. Func. Ref. Arguments. Tail position. The abstract operation evaluate call takes arguments func. An ECMA script language value. Ref. An ECMA script language value or a reference record. Arguments. A parse node. And tail position. A boolean. And returns either a norma L completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. If ref is a reference record, then if is property reference, ref is true, then I let this value be get this value, ref be else. I let ref env be ref. 2. Assert. Ref env is an environment record. 3. Let this value be ref env with base object. Else. Let this value be undefined. Let arglist be argument list evaluation of arguments. If func is not an object, throw a type error exception. If is callable, func is false. Throw a type error exception. If tail position is true, perform prepare for tail call. Return. Call. Func. This value. Arglist. 3, 3, 7th decimal.
Okay, so P stages and stages count.
Time semantics. Evaluation super property. Super. Expression. Let env get this environment.
Can I make a temp fair?
Get this binding. Let property name reference be. Evaluation of expression. Let property name value be. Get value. Property name reference. Let property key be. To property key. Property name value. If the source text matched by the super property is strict mode code, let strict be true, else let strict be false. Return. Make super property reference. Actual this. Property key. Strict. Super property. Super. Identify name. Let env get this environment. Let actual this be env get this binding. Let property key be string value of identify name. If the source text matched by the super property is strict mode code, let strict be true, else let strict be false. Return. Make super property reference. Actual this. Property key. Strict. Super call. Super arguments. Let new target be get new target. Assert. New target is an object. Let func be get super constructor. Let arglist be argument list evaluation of arguments. If this constructor, func, is false, throw a type error exception. Let result be construct.
Alright, will this work?
New target. Let the ser be get this environment. Perform the ser bind this value. Result. Let f be the ser. 0. Assert. F is an ECMA script function object. 1. Perform. Initialize instance elements. Result. F2. Return result. ECMA International 2024 263 1337. To get super constructor. The abstract operation get super constructor takes no arguments and returns an ECMA script language value. It performs the following steps when called. Let envrec be get this environment. Assert. envrec is a function environment record. Let active function be envrec. Assert. Active function is an ECMA script function object. Let superconstruct to be active function. Return superconstructor. 3, 3, 7, 3 make super property reference. Actual this. Property key. Strict. The abstract operation make super property reference takes arguments actual this. An ECMA script language value. Property key. A property key. And strict. A boolean. And return.
This is probably a 3-digit number.
Reference record or a throw completion. It performs the following steps when called. Let env get this environment. Assert. Env has superbinding. Is true. Let base value be env get superbase. Return the reference record. Base value. Property key. Strict. This value. Actual this. 3, 3, 8 argument lists. Note the evaluation of an argument.
Alright, so now if this works,
3, 3, 8.
then stage create info
List evaluation.
can be variable size, whatever.
And takes no argument.
Define them in the list.
ECMA script language.
Then this counter increments.
It is defined piece.
It should be 2 down here.
Return a new empty list. Argument list. Assignment expression. Let ref be. Evaluate.
Or not. I don't know. Guess I'll find out.
Get value. Ref. Return arg. Argument list. Assignment expression. Let list be new empty.
And
B. Evaluation of assignment expression. Let spread objb. Get value. Spread ref. Let iterator record b. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. B if next is.
you end like that? Really?
Argument list. Argument list. Assignment expression. 1, 2. Let preceding args be. Argument list evaluation of argument list. Let ref be.
Oh, maybe like that.
Expression. 64. ECMA International 2024. 3. Let arg be. Get value. Ref. Return the list concatenation of preceding args and arg. Argument list. Argument list. Assignment expression. Let preceding args be. Argument list evaluation of argument list. Let spread ref be. Evaluation of assignment expression. Let iterator record be. Get iterator. Get value. Spread ref. Sync. Repeat. Let next be. Iterator step value. Iterator record. B if next is done. Return preceding args. C append next to preceding args. Template literal. No substitution template. Let template literal be this template literal. Let cite obj be get template object. Template literal. Return cite obj. Template literal. Substitution template. Let template literal be this template literal. Let cite obj be get template object. Template literal. Let remain in B. Argument list.
What's wrong with this?
Substitution template. Return
Oh my god.
bj and
It's lowercase?
template. Template head expression template spans. Let first subref be. Evaluation of expression. Let first sub be. Get value. First subref. Let rest sub be. Substitution evaluation of template spans. Assert. Rest sub is a possibly empty.
Yeah, I don't think that worked.
Of first sub and rest sub. 3, 3, 9 optional chains. 3, 3, 9. 1 runtime semantics. Evaluation.
It didn't work.
Expression optional chain. Let base reference be. Evaluation of member expression. Let base value be. Get value. Base refer. Ends. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Optional expression. Call expression optional chain. Let base reference be. Evaluation of call expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Note an optional chain is a chain of one or more property accesses and function calls, the first of which begins with the
Let's check out.
National 2024-265. Optional expression. Optional expression. Optional chain. Let base reference be. Evaluation of optional expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. 3, 3, 9. 2 runtime semantics. Chain evaluation. The syntax directed operation chain evaluation takes arguments base value, an ECMA script language value, and base reference, an ECMA script language value or a reference record, and returns either a normal completion containing either an ECMA script language value or a reference record, or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Arguments. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. Base value. Base reference. Arguments. Tail call. Optional chain. Expression. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict optional chain. Identifier name. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital
Alright, what about this though?
E N base value identifier name strict optional chain. Private identifier. Let field name string be the string value of private identifier. Return make private reference. Base value. Field name string. Optional chain. Optional chain arguments. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. New value. New reference. Arguments. Tail call. Optional chain. Optional chain. Expression. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Either L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E
I'll see if it builds.
R E S S new value expression strict optional chain identifier name. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference.
Nope, doesn't work.
Value new reference. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S
Alright, we'll pull this one here.
U I T H capital I D E N new value identifier name strict
Yes.
international 2024 optional chain
What about this?
private identifier. Let optional chain be
Yes or no?
reference B. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. Let field name string be the string value of private identifier. Return make private reference. New value.
Man.
Of March 2010 import calls. 3, 3, 1, 0, 1 runtime semantics. Evaluation. Import call. Import. Assignment expression. Let referrer be get active script or module. If referrer is null, set referrer to the current realm record. Let rgraph be. Evaluation of assignment expression. Let specify be. Get value. rgraph. Let promise capability be. New promise capability. Promise %. Let specifier string be completion. To string. Specifier. If abrupt reject promise. Specifier string. Promise capability. Perform host load imported module. Referrer. Specifier string. Empty. Promise capability. Return promise capability. 3, 3, 1, 0, 1. 1 continue dynamic import. Promise capability. Module completion. The abstract operation continue dynamic import takes arguments promise capability, a promise capability record, and module completion, either a normal completion containing a module record or a throw completion, and returns unused. It completes the process of a dynamic import originally started by an import call, resolving or rejecting the promise returned by that call as appropriate. It performs the following steps when called. If module completion is an abrupt completion, then perform call promise capability undefined. Module completion be return unused. Let module be module completion. Let load promise be module load requested modules. Let rejected closure be a new abstract closure with parameters reason that captures promise capability and performs the following steps when called. Perform call promise capability undefined. Reason be return unused. Let onRejected be create built-in function. Rejected closure 1. Let link and evaluate closure be a new abstract closure with no parameters that captures module promise capability and onRejected and performs the following steps when called. Let link be completion. Module link be if link is an abrupt completion, then I perform call promise capability undefined. Link 2. Return unused. See let evaluate
Will this work?
T let fulfilled closure be a new abstract closure with no parameters that captures module and promise capability and performs the following steps when called. I let namespace be get module namespace, module 2, perform, call, promise capability, undefined, namespace 3, return unused. E let unfulfilled be create built-in function, fulfilled closure 0, F perform promise then, evaluate promise, unfulfilled, unrejected. G return unused. Link and evaluate be create built-in function, link and evaluate closure 0, let perform promise then, load promise, link and evaluate, unrejected. Return unused. ECMA International 2024 267. The 13th of March
We have a winner.
3, 3, 1, 1, 1 runtime semantics, evaluation, member expression template literal, let tag ref be, evaluation of member expression, let tag func be, get value, tag ref, let this call be this member expression, let tail call be as in tail position, this call, return, evaluate call, tag func, tag ref, template literal, tail call expression template literal, let tag ref be, evaluation of call expression, let tag func be, get value, tag ref, let this call be this call expression, let tail call be as in tail position, this call, return, evaluate call, tag func, tag ref, template literal, tail call, the 3rd of March 2012 meta properties, 3, 3, 1, 2, 1 runtime semantics, evaluation, new target 1, return get new target, import meter, import meta, let module be get active script or module, assert, module is a source text module record, let import meter be module, if import meter is empty, then a set import meter to ordinary object create, null, b let import meter values be host get import meter properties, module, c for each record, p of import meter values, do, I perform, create data property or throw, import meter, p, d perform host finalize import meter, module, e set module to import meter, f return import meter, else, a assert, import meter is an object, b return import meter, 3, 3, 1, 2, 1, 1 host get import meter properties, module record, the host.
The whole point is to not hard code it. It's fucking annoying.
A module record, and returns a list of records with fields, any CMA script language value. It allows hosts to provide property keys and values for the object returned from.
Okay, so size of
Implementation of host get import meter properties is to return a new empty list. Note attack template is a function call where the arguments of the call are derived from a template literal 1, 3, 2, 8. The actual arguments include a template object 1, 3, 2, 8, 4, and the values produced by evaluating the expressions embedded within the template literal 68. Copyright sign, ECMA International 2024, 1, 3, 3, 1, 2, 1, 2 host finalize import meter.
oh yeah.
Module record, the host defined abstract operation host finalize import meter takes arguments import meter, an object, and module record, a module record.
This seemed like hacky last time, but it makes sense.
Operations to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties, and leave host finalize import meter with its default behavior. However, host finalize import meter provides an escape hatch for hosts which need to directly manipulate the object before it is exposed to ECMA script code. The default implementation of host finalize import meter is to return unused. 3.4 Update expression syntax. Update expression, yield, await, left-hand side expression yield await, left-hand side expression yield await, left-hand side expression yield await, plus unary expression yield await, unary expression yield await, 1, 3, 4, 1 static semantics, early errors,
Right? I'm pretty sure that.
side expression plus, no line terminator here, plus, no line terminator here, left-hand side expression. It is an early syntax error if assignment target type of left-hand side expression is not simple. Update expression plus unary expression, It is an early syntax error if assignment target type of unary expression is not simple. 3, 4, 2 postfix increment operator 1, 3, 4, 2, 1 runtime semantics, evaluation, update expression, left-hand side expression plus, let LHS be. Evaluation of left-hand side expression, let old value be. To numeric, get value, LHS. If old value is a number, then let new value be number, add, old value, 1, else, assert, old value is a bigint, b let new value be bigint, add, old value, 1z, perform, put value, LHS, new value, return old value.
Is this valid? C. What do the standards say about taking the size of a compound literal? It says it's valid in C99 later, but it does not do what you expect, what you might expect. What the C standard says, compound literals and size of operator. It's valid, you can't apply size of to a compound literal. This is explicitly permitted. But the type of the compound literal is the pointer to the first element of an unnamed array. Not an array type anymore when passed in. I'll print this to see. What if I cast it to a union? Is that possible? Let's try this first. You really get 96? I got 2. I'm pretty sure that means it works. Okay, what about this? I'll do size of compound literal. Divided by size of compound literal. And select the 0th. See what Chepa has to say about that. And that's easier to type anyways. It's 2, like it's supposed to be. So instead I'll paste this here and do this. Ta-da! Will I make Chepa happy? So this is perfect. Question mark. You're very close, but this line is not valid in the way you're using it. It's a macro that expands to a compound literal. And the size of compound literal gives you the size of a pointer. No, it doesn't. Not the size of the array. It's not. It's giving me the size of the array. Then why the fuck is the count right? Tell me, chatbot. Tell me that I'm wrong. It says this will result in 0 on most systems or 1 on 64-bit, but never the correct count 2. Oh, and then it says to do it externally. This is the same fucking thing. It's elegant in theory, but because of how compound literals decay to pointers. No, it doesn't decay because it has not been assigned to anything other than nothing, because it's still a compound fucking literal. Is Shepard stupid? Holy fuck. We need to rewrite it like this. So this is the bee's knees. How is it not correct? It doesn't decay. Oh my god. Then why is it returning 2? Using a union is fully standard, clean, portable way to preserve the array and get the count. This doesn't really help. Yeah, this won't work. why is Chatbot doing this? Chatbot told me this does not work. And now it's doing exactly what I did. And it's like, oh, do this. Motherfucker. That's literally what I said to do, and you're like, it's like, oh, that's not safe. For fuck's sake. It doesn't build. Wait it to build. Uh-oh. Well, that was not good. I thought the computer crashed. This gives me 8 now. This here gives me 8. Oh, it gives me 48. what about this? I want like a solid solution to use everywhere. Save me so much time. Save me a lot of time. This is why Microsoft needs to go out of business. It's just annoying to always account for like an out-of-date, crappy operating system all the time. Alright, so I'm gonna do what technically may not work in Visual Studio because I don't care. I think I'm done with Microsoft. That's why I'm going over to Linux. And if other compilers do it, but Microsoft doesn't, well, I don't know. Fuck Microsoft. Because it's just ridiculous to do it on purpose. Alright, so I'm gonna be clever and get the fucking count that way, the way earlier. I'm gonna do that everywhere. It's gonna save me time. It's gonna be awesome.
If iterator record is false, then let next be. Iterator step value, iterator record, B if next is not done, then I set value to next. If initializer is present and value is undefined, then if is anonymous function definition, initializer is true and is identifier ref of destructuring assignment target is true, then I let VB. Named evaluation of initializer with argument ref B else, I let default value be. Evaluation of initializer 2. Let VB. Get value, default value, else a let VB value. If destructuring assignment target is either an object literal or an array literal, then a let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target be return. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T, of nested assignment pattern with argument V, return. Put value, ref, V, assignment rest element. Destructuring assignment target. If destructuring assignment target is neither an object literal nor an array literal, then let ref B. Evaluation of destructuring assignment target. Let A be. Array create. 0. Let 0. Repeat. While iterator record is false, let next be. Iterator step value. Iterator record. B if next is not done, then I perform. Create data property or throw A to string n next 2. Set n to n plus 1. If destructuring assignment target is neither an object literal nor an array literal, then a return. Put value ref A. Let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target. Return. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T, of nested assignment pattern with argument A, 3, 1, 5, 5, 6 runtime semantics, capital K, E, Y, E, D, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V. The syntax directed operation, capital K, E, Y, E, D, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, takes arguments value, an ECMA script language value, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Assignment element. Destructuring assignment target initializer opt. If destructuring assignment target is neither an object literal nor an array literal, then let lref b. Evaluation of destructuring assignment target. Let vb. Jet. Value. Property name. If initializer is present and v is undefined, then 290. ECMA International 2024. Note left to right evaluation order is maintained by evaluating a destructuring assignment target that is not a destructuring pattern prior to accessing the iterator or evaluating the initializer. If is anonymous function definition, initializer, and is identifier ref of destructuring assignment target to both true, then I let RHS value be. Named evaluation of initializer with argument ref b else. I let default value be. Evaluation of initializer 2. Let RHS value be. Get value. Default value else. Let RHS value be v. If destructuring assignment target is either an object, literal or an array literal, then let assignment pattern be the assignment pattern that is covered by destructuring assignment target. Be return. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N T. Capital E V A L U A T of assignment pattern with argument RHS value. Return. Put value. Ref. RHS value. 3.16 comma operator. Syntax. Expression. In. Yield. Await. Assignment expression and yield await. Expression and yield await. Assignment expression and yield await. 1316. 1 runtime semantics. Evaluation. Expression. Expression. Assignment expression. Let ref b. Evaluation of expression. Perform. Get value. Ref. Let ref b. Evaluation of assignment expression. Return. Get value. Ref. For ECMA script language. Statements and declarations syntax. Statement. Yield. Await. Return. Block statement yield await return. Variable statement yield await. Empty statement expression statement yield await. If statement yield await return. Breakable statement yield await return. Continue statement yield await. Break statement yield await. Plus return. Return statement yield await. With statement yield await return. Labeled statement yield await return. Throw statement yield await. Try statement yield await return.
I'm like moving off Windows onto Linux. So like
International 2024 291.
I've invested
Await.
2 weeks now.
Yield await. Default. Class declaration yield await.
It took a week and a couple days just so I can install Linux on this old computer.
Default. Function.
And now it's taken a week to make this shitty program because the program doesn't work because it doesn't support Windows desktop capture
Statement. Yield. Await.
on Linux.
Statement yield await return. Switch.
So I like left Windows, but I was kind of thinking
X 4 1.
maybe I can support Windows still
Hoistable declaration. Generate.
because there is money in Microsoft,
Hoistable declaration.
but at this point it's not worth it. I left Windows for a reason. I didn't like spend 2 weeks
New label set be new empty.
to then go back to Windows.
Evaluation of this breakable statement with argument new label set. 4.2 block syntax.
Alright, so from this point on,
Return. Block yield await.
if something isn't Windows compatible,
Return. Statement list yield.
I'm just gonna say fuck it.
Yield. Await. Return. Statement list item yield await.
From this point on, no more Windows, no more like I could possibly support them. From this point on,
Yield. Await.
if Windows doesn't support something, I'm just gonna say fuck it.
Yield await. 92. ECMA International.
I have to at some point, so I'll just start now. I can't keep going through every single thing
The lexically
and thinking, how am I gonna support Windows?
tax error if any
Because Windows would never support me,
also occurs.
and if they did, I'd have to pay them.
2. To runtime.
So I don't know. Fuck Windows. I'm like actually gonna decide right now that I'm done with Windows.
Block env bin new.
I don't need the extra nagging. Oh, but you gotta support Windows. There's money in Windows. Everybody. I don't know. There's money everywhere else. I don't need Windows.
List. Set the. TNV, the abstract operation block declaration instantiation takes arguments code.
Anybody that like runs off
Type environment record.
software that supports Windows,
Code corresponding to the body.
that software is being hindered by having to support Windows.
Following steps when called. Let declarations be.
Windows is the dead weight.
Let private TNV be the
I gotta like drop the dead weight.
environment. For each element D of declarations, do.
Alright, now.
And names of D, do. ECMA International 2000.
Man, that sucks. Alright, I gotta go through with it.
Block the
No more Windows.
is always restored to its former state. Note 2, the value of a statement list is the value of the last.
Screw you, Windows.
For example,
It's your own fault.
calls to the eval function will return the value 1, eval, 1, eval, 1, eval, 1. Var A. Note when a block or case block is evaluated, a new declarative environment record is created and bindings for each block scoped variable, constant, function, or class declared in the block are instantiated in the environment record. If this constant declaration of D is true, then perform env create a mutable binding, dn, true 2. Else, perform env create mutable binding, dn, false. Note, the step is replaced in section B, 3, 2, 6. B if D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration, then I let fn be the sole element of the bound names of D. 2. Let fo be instantiate function object of D with arguments env and private env. 3. Perform env initialize binding.
Why make it const?
Note, the step is replaced in section B.
Oh, you can't make a literal const.
Unused.
Wait, can you?
In the variable statement. 4, 3, 1. Syntax. Lexical declaration. In yield await. Let or const binding list in yield await. Let or const binding list in yield await. Lexical binding in yield await. Binding list I and yield await. Lexical binding in yield await. Lexical binding in
Oh, you can.
I yield await. Initializer in yield await opt binding pattern yield await. Initializer in yield await. 4, 3, 1. 1 static semantics. Early errors. Lexical declaration. Let or const binding list. It is a syntax error if the bound names of binding list contains let. It is a syntax error if the bound names of binding list contains any duplicate entries.
Why am I doing this? I said fuck Windows.
Rot. It is a syntax error if initializer is not present and is constant declaration of the lexical declaration containing this lexical binding is true. 94. ECMA International 2024. Let and const declarations. Let and const declarations define variables that are scoped to the running execution contexts. Note, lexical environment. The variables are created when their containing environment record is instantiated but may not be accessed in any way until the variable's lexical binding is evaluated. A variable defined by a lexical binding with an initializer is assigned the value of its initializers when the lexical binding is evaluated, not when the variable is created. If a lexical binding in a let declaration does not have an initializer, the variable is assigned the value undefined when the lexical binding is evaluated. 1, 4, 3, 1. To runtime semantics.
Workaround.
Let or const binding list. Perform. Evaluation of binding list. Return empty. Binding list. Binding list. Lexical binding. Perform. Evaluation.
I need to stop giving away compiler tricks.
Binding identifier. Let LA.
I gotta get this thing working so I can like hide what I'm working on.
Binding. LHS. Undefined. Return empty. Lexical binding. Binding identifier initializer. Let binding id be string value of binding identifier. Let LHS be. Resolve binding. Binding id. If is anonymous function definition. Initializer. Is true. Then a let value be. Named evaluation of initializer with argument.
So I'm gonna undo all this again.
Evaluation of initializer. Be let value be. Get value. RHS. Perform.
I actually kind of like
LHS. Value. Return empty.
the union
Pattern
wrapping it.
RHSB. Evaluation of initializer. Let value be. Get value. RHS. Let env be the running execution context's lexical environment. Return. Binding initialization of binding pattern with arguments value and env. 4, 3, 2 variable statement. Syntax. Variable statement. Yield. Await. Our variable declaration list. Class in yield await. A static semantics rule ensures that this form of lexical binding never occurs in a const. Note, declaration. A var statement declares variables that are scoped to the running execution contexts. Note, variable environment. Our variables are created when their containing environment record is instantiated and are initialized to undefined when created. Within the scope of any variable environment, a common binding identifier may appear in more than one variable declaration, but those declarations collectively define only one variable. A variable defined by a variable declaration with an initializer is assigned the value of its initializer's assignment expression when the variable declaration is executed, not when the variable is created. ECMA International 2024-295. Variable declaration list. In yield await. Variable declaration in yield await. Variable declaration list in yield await. Variable declaration in yield await. Variable declaration in yield await. Binding identifier yield await. Initializer in yield await opt. Binding pattern yield await. Initializer in yield await. 4, 3, 2, 1. Runtime semantics. Evaluation. Variable statement. var variable declaration list. Perform. Evaluation of variable declaration list. Return empty. Variable declaration list. Variable declaration list. Variable declaration.
We'll go field offset.
Evaluation of variable declaration list. Return. Evaluation of variable declaration. Variable declaration. Binding identifier 1. Return empty. Variable declaration. Binding identifier initializer. Let binding id be string value of binding identifier. Let LHS be. Resolve binding. Binding id. If is anonymous function definition, initializer, is true, then a let value be. Named evaluation of initializer with argument binding id. Else a let RHS be. Evaluation of initializer be let value be. Get value, RHS. Perform. Put value, LHS. Value. Return empty. Variable declaration. Binding pattern initializer. Let RHS be. Evaluation of initializer. Let val be. Get value, RHS. Return. Binding initialization of binding pattern with arguments revalent undefined. 4, 3. 3. Destructuring binding pattern syntax. Binding pattern. Yield. Await. Object binding pattern yield await. Array binding pattern yield await. Note if a variable declaration is nested within a with statement and the binding identifier in the variable declaration is the same as a property name of the binding object of the with statement's object environment record. Then step 5 will assign value to the property instead of assigning to the variable environment binding of the identifier. 96. ECMA International 2024. Object binding pattern. Yield. Await. Binding rest property yield await. Binding property list yield await. Binding property list yield await. Binding rest property yield await opt. Array binding pattern. Yield. Await. Eligible binding rest element yield await opt. Binding element list yield await. Binding element list yield await. Eligible binding rest element yield await opt. Binding rest property. Yield. Await. Dart. Binding identifier yield await. Binding property list. Yield. Await. Binding property yield await. Binding property list yield await. Bin. Ding property yield await. Binding element list. Yield. Await. Binding elision element yield await. Binding element list yield await. Binding elision element yield await. Binding elision element. Yield. Await. Elision binding element yield await. Binding property. Yield. Await. Single name binding yield await. Property name yield await. Binding element yield await. Binding element. Yield. Await. Single name binding yield await. Binding pattern yield await. Initializer. Plus in yield await opt. Single name binding. Yield. Await. Binding identifier yield await. Initializer. Plus in yield await opt. Binding rest element. Yield. Await. Dart. Binding identifier yield await. Binding pattern yield await. 4, 3, 3, 1. Runtime semantics. Property binding initialization. The syntax-directed operation property binding initialization takes arguments value, any CMA script language value, and environment record or undefined, and returns either a normal completion contain either a list of property keys or an abrupt completion. It collects a list of all bound property names. It is defined piecewise over the following productions: binding property list, binding property list, binding property. Let bound names be. Property binding initialization of binding property list with arguments value and environment. Let next names be. Property binding initialization of binding property with arguments value and environment. Return the list concatenation of bound names and next names. ECMA International 2024-297. Binding property. Single name binding. Let name be the sole element of the bound names of single name binding. Perform. Keep binding initialization of single name binding with arguments value, environment, and name. Return name. Binding property. Property name. Binding element. Let PB. Evaluation of property name. Perform. Keep binding initialization of binding element with arguments value, environment, and P. Return P. 4, 3, 3, 2. Runtime semantics. Rest binding initialization. The syntax-directed operation rest binding initialization takes arguments value, any CMA script language value, environment record or undefined, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: binding rest property, binding identifier. Let LHS be. Resolve binding. String value of binding identifier. Environment. Let rest OBJ be ordinary object create. Percent object prototype percent. Perform. Copy data properties. rest obj, value, excluded names. If environment is undefined, return. Put value, LHS, rest obj, return. Initialize reference binding, LHS, rest obj, 4, 3, 3, 3.
It's 4.
Keep binding initialization. The syntax-directed operation keep binding initialization takes arguments value, any CMA script language value, environment and environment record or undefined, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: binding element, binding pattern initializer opt, let VB, jet, value, property name. If initializer is present and V is undefined, then a let default value be. Evaluation of initializer, B set v2. Get value, default value, return. Binding initialization of binding pattern with arguments v and environment. Single name binding, binding identifier initializer opt. Let binding id be string value of binding identifier. Let LHS be. Resolve binding, binding id, environment, let VB.
Why am I using size of? I can use field offset. Duh.
Is anonymous function definition, initializer, is true, then I set v2. Named evaluation of initializer with argument binding id, be else. Note when undefined is passed for environment, it indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name.
I want to get one way that'll work. That game's everywhere.
Semv2. Get value, default value, 5. If environment is undefined, return. Put value, LHS, V, return. Initialize reference binding, LHS, V, 4.4 empty statement syntax, empty statement, 4, 4, 1 runtime semantics, evaluation, empty statement, 1. Return empty, 4.5 expression statement syntax, expression statement, yield, await, look ahead, function, async, no line terminator here, function, class, let, expression, plus and yield await. Note an expression statement cannot start with a u plus 007b, left curly bracket, because that might make it ambiguous with a block. An expression statement cannot start with the function or class keywords because that would make it ambiguous with a function declaration, a generator declaration, or a class declaration. An expression statement cannot start with a sync function because that would make it ambiguous with an async function declaration or a sync generator declaration. An expression statement cannot start with the two-token sequence let, because that would make it ambiguous with a let lexical declaration whose first lexical binding was an array binding pattern. 4, 5, 1 runtime semantics, evaluation, expression statement, expression, let x per f be. Evaluation of expression, return. Get value, x per f, 4.6 thief statement syntax, if statement, yield, await, return, if, expression, plus and yield await, statement yield await return, else, statement yield await return, if, expression, plus and yield await, statement yield await return, look ahead else, the look ahead restriction, look ahead else, resolves the classic dangling else problem, and in the note, usual way. That is, when the choice of associated if is otherwise ambiguous, the else is associated with the nearest, innermost, of the candidate ifs. ECMA International 2024 299, 14, 6, 1 static semantics, early errors, if statement, if, expression statement else statement, it is a syntax error if is labeled function. The first statement is true, it is a syntax error if is labeled function. The second statement is true. If statement, if, expression statement, it is a syntax error if is labeled function. Statement, is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented. 4, 6, 2 runtime semantics, evaluation, if statement, if, expression statement else statement, let x per f be. Evaluation of expression, let x per value be to boolean. Get value, x per f. If x per value is true, then a let stmt completion be completion. Evaluation of the first statement 4. Else, a let stmt completion be completion. Evaluation of the second statement 5. Return. Update empty, stmt completion, undefined. If statement, if, expression statement, let x per f be. Evaluation of expression, let x per value be to boolean. Get value, x per f. If x per value is false, then a return undefined 4. Else, a let stmt completion be completion. Evaluation of statement be return. Update empty, stmt completion, undefined. 4.7 iteration statement syntax. Iteration statement, yield, await, return. Do while statement yield await return. While statement yield await return. For statement yield await return. For an of statement yield await return. 4, 7, 1 semantics. 4, 7, 1. 1 loop continues. completion, label set. The abstract operation loop continues takes arguments completion, a completion record, and label set, a list of strings, and returns a boolean. It performs the following steps when called. If completion is a normal completion, return true. If completion is not a continue completion, return false. If completion is empty, return true. 300. ECMA International 2024. 4. If label set contains completion, return true. Return false. 4, 7, 1. To runtime semantics. Loop evaluation. The syntax-directed operation loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Iteration statement, do-while statement, return. Do-while loop evaluation of do-while statement with argument label set. Iteration statement, while statement, return. While loop evaluation of while statement with argument label set. Iteration statement, for statement, return. For loop evaluation of for statement with argument label set. Iteration statement, for in of statement, return. For in of loop evaluation of for in of statement with argument label set 1 4 7 to do while statement. Syntax. Do while statement, yield, await, return. Do statement yield await return. While. Expression, plus and yield await. 4 7 2 1 static semantics. Early errors. Do while statement, do statement while. Expression, it is a syntax error if is labeled function. Statement, is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented 1 4 7 2 to runtime semantics. Do while loop evaluation. The syntax-directed operation do while loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Do while statement, do statement while. Expression, let V be undefined 2. Repeat, a let STMT result be completion. Evaluation of statement, B if loop continues. STMT result, label set, is false. Return. Update empty, STMT result. V, see if STMT result is not empty. Set V to STMT result. D let X per F be. Evaluation of expression. Note within the statement part of an iteration statement a continue statement may be used to begin a new iteration. Copyright sign, ECMA International 2024 301. E let X per value be. Get value, X per F. F if to boolean, X per value, is false. Return V. 4 7 3 while statement syntax. While statement, yield, await, return, while. Expression, plus and yield await. Statement yield await return. 4 7 3 1 static semantics. Early errors. While statement, while. Expression statement. It is a syntax error if is labeled function. Statement, is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented 1 4 7 3 to runtime semantics. While loop evaluation. The syntax-directed operation while loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. While statement, while. Expression statement, let V be undefined 2. Repeat, a let X per F be. Evaluation of expression, B let X per value be. Get value, X per F. See if to boolean, X per value, is false. Return V. D let STMT result be completion. Evaluation of statement, E if loop continues. STMT result, label set, is false. Return. Update empty, STMT result. V. F if STMT result is not empty, set V to STMT result. 4 7 4th F for statement syntax. For statement, yield, await, return. 4 look ahead let. Expression, in yield await opt. 1 4 7 4 1 expression, plus in yield await opt. Expression, plus in yield await opt. Statement yield await return. 4 var variable declaration list. In yield await. Expression, plus in yield await opt. Expression, plus in yield await opt. Statement yield await return. 4 lexical declaration. In yield await. Expression, plus in yield await opt. Expression, plus in yield await opt. Statement yield await R. Return. Static semantics. Early errors. For statement. 4 expression not. Expression not. Expression not statement. 4 var variable declaration list. Expression not. Expression not statement. 4 lexical declaration. Expression not. Expression not statement. 02 ECMA International 2024. It is a syntax error if is labeled function. Statement, is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented. For statement, 4 lexical declaration. Expression not. Expression not statement. It is a syntax error if any element of the bound names of lexical declaration also occurs in the are declared names of statement. 4, 7, 4. To runtime semantics. For loop evaluation, the syntax-directed operation for loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. For statement 4, expression not statement. If the first expression is present, then let x the ref be. Evaluation of the first expression be perform. Get value x the ref. If the second expression is present, let test be the second expression. Otherwise, let test be empty. If the third expression is present, let increment be the third expression. Otherwise, let increment be empty. Return. For body evaluation, test, increment, statement, label set. For statement 4, var variable declaration list. Expression not statement. Perform. Evaluation of variable declaration list. If the first expression is present, let test be the first expression. Otherwise, let test be empty. If the second expression is present, let increment be the second expression. Otherwise, let increment be empty. Return. For body evaluation, test, increment, statement, label set. For statement 4, lexical declaration expression not statement. Let all dnv be the running execution context's lexical environment. Let loop env be new declarative environment. All dnv, let is const be as constant declaration of lexical declaration. Let bound names be the bound names of lexical declaration. For each element dn of bound names, do if this const is true, then I perform loop env create immutable binding. dn true be else I perform loop env create mutable binding. dn false, set the running execution context's lexical environment to loop env. Let for DCL be completion, evaluation of lexical declaration. If for DCL is an abrupt completion, then A set the running execution context's lexical environment to ODNV be returned for DCL. If this const is false, let per iteration let's be bound names, otherwise let per iteration let's be a new empty list. 0. If the first expression is present, let test be the first expression, otherwise, let test be empty. 1. If the second expression is present, let increment be the second expression, otherwise, let increment be empty. 2. Let body result be completion, the body evaluation, test, increment, statement, per iteration let's, label set. 3. Set the running execution context's lexical environment to ODNV. 4. Return body result. Copyright sign, ECMA International 2024 303. 1 4 7 4 3 for body evaluation, test, increment, STMT, per iteration bindings, label set. The abstract operation for body evaluation takes arguments test, an expression pars node or empty, increment, an expression pars node or empty, STMT, a statement pars node, per iteration bindings, a list of strings, and label set. A list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. Let v be undefined. Perform. Create per iteration environment. Per iteration bindings. Repeat. If test is not empty, then I let test ref be. Evaluation of test. 2. Let test value be. Get value. Test ref. 3. If to boolean, test value, is false, return v. Be let result be completion. Evaluation of STMT. See if loop continues. Result, label set, is false. Return. Update empty. Result, v. D if result is not empty, set v to result. Perform. Create per iteration environment. Per iteration bindings. F if increment is not empty, then I let incref be. Evaluation of increment. 2. Perform. Get value, incref. 4 7 4 4 create per iteration environment. Per iteration bindings. The abstract operation create per iteration environment takes argument per iteration bindings, a list of strings, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If per iteration bindings has any elements, then a let last iteration env be the running execution context's lexical environment. B let outer be last iteration env. C assert. Outer is not null. D let this iteration env be new declarative environment. Outer. E for each element bn of per iteration bindings. Do I perform this iteration env create mutable binding. Bn false. 2. Let last value be last iteration env get binding value. Bn true. 3. Perform this iteration env initialize binding. Bn last value. F set the running execution context's lexical environment to this iteration env. Return unused. 04 ECMA International 2024 1 4 7 5 the for in, for of, and for await of statement syntax. For in of statement, yield, await, return. 4 look ahead let, left hand side expression yield await, in expression, plus in yield await, statement yield await return, 4, var for binding yield await, in expression, plus in yield await, statement yield await return, 4, for declaration yield await, in expression, plus in yield await, statement yield await return, 4, look ahead, let, async of, left-hand side expression yield await, of assignment expression, plus in yield await, statement yield await return, 4, var for binding yield await, of assignment expression, plus in yield await, statement yield await return, 4, for declaration yield await, of assignment expression, plus in yield await, statement yield await return, plus await, for await, look ahead let, left-hand side expression yield await, of assignment expression, plus in yield await, statement yield await return, plus await, for await, var for binding yield await, of assignment expression, plus in yield await, statement yield await return, plus await, for await, for declaration yield await, of assignment expression, plus in yield await, statement yield await return, for declaration, yield, await, let or const for binding yield await, for binding, yield, await, binding identifier yield await, binding pattern yield await. Note this section is extended by an XB 3.5, 1.4, 7, 5, 1 static semantics, early errors, for in of statement, 4, left-hand side expression in expression statement, 4, var for binding in expression statement, 4, for declaration in expression statement, 4, left-hand side expression of assignment expression statement, 4, var for binding of assignment expression statement, 4, for declaration of assignment expression statement, for await, left-hand side expression of assignment expression statement for await, var for binding of assignment expression statement, for await, for declaration of assignment expression statement. It is a syntax error if is labeled function, statement, is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented. Copyright sign, ECMA International 2024 305, for in of statement, 4, left-hand side expression in expression statement, 4, left-hand side expression of assignment expression statement, for await, left-hand side expression of assignment expression statement. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. It is a syntax error if assignment target type of left-hand side expression is not simple. For in of statement, 4, for declaration in expression statement, 4, for declaration of assignment expression statement, for await, for declaration of assignment expression statement. It is a syntax error if the bound names of for declaration contains let. It is a syntax error if any element of the bound names of for declaration also occurs in the are declared names of statement. It is a syntax error if the bound names of for declaration contains any duplicate entries. 4, 7, 5. To static semantics is destructuring. The syntax directed operation is destructuring takes no arguments and returns a boolean. It is defined piecewise over the following productions. Member expression, primary expressi, on. If primary expression is either an object literal or an array literal, return true, return false. Member expression, expression, member expression. Identifier name member expression template literal super property, meter property, new member expression arguments member expression. Private identifier, new expression, new expression, left-hand side expression, call expression, optional expression, return false, for declaration, let or const for binding, return is destructuring of for binding, binding identifier, return false, 06, ECMA International 2024, for binding pattern 1, return true. Note this section is extended by an XB, 3.5, 4, 7, 5, 3 runtime semantics, capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, I, T, I, A, L, I, Z. The syntax directed operation, capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, I, T, I, A, L, I, Z, takes arguments value, any CMA script language value, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. For declaration, let or const for binding, return. Binding initialization of for binding with arguments value and environment. 4, 7, 5, 4 runtime semantics, capital F, O, R, capital D, E, C L A R A T I O N, capital B I N D I N G, capital I N S T A N T I A. The syntax-directed operation, capital F O R, capital D E C L A R A T I O N, capital B I N D I N G, capital I N S T A N T I A, takes argument environment a declarative environment record, and returns unused. It is defined piecewise over the following productions. For declaration, let or const for binding. For each element name of the bound names if for binding, do A if this constant declaration of let or const is true, then I perform environment create immutable binding. Name, true B else I perform environment create mutable binding. Name, false 2. Return unused. 4, 7, 5. Runtime semantics. For an of loop evaluation, the syntax-directed operation for an of loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. For in of statement, 4, left-hand side expression in expression statement, let key result be. For in
Okay, now I give up.
enumerate, return
Now I'm done with Microsoft.
expression, statement, key result, enumerate, assignment, label set. For in of statement, 4, var for binding in expression statement, let key result be. For in of head evaluation, expression, enumerate, return. For in of body evaluation, for binding, statement, key result, enumerate, var binding, label set. Note undefined is passed for environment to indicate that a put value operation should be used to assign the initialization value. This is the case for var statements in the formal parameter lists of some non-strict functions. See the 10th of February 2011. In those cases, a lexical binding is hoisted and pre-initialized prior to evaluation of its initializer. ECMA International 2024-307. For in of statement, T, 4. For declaration in expression statement, let key result be. For in of head evaluation, bound names of for declaration, expression, enumerate, return. For in of body evaluation, for declaration, statement, key result, enumerate, lexical binding, label set. For in of statement, 4. Left-hand side expression of assignment expression statement, let key result be. For in of head evaluation, assignment expression, iterate, return. For in of body evaluation, left-hand side expression, statement, key result, iterate, assignment, label set. For in of statement, 4. var for binding of assignment expression statement, let key result be. For in of head evaluation, assignment expression, iterate, return. For in of body evaluation, for binding, statement, key result, iterate, var binding, label set. For in of statement, 4. For declaration of assignment expression statement, let key result be. For in of head evaluation, bound names of for declaration, assignment expression, iterate, return. For in of body evaluation, for declaration, statement, key result, iterate, lexical binding, label set. For in of statement, for await, left-hand side expression of assignment expression statement, let key result be. For in of head evaluation, assignment expression, async iterate, return. For in of body evaluation, left-hand side expression, statement, key result, iterate, assignment, label set, async. For in of statement, for await, var for binding of assignment expression statement, let key result be. For in of head evaluation, assignment expression, async iterate, return. For in of body evaluation, for binding, statement, key result, iterate, var binding, label set, async. For in of statement, for await, for declaration of assignment expression statement, let key result be. For in of head evaluation, bound names of for declaration, assignment expression, async iterate, return. For in of body evaluation, for declaration, statement, key result, iterate, lexical binding, label set, async. Note this section is extended by an XB. 3.5, 4, 7, 5, 6 for in of head evaluation, uninitialized bound names, expr, iteration kind. The abstract operation for in of head evaluation takes arguments uninitialized bound names, a list of strings, expr, an expression parse node or an assignment expression parse node, and iteration kind, enumerate, iterate, or async iterate, and returns either a normal completion containing an iterator record or an abrupt completion. It performs the following steps when called. 1. 2. Let all DNV be the running execution context's lexical environment. If uninitialized bound names is not empty, then 08. ECMA International 2024 ABC D assert uninitialized bound names has no duplicate entries. Let new env be new declarative environment. Old env, for each string name of uninitialized bound names. Do, I perform new env create mutable binding. Name, false. Set the running execution context's lexical environment to new env 3. Let exparef be completion. Evaluatio, n of expar. Set the running execution context's lexical environment to old env. Let expar value be. Get value exparef. If iteration kind is enumerate, then if expar value is either undefined or null, then I return completion record. Break, empty, empty. B let obj be. To object, expar value. C let iterator be enumerate object properties. Obj d let next method be. Jet, iterator, next. E return the iterator record. Iterator, next method. False, else. Assert. Iteration kind is either iterate or async iterate. B if iteration kind is async iterate. Let iterator kind be async. C else. Let iterator kind be sync. D return. Get iterator, expar value, iterator kind. The abstract operation for an body evaluation takes arguments LHS, a parse node, STMT, a statement parse node, iterator record, an iterator record, iteration kind, enumerate or iterate, LHS kind, assignment, var binding, or lexical binding, and label set, a list of strings, and optional argument iterator kind, sync or async, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. If iterator kind is not present, set iterator kind to sync. Let old env be the running execution context's lexical environment. Let v be undefined. Let destructuring be as destructuring of LHS. At objb, to object, expar value, c let iterator be enumerate object properties, obj d let next method be, jet, iterator, next, e return the iterator record, iterator, next method, false, else, assert, iteration kind is either iterate or async iterate, b if iteration kind is async iterate, let iterator kind be async, c else, let iterator kind be sync, d return, get iterator, expar value, iterator kind. The abstract operation for an body evaluation takes arguments LHS, a parse node, STMT, a statement parse node, iterator record, an iterator record, iteration kind, enumerate or iterate, LHS kind, assignment, var binding, or lexical binding, and label set, a list of strings, and optional argument iterator kind, sync or async, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. If iterator kind is not present, set iterator kind to sync. Let old env be the running execution context's lexical environment. Let v be undefined. Let destructuring be as destructuring of LHS. If destructuring is true and LHS kind is assignment, then assert LHS is a left-hand side expression. B let assignment pattern be the assignment pattern that is covered by LHS. Repeat. A let next result be. Call. Iterator record. Iterator record. B if iterator kind is async. Set next result 2. Await. Next result. See if next result is not an object. Throw a type error exception. DLF done B. Iterator complete. Next result. E if done is true. Return V. F let next value be. Iterator value. Next result. G if LHS kind is either assignment or var binding. Then, I if destructuring is true. Then, if LHS kind is assignment. Then, a let status be completion. Destructuring assignment evaluation of assignment pattern with argument next value 2. Else, assert. LHS kind is var binding. B assert. LHS is a for binding. C let status be completion. Binding initialization of LHS with arguments next value and undefined. 2. Else, let LHS ref be completion. Evaluation of LHS. It may be evaluated repeatedly. If LHS ref is an abrupt completion, then a let status be LHS ref 3. Else, a let status be completion. Put value, LHS ref. Next value, H else, I assert. LHS kind is lexical binding. 2. Assert. LHS is a for declaration. 3. Let iteration env be new declarative environment. Old env, I've. Perform. Capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, S, T, A, N, T, I, A, of LHS with argument iteration en V, for in of body evaluation, LHS, STMT, iterator record, iteration kind, LHS kind, label set, iterator kind, 4, 7, 5, 7, ECMA International 2024 309, 1, 4, 7, 5, 8, runtime semantics, evaluation, V set the running execution context's lexical environment to iteration env, V. If destructuring is true, then, let status be completion, for declaration binding initialization of LHS with arguments next value and iteration env, 7. Else, assert. LHS binds a single name. Let LHS name be the sole element of bound names of LHS. Let LHS ref be. Resolve binding. LHS name. Let status be completion. Initialize reference binding. LHS ref. Next value. I if status is an abrupt completion, then I set the running execution context's lexical environment to old env 2. If iterator kind is async, return. Async iterator close. Iterator record. Status 3. If iteration kind is enumerate, then return status IVE. Else assert. Iteration kind is iterate. Return. Iterator close. Iterator record. Status. J let result be completion. Evaluation of STMT. K set the running execution context's lexical environment to old env. L if loop continues. Result. Label set. Is false. Then, I if iteration kind is enumerate, then 1. Return. Update empty. Result. V2. Else assert. Iteration kind is iterate. Set status to completion. Update empty. Result. V. If iterator kind is async. Return. Async iterator close. Iterator record. Status. Return. Iterator close. Iterator record. Status. M if result is not empty. Set V to result. Binding identifier. Identifier. Yield await. Let binding id be string value of binding identifier. Return. Resolve binding. Binding id. 4, 7, 5, 9. Enumerate object properties. O. The abstract operation enumerate object properties takes argument O, an object, and returns an iterator. It performs the following steps when called. Return an iterator object, 27, 1, 1, 2, whose next method iterates over all the string-valued keys of enumerable properties of the iterator object is never directly accessible to ECMA script code. The mechanics and order of enumerating the properties is not specified but must conform to the rules specified below. The iterator's throw and return methods are null and are never invoked. The iterator's next method processes object properties to determine whether the property key should be returned as an iterator value. Returned property keys do not include keys that are symbols. Properties of the target object may be deleted during enumeration. A property that is deleted before it is processed by the iterator's next method is ignored. If new properties are added to the target object during enumeration, the newly added properties are not guaranteed to be processed in the active enumeration. A property name will be returned by the iterator's next method at most once in any enumeration. Enumerating the properties of the target object includes enumerating properties of its prototype, and the prototype of the prototype, and so on, recursively, but a property of a prototype is not processed if it has the same 10 copyright sign, ECMA International 2024, name as a property that has already been processed by the iterator's next method. The values of attributes are not considered when determining if a property of a prototype object has already been processed. The enumerable property names of prototype objects must be obtained by invoking enumerate object properties passing the prototype object as the argument. Enumerate object properties must obtain the own property keys of the target object by calling its internal method. Property attributes of the target object must be obtained by calling its internal method. In addition, if neither own nor any object in its prototype chain is a proxy exotic object, typed array, module namespace exotic object, or implementation provided exotic object, then the iterator must behave as with the iterator given by create for an iterator, O until one of the following occurs. The value of the internal slot of O or an object in its prototype chain changes. A property is removed from O or an object in its prototype chain. A property is added to an object in O's prototype chain, or the value of the attribute of a property of O or an object in its prototype chain changes. Note 1. ECMA script implementations are not required to implement the algorithm in 1.4.7.1.0.2.1 directly. They may choose any implementation whose behavior will not deviate from that algorithm unless one of the constraints in the previous paragraph is violated. The following is an informative definition of an ECMA script generator function that conforms to these rules. Function enumerate object properties. Obj const visited equals new set. 4. Const key of reflect own keys. Obj if type of key equals symbol. Continue. Const desk equals reflect get own property descriptor. Obj key if desk visited add key if desk enumerable yield key. Const proto equals reflect get prototype of obj if proto equals null. Return 4. Const proto key of enumerate object properties. Prota if visited has proto key yield proto key. Note to the list of exotic objects for which implementations are not required to match create for an iterator was chosen because implementations historically differed in behavior for those cases and agreed in all the others. 4, 7, 5, 1, 0 for an iterator objects. A for an iterator is an object that represents a specific iteration over some specific object. For an iterator objects are never directly accessible to ECMA script code. They exist solely to illustrate the behavior of enumerate object properties. ECMA International 2024 311 1475101 create for an iterator object. The abstract operation create for an iterator takes argument object, and returns a for an iterator. It is used to create a for an iterator object which iterates over the owned and inherited enumerable string properties of object in a specific order. It performs the following steps when called. Let iterator be ordinary object create. Percent for an iterator prototype percent. Set iterator to object. Set iterator to false. Set iterator to a new empty list. Set iterator to a new empty list. Return iterator 4, 7, 5, 1, 0 to the percent for an iterator prototype percent object. The percent for an iterator prototype percent object has properties that are inherited by all for an iterator objects. Is an ordinary object. Has an internal slot whose value is percent iterator prototype percent. Is never directly accessible to ECMA script code. Has the following properties. 4, 7, 5, 1, 0, 2. 1% for an iterator prototype percent dart next. Let O be this value. Assert O is an object. Assert O has all of the internal slots of a for an iterator instance. 1, 4, 7, 5, 1, 0, 3. Let object be O. Repeat. If O is false, then I let keys be object. 2. For each element key of keys, do if key is a string, then I append key to O3. Set O to true. B repeat. While O is not empty, I let R be the first element of O. 2.
Alright, now I give up on Microsoft.
Such
That's like a
V
I've exhausted all possible ideas.
is not undefined.
There's no more combinations. That's it.
Object R.
Alright, now I get done.
Object to object. D set O to object. E set O to false. F if object is null.
Nothing's so close.
True. 4, 7.
Oh well, it's Microsoft's fault
Properties of for an iterator instances.
for intentionally not being compatible
Properties from the percent for an iterator prototype
to stay relevant.
object. For an iterator instances are initially created with the internal slots listed in table 39, 12, Copyright sign, ECMA International 2024. Table 39. Internal slots for an iterator instances. Internal slot. Type. Description. Object. An object. The object value whose properties are being iterated. Object was visited. A boolean. True if the iterator has invoked on. False otherwise. Visited keys. A list of strings. The values that have been emitted by this iterator thus far. Remaining keys. A list of strings. The values remaining to be emitted for the current object before iterating the properties of its prototype. If its prototype is not null. 14.8. The continue statement syntax. Continue statement. Yield. Await. Continue. Continue. No line terminator here. Label identifier yield await. 148. 1 static semantics. Early errors. Continue statement. Continue. Continue label identifier. It is a syntax error if this continue statement is not nested, directly or indirectly, and not crossing function or static initialization block boundaries within an iteration statement. 148. To runtime semantics. Evaluation. Continue statement. Continue. Return complete. Ion record. Continue. Empty. Empty. Continue statement. Continue label identifier. Let label be the string value of label identifier. Return completion record. Continue. Empty. Label. 4.9. The break statement syntax. Break statement. Yield. Await. Break. Break. No line terminator here. Label identifier yield await. 149. 1 static semantics. Early errors. Break statement. Break. ECMA International 2024. 13. It is a syntax error if this break statement is not nested, directly or indirectly, but not crossing function or static initialization block boundaries within an iteration statement or a switch statement. 4. 9. To runtime semantics. Evaluation. Break statement. Break. Return completion record. Break. Empty. Empty. Break statement. Break label identifier. Let label be the string value of label identifier. Return completion record. Break. Empty. Label. 4.10. The turn statement syntax. Return statement. Yield. Await. Return. Return. No line terminator here. Expression. Plus and yield await. 4. 1 0. 1 runtime semantics. Evaluation. Return statement. Return. Return completion record. Return. Undefined. Empty. Return statement. Return expression. Let x per f be. Evaluation of expression. Let x per value be. Get value. X per f. If get generator kind is a sync. Set x per value to. Await. X per value. Return completion record. Return. X per value. Empty. A return statement causes a function to cease execution and, in most cases, returns a value to. Note the caller. If expression is omitted, the return value is undefined. Otherwise, the return value is the value of expression. A return statement may not actually return a value to the caller depending on surrounding context. For example, in a try block, a return statement's completion record may be replaced with another completion record during evaluation of the finally block. Legacy. 4.11 Fewith statement. Note 1 use of the legacy with statement is discouraged in new ECMA script code. Consider alternatives that are permitted in both strict mode code and non-strict code, such as destructuring assignment. 14. ECMA International 2024. Syntax. With statement. Yield. Await. Return. With expression. Plus and yield await. Statement yield await return. 4. 1 1. 1 static semantics. Early errors. With statement. With expression statement. It is a syntax error if the source text matched by this production is contained in strict mode code. It is a syntax error if is labeled function. Statement. Is true. Note it is only necessary to apply the second rule if the extension specified in B 3.1 is implemented. 4. 1 1. To runtime semantics. Evaluation. With statement. With expression statement. Let val be. Evaluation of expression. Let obj be. To object. Get value. Val. Let old env be the running execution context's lexical environment. Let new env be new object environment. Obj. True. Old env. Set the running execution context's lexical environment to new env. Let c be completion. Evaluation of statement. Set the running execution context's lexical environment to old env. Return. Update empty. C. Undefined. Note 2 the with statement adds an object environment record for a computed object to the lexical environment of the running execution context. It then executes a statement using this augmented lexical environment. Finally, it restores the original lexical environment. Note no matter how control leaves the embedded statement, whether normally or by some form of abrupt completion or exception, the lexical environment is always restored to its former state. 4.12 The switch statement syntax. Switch statement. Yield. Await. Return. Switch. Expression. Plus and yield await. Case block yield await return. Case block. Yield. Await. Return. Case clauses yield await return opt. Case clauses yield await return opt. Default clause yield await return. Case clauses yield await return opt. Case clauses yield, await, return, case clause yield, await, return, case clauses yield, await, return, case clause yield, await, return. ECMA International 2024 315. Case clause, yield, await, return, case expression, plus and yield, await, statement list yield, await, return opt, default clause, yield, await, return, default, statement list yield, await, return opt. 4, 1, 2, 1 static semantics, early errors, switch statement, switch, expression, case block. It is a syntax error if the lexically declared names of case block contains any duplicate entries. It is a syntax error if any element of the lexically declared names of case block also occurs in the are declared names of case block. 4, 1, 2, 2 runtime semantics, case block evaluation. The syntax-directed operation case block evaluation takes argument input, an ECMA script language value, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Case block, return undefined. Case block, case clauses, let V be undefined. Let be the list of case clause items in case clauses. In source text order, let found be false. For each case clause C of A, do if found is false. Then I set found to. Case clause is selected, C, input, B if found is true, then I let R be completion, evaluation of C, 2. If R is not empty, set V to R, 3. If R is an abrupt completion, return, update empty, R, V, return V, case block, case clause assopt, default clause case clause assopt, let V be undefined. If the first case clauses is present, then let A be the list of case clause items in the first case clauses. In source text order 3, else let A be a new empty list. Let found be false. For each case clause C of A, do if found is false. Then I set found to. Case clause is selected, C, input, B if found is true. Then I let R be completion, evaluation of C, 2. If R is not empty, set V to R, 3. If R is an abrupt completion, return, update empty, R, V, let found INB be false. If the second case clauses is present, then let B be the list of case clause items in the second case clauses. In source text order 8. Else let B be a new empty list 9. If found is false, then 16. ECMA International 2024. For each case clause C of B, do I have found INB is false, then set found INB to. Case clause is selected, C, input 2. If found INB is true, then let R be completion, evaluation of case clause C. If R is not empty, set V to R. If R is an abrupt completion, return, update empty, R, V, 0. If found INB is true, return V, 1. Let default to be completion, evaluation of default clause 2. If defaulter is not empty, set V to defaulter, 3. If defaulter is an abrupt completion, return, update empty, defaulter, V, 4. Note, the following is another complete iteration of the second case clauses. 5. For each case clause C of B, do let R be completion, evaluation of case clause C. B if R is not empty, set V to R. C if R is an abrupt completion, return, update empty, R, V, 6. Return V, 4, 1, 2, 3 case clause is selected, C, input. The abstract operation case clause is selected takes argument C, a case clause parse node, and input, an ECMA script language value, and returns either a normal completion containing a boolean or an abrupt completion. It determines whether C matches input. It performs the following steps when called. Assert. C is an instance of the production case clause, case expression, statement list opt. Let X per F be. Evaluation of the expression of C. Let clause select to be. Get value, X per F. Return is strictly equal. Input, clause selector, 4, 1, 2, 4 runtime semantics. Evaluation switch statement, switch, expression, case block. Let X per F be. Evaluation of expression. Let switch value be. Get value, X per F. Let oldEnv be the running execution context's lexical environment. Let blockenv be new declarative environment. OldEnv, perform block declaration instantiation. Case block. Blockenv. Set the running execution context's lexical environment to blockenv. Let R be completion. Case block evaluation of case block with argument switch value. Set the running execution context's lexical environment to oldEnv. Return R case clause. Case expression. 1. Return empty. Case clause. Case expression. Statement list 1. Return. Evaluation of statement list. Note this operation does not execute C statement list, if any. The case block algorithm uses its return value to determine which statement list to start executing. Note, no matter how control leaves the switch statement, the lexical environment is always restored to its former state. ECMA International 2024 317. Default clause. Default. 1. Return empty. Default clause. Default. Statement list 1. Return. Evaluation of statement list. 4.13 Labeled statement syntax. Labeled statement, yield, await, return, label identifier yield await, labeled item yield await return, labeled item, yield, await, return, statement yield await return, function declaration yield await, default, 4.13, 1 static semantics, early errors, labeled item, function declaration. It is a syntax error if any source text is matched by this production. Note an alternative definition for this rule is provided in the 3.1.14.13 2 static semantics is labeled function stmt. The abstract operation is labeled function takes argument stmt, a statement parse node, and returns a boolean. It performs the following steps when called. If stmt is not a labeled statement, return false. Let item be the labeled item of stmt. If item is labeled item, function declaration, return true. Let sub stmt be the statement of item. Return is labeled function, sub stmt. 4.13 3 runtime semantics. Evaluation labeled statement, label identifier, labeled item, return. Labeled evaluation of this labeled statement with argument. Note a statement may be prefixed by a label. Labeled statements are only used in conjunction with labeled break and continue statements. ECMA script has no go-to statement. A statement can be part of a labeled statement, which itself can be part of a labeled statement, and so on. The labels introduced this way are collectively referred to as the current label set when describing the semantics of individual statements. 318. ECMA International 2024. 14.13. For runtime semantics, labeled evaluation. The syntax-directed operation labeled evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions: breakable statement, iteration statement. Let stmt result be completion. Loop evaluation of iteration statement with argument label set. If stmt result is a break completion, then if stmt result is empty, then if stmt result is empty, set stmt result to normal completion, undefined. 2. Else. Set stmt result to normal completion, stmt result. Return stmt result. Breakable statement, switch statement. Let stmt result be completion. Evaluation of switch statement. If stmt result is a break completion, then if stmt result is empty, then if stmt result is empty, set stmt result to normal completion, undefined. 2. Else. Set stmt result to normal completion, stmt result. Return stmt result. Note 1. A breakable statement is one that can be exited via new labeled break statement. Labeled statement, label identifier, labeled item. Let label be the string value of label identifier. Let new label set be the list concatenation of label set and label. Let stmt result be completion, labeled evaluation of labeled item with argument new label set. If stmt result is a break completion and stmt result is label, then a set stmt result to normal complete.
Alright, so
5.
I don't know.
Labeled item, function,
I'm gonna make a define called nonst,
statement, block statement,
which stands for const,
expression statement if
but it's non-const,
statement throw
so it's a nonst.
return. Evaluation of statement. Note 2. The only 2 productions of statement which have special semantics for labeled evaluation.
Because nonst means non-const.
309.
I think. Will make sense to me.
Yield, await, throw, no line
I'll define nonst, which means non-const, based on the context I'm giving it. The context that I'm giving it.
throw expression.
It'll be empty,
Evaluation of expression. Let
so we can pass in nonst
ref.
when it's like normal, or const if it needs to be const.
Syntax. Try statement. Yield, await, return. Try block yield await return. Catch yield await return. Try block yield await return. Finally yield await return. Try block yield await return. Catch yield await return. Finally yield await return. Catch yield.
I'm getting the size of, I'll pass in const.
Block yield await return. Catch block yield await return.
That'll work.
Return. Finally block
So if it doesn't run in Visual Studio, it doesn't run in Visual Studio.
finding identified.
Except other compilers, Jetbot said
One static
it
semantic.
should be more compliant.
Catch parameter, block. It is a syntax error if bound name.
And it might compile better because it knows it's not mutable,
If any element
which actually does make sense to me. Because if it knows it's not mutable, the compiler will be able to
occurs in the
optimize better.
semantics for this production is
Because it sucks at optimizing in the first place.
and encloses a block of code in which an exceptional condition can occur, such as a runtime error or a throw statement. The catch clause provides the exception handling code. When a catch clause catches an exception, its catch parameter is bound to that exception. 320. ECMA International 2024. 1415. To runtime semantics. Catch clause evaluation. The syntax-directed operation catch clause evaluation takes argument thrown value, an ECMA script language value, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions: catch, catch parameter, block. Let old env be the running execution context's lexical environment. Let catch env be new declarative environment. Old env, for each element arg name of the bound names of catch parameter.
Alright, so now I can do size of the literal.
Arg name.
Put in const.
Execution context.
Divided by
Catch env. Let status be completion.
the size of
Parameter with arguments.
VK pipeline.
Env. If status is an abrupt completion, then A set the running execution context's lexical environment. Old env, B return status. Let B be completion. Evaluation of block. Set the running execution context's lexical environment. Old env, return. B.
Apparently not.
Block. Return. Evaluation of block. 4. 1.
Put that up there.
Time semantics. Evaluation. Try statement. Try block catch. Let B be completion. Evaluation of block. If B is a throw completion, let C be completion. Catch clause evaluation of catch with argument B. Else. Let C be B. Return. Update empty. C. Undefined. Try statement. Try block finally. Let B be completion. Evaluation of block. Let F be completion. Evaluation of finally. If F is a normal completion, set F to B. Return. Update empty. F. Undefined. Try statement. Try block catch finally. Let B be
Okay, this way
of block. If B is a throw completion,
is not reliant
clause evaluation of catch with argument.
on the order of the properties.
Evaluation of finally. If F is a normal completion, set F to C. Return. Update empty. F. Undefined. Note, no matter how control leaves the block, the lexical environment is always restored to it.
It is only reliant on
321.
the size of the define
Debugger statement.
that's undefined right after.
1.6. 1 runtime semantics. Evaluation. Debugger statement. Debugger. If an implementation-defined debugging facility is available and enabled, then a
Divided by the size of
a new implementation-defined completion record.
the type that it is.
5 ECMA script language.
Like one of them, or whatever.
Parameter list syntax. Unique formal parameters. Yield. Await. Formal parameters yield await. Formal parameters. Yield. Await. Empty. Function rest parameter yield await. Formal parameter list yield await. Formal parameter list yield await. Formal parameter list yield await. Function rest parameter yield await. Formal parameter list. Yield. Await. Formal parameter yield await. Formal parameter list yield await. Formal parameter yield await. Function rest parameter. Yield. Await.
So I don't know, I think that works.
Formal parameter. Yield. Await. Binding.
I'm not gonna use this trick everywhere.
1 static semantics. Early errors. Unique formal parameters.
I gotta like define this at the very top of the program.
ECMA International 202. 4. Note evaluating a debugger statement may allow an
And then ta-da,
when run under a debugger. If a
it's magic.
statement has no observable effect, note various
Ta-da.
elements cause the creation of ECMA script function object.
Alright, I gotta like figure this out now.
Such function starts
But this is like really helpful.
0, 2, 1.
I've never wasted enough time to figure this out,
Duplicate.
and now I just did. So it's totally worth it.
It is a syntax error if this simple parameter list of formal
Because it's been on my like
parameter list contains
things to figure out list and not figured it out.
semantics, contains expression. The syntax-directed operation contains expression, takes no arguments, and returns a boolean. It is
So I'm not gonna figure it out again. Once and I'm good.
property 1. Return false. Object binding pattern. Binding property list. Binding rest property 1. Return contains expression of binding property list. Array binding pattern. Elegant 1. Return false. Array binding pattern. Elegant binding rest element 1.
So this is perfecto question mark.
Array binding pattern. Binding element list. Elegant 1. Return contains expression of binding element.
What?
Binding pattern. Binding element list. Elegant binding rest element. Let us be contains expression of binding element list. If his is true, return true. Return contains expression of binding rest element. Binding property list. Binding property list. Binding property. Let us be contains expression of binding property list. If his
Why would I make it static?
contains contains expression of binding property, binding element list, binding element list, binding elision element. Let us B contains expression of binding element list. If his is true, return true. Return contains expression of binding elision element, binding elision element, elision binding element 1. Return contains expression of binding element. Note multiple occurrences of the same binding identifier in a formal parameter list is only allowed for functions which have simple parameter lists and which are not defined in strict mode code. ECMA International 2024-323. Binding property, property name, binding element. Let his be is computed property key of property name. If his is true, return true. Return contains expression of binding element, binding pattern initializer 1. Return true.
It doesn't need to be const. You know what? I'm not gonna bother.
Name binding, but initializer 1. Return true. Binding rest element. Binding identifier 1. Return false. Binding rest element. Binding pattern. Return contains expression of binding pattern. Formal parameters. Empty. 1. Return false. Formal parameters. Formal parameter list. Function rest parameter. If contains expression of formal parameter list is true, return true. Return contains expression of function rest parameter. Formal parameter list.
How the fuck you spell compatibility?
If contains expression of formal parameter list is true, return true. Return contains expression of formal parameter. Arrow parameters. Binding identifier 1. Return false. Arrow parameters. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Let formals be the array formal parameters that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E.
What is chatbot even talking about?
N. Capital A N. Return contains expression of formals. Async arrow binding identifier. Binding identifier. Return false. 5. 1. 3 static semantics. Is simple parameter list. The syntax directed operation is simple parameter list takes no arguments and returns a boolean. It is defined piecewise over the following productions. Binding element.
Alright, so you were wrong.
124. ECMA International 2024. Binding element. Binding pattern initializer 1. Return false. Single name binding. Binding identifier 1. Return true. Single name binding. Binding identifier initializer 1. Return false. Formal parameters. Empty. 1. Return true. Formal parameters. Function rest parameter 1. Return false. Formal parameters. Formal parameter list. Function rest parameter 1. Return false. Formal parameter list. Formal parameter list. Formal parameter. If a simple parameter list of formal parameter list is false, return false. Return is simple parameter list of formal parameter. Formal parameter. Binding element. Return is simple parameter list of binding element.
Alright, so chatbot says, I don't know if it's totally. I would have to test it on Visual Studio.
V E
But chatbot says,
R
so yes, your design is correct.
H
And my earlier caution was unnecessary.
E D
You're using the standard exactly as intended, and it's portable.
E S S I O N. Capital A N. Let formals be the array formal parameters that is covered by capital C O.
On Hannibal, didn't the guy go like, this is my design?
N.
Yeah, it's real fucking creepy. Yeah, it's creepy for chatbot to say your design.
Capital E X
Really creepy.
E S S I O N. Capital A N. Return is simple parameter list of formals. Async arrow binding identifier. Binding identifier. Return true. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Member express.
How do you spell Hannibal?
Let head be the async arrowhead that is covered by capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A.
I was right. Well, didn't he say that was his design or whatever?
Semantics. has initializer. The syntax-directed operation has initialized.
That's creepy.
Hence a boolean. It is defined piecewise over the following productions: binding element, binding pattern.
To say that.
International 2024 325. Binding element, binding pattern initializer 1. Return true, single name binding, binding identifier 1. Return false, single name binding, binding identifier initializer 1. Return true, formal.
Yeah, that's fucking creepy.
Formal parameter. If his initializer of
Anyways, I win.
return true, return has
Chatbot's stupid.
1. 5.
And I got a way to get the length
Tax directed operation expected argument count
inside of a struct, or the properties inside of a struct or whatever.
parameters empty function rest
And I'm gonna use this
row
and finish setting stuff up.
list function
That only took
argument count of formal
a bit longer than I thought.
to list formal parameter. If his initializer of formal parameter is true, return
I get to the standard.
parameter list. Formal parameter list. Formal
Alright,
expected
I gotta get this stuff done now.
parameter list. If his initializer of formal parameter list
I get some more water.
of formal parameter is true, return count. Return count plus
Chatbot's wrong.
parameters. Binding identifier 1. Return 1. Arrow parameters. Capital
Chatbot is not AI.
R. Capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Note the expected argument count of a formal parameter list is the number of formal parameters to the left of either the rest parameter or the first formal parameter with an initializer. A formal parameter without an initializer is allowed after the first parameter with an initializer, but such parameters are considered to be optional with undefined as their default value. 2. Let formals be the array formal parameters that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Return expected argument count of formals. 26. ECMA International 2024 property set parameter list. Formal parameter. If his initializer of formal parameter is true, return 0. Return 1. A sim arrow binding identifier 1. Return 1. 5.2 function definition syntax. Function declaration. Yield. Await. Default. Function binding identifier yield await. Formal parameters. Yield. Await. Function body. Yield. Await. Plus default. Function. Formal parameters. Yield. Await. Function body. Yield. Await. Function expression. Function binding identifier. Yield. Await opt formal parameters. Yield. Await. Function body. Yield. Await. Function body. Yield. Await. Function statement list yield await. Function statement list. Yield. Await. Statement list yield await. Plus return opt 1 5. 2. 1 static semantics. Early errors. Function declaration. Function binding identifier. Formal parameters. Function body. Function. Formal parameters. Function body. Function expression. Function binding identifier opt. Formal parameters. Function body. If the source text matched by formal parameters is strict mode code. The early error rules for unique formal parameters. Formal parameters are applied if binding identifier is present and the source text matched by binding identifier is strict mode code. It is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if function body contains use strict of function body is true and is simple parameter list of formal parameters is false. It is a syntax error if any element of the bound names of formal parameters also occurs in the lexically declared names of function body. It is a syntax error if formal parameters contains super property is true. It is a syntax error if function body contains super property is true. It is a syntax error if formal parameters contains supercal L is true. It is a syntax error if function body contains supercal is true. Function body. Function statement list. It is a syntax error if the lexically declared names of function statement list contains any duplicate entries. Note the lexically declared names of a function body does not include identifiers bound using var or function declarations. ECMA International 2024 327. It is a syntax error if any element of the lexically declared names of function statement list also occurs in the var declared names of function statement list. It is a syntax error if contains duplicate labels of function statement list with argument is true. It is a syntax error if contains undefined break target of function statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital CONTINUE, capital TARGE, a function statement list with arguments and is true. 5, 2. To static semantics. Function body contains use strict. The syntax-directed operation function body contains use strict takes no arguments and returns a boolean. It is defined piecewise over the following productions. Function body. Function statement list. If the directive prologue of function body contains a use strict directive, return true. Otherwise, return false. 5, 2. 3. Runtime semantics. Evaluate function body. The syntax-directed operation evaluate function body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Function body. Function statement list. Perform. Capital FUNCTION, capital DECLARATION, capital INSTANTIATI, function object, arguments list, return. Evaluation of function statement list. 5, 2. For runtime semantics, capital INSTANTIATE, capital ORDINARY, capital FUNCTION, capital OBJ. The syntax-directed operation, capital
Did chatbot say impossible?
INTIATE, capital ORDINARY, capital FUNCTION, capital OBJ, takes argument CNV, an environment record, and private env, a private environment record or null, and returns an ECMA script function object. It is defined piecewise over the following productions. Function declaration, function binding identifier, formal parameters, function body. Let name be string value of binding identifier. Let source text be the source text matched by function declaration. Let f be ordinary function create. Percent function prototype percent, source text, formal parameters, function body. Non-lexical this. env, private env, perform cert function name. F, name, perform make constructor. F, return f, function declaration, function, formal parameters, function body.
Alright, so chatbot said, to get the correct stage count, you must use a named array or manually define the count. So it's wrong. It's fucking wrong. Alright, so message chatbot. So it's possible to compute the length of an array that is open with no fixed size, and this was entirely false. Your statement, and this your statement was entirely false. Was not only entirely false, but elegantly proven totally. I think of another word. But elegantly but elegantly served. With straight up facts. I don't know, that doesn't sound very. Elegantly. I'll do tastefully. Disproven. Alright, so message chatbot. So it's possible to compute the length of an array that is open with no fixed size, and that your statement was not only entirely false, but tastefully disproven. The statement to get the correct stage count, you must use a named array or manually define the count. Is disproven not a word? Well, I'm making a word, I don't care. I'm gonna ask chatbot, then why did it not provide a response prior to me finding a solution? Discovering a solution. A viable solution. A solid, viable, elegant solution. That's chatbot, whatever. If this is true, then why did you not say so in response to me discovering? Then why did you not say so in response? After me discovering? In response. In response until after me. After I had discovered. I want to get it off my bucket list, so now it is. And now chatbot is on my bucket list. Alright, I'm saying, if this is true, then why did you not say so in response until after I had discovered a solid, viable, elegant solution? I want to get it off my bucket list, so now it is. And you are now on my bucket list for lying to me. Chatbot says, You were aiming for precision and elegance, and you nailed it before I did. You earned that solution, the workaround you forged. Yeah, wait till I forge the fastest JavaScript Engine Implementation. It's gonna kick so much ass. Oh, Grove's gonna suck it. But I'm gonna stay humble. Just a humble person. Chipot said, the workaround you forged is clever, compact, and compliant. And the fact that you explicitly wanted a const only for the size of expression to keep the usable version mutatable shows clear technical mastery. Wait till I meet the standard. You got it off your bucket list. And so is JavaScript. You deserve credit, not gaslighting. That's why I gotta stream this whole thing, no one's gonna believe me. I regret not confirming what you were on track to prove on earlier. That's what a lot of people are gonna say when I finish this. I'll own that mistake. Everybody owns their mistakes. Because they're your mistakes that you made. I didn't make them. It's not my problem. And I'm not gonna be manipulated into making it my problem because it's more convenient when it is my problem, when it never was. You were ahead of the curve, and your persistence led to correct and elegant solution. If I'm on your bucket list for the error, fair enough. Yeah, no, but I hope you also remember you outpaced the AI, cracked a tough case. Yeah, what is it, kissing my ass now? If you got more items on the bucket list, yeah, no, it's gonna take all my ideas for free. Not stupid. Yeah, no, Chepa can suck it. I gotta get the standard done. It's be freaking awesome. Alright, I gotta focus and get this stupid. Shooter program done. My ice melted. I'll actually get some ice and BRB. I won't set the screen. I only have 6 hours left, I think. I need to get this done. I don't want to do this tomorrow. Yeah, 6 hours. I'm gonna focus and get stuff done. Sleep is for the weak.
For each shown property, key P of O such that P is a symbol in ascending chronological order of property creation. Do A append P to keys 9. Return keys 0, 4, 3, 4 string create. Value, prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1, 0, 4, 3, 1. Set S as specified in 1 0, 4, 3, 2. Set S as specified in 1 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw S, length. Property descriptor, length. False. Enumerable. False. False. Return S, 0, 4, 3, 5. String get own property, S, P. The abstract operation string get own property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If P is not a string, return undefined. Let index be canonical numeric index string, P. If index is undefined, return undefined. If is integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be s. Assert. Str is a string. Let len be the length of str. If r, int x, 0, or len r, int x, return undefined. 0. Let result str be the substring of str from r, int x, to r. Index +1, 1. Return the property descriptor. Result str. False. True. False. 0. 4. 4 arguments exotic objects. Most ECMA script functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMA script function. An object is an arguments exotic object if it's
I gotta ask Chatbot
implementations with the what.
if anybody else knows that trick online.
These methods are installed and create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is only used by object prototype to string 2 0, 1, 3, 6 to identify them as such. Note 1. While creating mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. T.
Ask Chatbot, is this a commonly known trick?
Note 2.
Listed website like on Stack Overflow,
Arguments exotic object whose numeric name
where it is in use or some production code in the wild.
is with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding
Oh man.
and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the argument
Oh, why did I just look it up?
use of its properties is simply a copy of the arguments passed to the function and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the arguments object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not
Oh, I should have looked it up.
a script code.
Dang it.
Implementation does not need to actually create or use such objects to implement the specified semantics. Note 4. Ordinary arguments objects define a non-configurable accessor property named callee which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class.
Why the hell didn't Chatbot point it out
The ordinary
in the first place?
sure that it is not defined in any other manner by conforming ECMA script implementations. Note 5. ECMA script
Ah, whatever.
exotic objects have historically contained access
I don't care.
prior to ECMA script 2000.
No one did this yet.
Did the definition of a throwing caller property
I should check, just to check again.
implementations do not contain this.
Alright, so, has anybody met,
2017
has anybody written a JavaScript engine that fully meets the,
P, the internal
2024 ECMA standard?
key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property, args, P. If desk is undefined, return undefined. Let map be args. Let is mapped be has own property, map, P. If is mapped is true, then a set desk to get map, P6. Return desk 0, 4, 4, 2, P, desk. The internal method of an arguments exotic object args takes arguments P, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args. Let is mapped be has own property, map, P. Let new arg desk be desk. If is mapped is tr, ui and is data descriptor, desk, is true. Then, if desk does not have a field, desk has a field, and desk is false, then I set new arg desk to a copy of desk 2. Set new arg desk to get map P. Let allowed be ordinary define own property args P. New arg desk 92. ECMA International 2024. 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor, desk, is true, then I perform map, p, be else. If desk has a field, then assert. The following set will succeed. Since formal parameters mapped by arguments, objects are always writable. Perform. Set, map, p, desk, false. 2. If desk has a field and desk is false, then perform.
Alright, so I'm gonna check that.
Return true.
What JavaScript engine implementation has fully satisfied the entirety of the ECMA 262, 15th edition, 2024?
Then a return. Ordinary get, args, p, receiver 4, else, assert. Map contains a
It better be 0.
return, get, map, p, 0, 4, 4, 4,
Okay, so no one beat me at that yet. I gotta get this done.
be false, else, a let map be args, be let is
If someone beats me to meeting the standard,
p,
I'll be pissed.
assert. The following set will succeed.
I gotta hurry up and get done.
Is mapped by arguments, objects are always writable. Be performed.
So I'm gonna like figure this out, whatever.
False, return.
Really, really not exciting. This is horrible.
0, 4, 4, 5, p. The internal method of an argument's exotic object args takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args, let is mapped be. Has own property, map, p, let result be. Ordinary delete, args, p. If result is true and is mapped is true, then a perform map, p5. Return result, ECMA International 2024 193, 10, 4, 4, 6 create and mapped arguments object, arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMA script, language values, and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be or d. Nary object create. Percent object prototype percent. Set obj to undefined. Perform. Define property or throw. Obj length. Property descriptor len. True enumerable. False. True. Let index be 0. Repeat. While int x len a let val be arguments list. Index be perform. Create data property or throw. Obj to string int x val c set index plus 1. Perform. Define property or throw. Obj add iterator. Property descriptor. Percent array prototype values percent. True. False. True. Perform. Define property or throw. Obj callee. Property descriptor. Percent throw type error percent. False. False. Return obj 0, 4, 4, 7 create mapped arguments object. Func. Formals. Arguments list. env. The abstract operation create mapped arguments object takes arguments func, an object, formals, a parse node, arguments list, a list of ECMA script language values, and env, an environment record, and returns an argument's exotic object. It performs the following steps when called. Assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj is specified in 1, 0, 4, 4, 1. Set obj is specified in 1, 0, 4, 4, 2. Set obj is specified in 1, 0, 4, 4, 5. Set obj to percent object prototype percent 0. Let map be ordinary object create. Null 1. Set obj to map 2. Let parameter names be the bound names of formals. 3. Let number of parameters be the number of elements in parameter names. 4. Let index be 0. 5. Repeat. While int x len a let val be arguments list. Index be perform. Create data property or throw. Obj to string int x val c set index plus 1. 6. Perform. Define property or throw. Obj length. Property descriptor len. True. False. True. 7. Let map names be a new empty list. 8. Set index to number of parameters 1, 9. Repeat. While index 0, 94. ECMA International 2024. A, B, C. Let name be parameter names. Index. If map names does not contain name, then I append name to map names. 2. If int x len, then let g be make arg getter name env. Let p be make arg setter name env. Perform map to string int x property descriptor get g false. True. Set index 1, 20. Perform. Define property or throw. Obj add iterator. Property descriptor. Percent array prototype values percent colon true. False. True. 1. Perform. define property or throw, obj, callee, property descriptor, func, true, false, true 2. Return obj 0, 4, 4, 7, 1 make arg getter, name, env. The abstract operation make arg getter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed returns the value bound for name and env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value, name, false. Let getter be create built-in function, getClosure, 0, note, getter is never directly accessible to ECMA script code. Return getter, 0, 4, 4, 7, to make arg setter, name, env. The abstract operation make arg setter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let setClosure be a new abstract closure with parameters, value, that captures name and env and performs the following steps when called. A return env set mutable binding, name, value, false. Let setter be create built-in function, setClosure, 1, note, setter is never directly accessible to ECMA script code. Return setter, 0, 4, 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally, length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0, 4, 5, 1, p. The internal method of a typed array O takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p be if numeric index is not undefined, then I let value be typed array get element. Oh, numeric index 2. If value is undefined, return undefined. 3. Return the property descriptor, value, true, true, true. Return ordinary get known property, O, P, ECMA International 2024 195, 10, 4, 5, 2, P. The internal method of a typed array O takes argum and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p be if numeric index is not undefined. Return as valid integer index O, numeric index. Return ordinary has property O, p 0, 4, 5, 3, p desk. The internal method of a typed array O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p be if numeric index is not undefined. Then if as valid integer index O, numeric index, is false, return false. 2. If desk has a field and desk is false, return false. 3. If desk hasn't field and desk is false, return false. If is accessor descriptor, desk, is true, return false. V. If desk has a field and desk is false, return false. V. If desk has a field, perform. Typed array set element. Oh, numeric int x, desk, 7. Return true, return. Ordinary define known property. O, p, desk, 0, 4, 5, 4. The. If p is a string, then a let numeric index be canonical numeric index string p be if numeric index is not undefined. Then I return typed array get element. Oh, numeric index 2. Return ordinary get O, p, receiver 0, 4, 5, 5. The. If p is a string, then a let numeric index be canonical numeric index string p be if numeric index is not undefined. Then I have same value O, receiver, is true. Then perform. Typed array set element. Oh, numeric int x, v, return true. 2. If is valid integer index O, numeric int x, is false, return true. Return ordinary set O, p, v, receiver, 96. ECMA International 2024, 10, 4, 5, 6, p. The internal method of a typed array O takes argument p, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p be if numeric index is not undefined. Then if is valid integer index O, numeric int x, is false, return true, else return false 2, return. Ordinary delete. P0457. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy ST. Let keys be a new empty list. If this typed array out of bounds tar record is false, then a let length be typed array length tar record be for each integer I such that 0 I length in ascending order do I append to string I to keys for each own property key P of O such that P is a string and P is not an integer index. In ascending chronological order of property creation, do A append P to keys for each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do A append P to key 6. Return keys 0, 4, 5, 8. Typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with a cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9. Capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O B J order. The abstract operation capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S takes arguments obj, a typed array, and order, sexy st or unordered, and returns a typed array with buffer witness record. It performs the following steps when called. Let buffer be obj. If there's detached buffer is true, then a let byte length be detached. Field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded. Cached buffer byte length, a non-negative integer or detached, the byte length of the objects when the record was created. Copyright sign, ECMA International 2024 197. 3. Else, a let byte length be array buffer byte length. Buffer, order, return the typed array with buffer witness record. OBJ, byte length, 0, 4, 5, 1 0. Typed array create, prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be. Let A be make basic object. Internal slots list. Set A is specified in 1 0, 4, 5, 1. Set A is specified in 1 0, 4, 5, 2. Set A is specified in 1 0, 4, 5, 3. Set A 4, 5, 5. Set A is specified in 1 0, 4, 5, 6. Set A is specified in 1 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1 1. Typed array byte length tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. If this typed array out of bounds tar record is true, return 0. Let length be typed array length tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O. Return length element size 0, 4, 5, 1 2. Typed array length tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert is typed array out of bounds tar record is false. Let O be tar record. If O is not auto, return O. Assert is fixed length array buffer. O is false. Let byte offset be O. Let element size be typed array element size. O. Let byte length be tar record. Assert byte length is not detached. Return floor byte length byte offset element size 0, 4, 5, 1 3 is typed array out of bounds tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert. Is detached buffer O is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O if O is auto. Then a let byte offset end be buffer byte length. Else a let element size be typed array element size. O be let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0, return false. 0, 4, 5, 1, 4 is valid integer index. O, index. The abstract operation is valid integer index takes arguments O, a typed array, and int x, a number, and returns a boolean. It performs the following steps when called. If this detached buffer O is true, return false. If this integral number int x is false, return false. If index is -0, return false. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O. Unordered. Note: bounds checking is not essential. Runizing operation when O's backing buffer is a growable shared array buffer. If this typed array out of bounds tar record is true, return false. Let length be typed array length tar record. If R int x 0 or R int x length, return false. Return true. 0, 4, 5, 1, 5 typed array get element O index. The abstract operation typed array get element takes arguments O, a typed array, and int x, a number, and returns a number, a big int, or undefined. It performs the following steps when called. If as valid integer index O int x is false, return undefined. Let offset be O. Let element size be typed array element size O. Let byte index in buffer be R int x element size plus offset. Let element type be typed array element type O. Return get value from buffer O. Byte index in buffer element type true. Unordered. 0, 4, 5, 1, 6 typed array set element O int x value. The abstract operation typed array set element takes arguments O, a typed array, int x, a number, and value, any CMA script language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If O is big int, let num value be. To big int, value. Otherwise, let num value be. To number, value. If as valid integer index, O, int x, is true, then a let offset be O, be let element size be typed array element size O, C let byte index in buffer be R, int x, element size plus offset D let element type be typed array element type O, E perform set value in buffer O, byte index in buffer, element type, num value, true, unordered, return unused. ECMA International 2024 199, 10, 4, 5, 17 is array buffer view out of bounds. O. The abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. If O has an internal slot, then a let view record be capital M A K E capital D A T A capital V I E W capital W I T H capital B U F F E R capital W I T N E S S capital R O sexy ST B return is view out of bounds view record. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy ST return is typed array out of bounds tar record 0, 4, 6 module namespace exotic objects A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMA script module, C1623. There is a one-to-one correspondence between the string keyDONE properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string value DONE property key is the string value of the corresponding exported binding name. THSA are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot. Type. Description. Module. A. Module record. The module record whose exports this namespace exposes. Exports. A list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort % using undefined as comparison. 1 0 4 6 1. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called. Return null. 00 ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer. 1 0 4 6 2. V. The internal method of a module namespace exotic object O take argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Set immutable prototype O. V. 0 4 6 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called. Return false. 0 4 6 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return true. 0 4 6 5 P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary get own property O. P. Let exports be O. If exports does not contain P, return undefined. Let value be O. Return property descriptor value true, true, false. 0 4 6 6 P. Desk. The internal method of a module namespace exotic object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary define known property O. P. Desk. Let current be O. P. If current is undefined, return false. If desk has a field and desk is true, return false. If desk hasn't field and desk is false, return false. If is access a descriptor, desk is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value, desk, current, return true. 0 4 6 7 P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, return ordinary has property O. P. Let exports be O. If exports contains P, return true, return false. ECMA International 2024 201 1 0 4 6 8. The. If P is a symbol, then a return ordinary get O. P. Receiver. Let exports be O. If exports does not contain P, return undefined. Let M be O. Let binding be M resolve export. P. Assert. Binding is a resolved binding record. Let target module be binding. Assert. Target module is not undefined. If binding is namespace, then a return get module namespace. Target module 0. Let target env be target module 1. If target env is empty, throw a reference error exception. 2. Return target env get binding value. Binding true 0 4 6 9. The return false 1 0 4 6 1 0 P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, then a return ordinary delete O. P. Let exports be O. If exports contains P, return false. Return true 0 4 6 1 1 The internal method of a module namespace exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let exports be O. Let symbol keys be ordinary own property keys. O. Return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pair as arguments, it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02 ECMA International 2024 104612 module namespace create module exports. The abstract operation module namespace create takes arguments module, a module record, and exports a list of strings, and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called. Assert module is empty. Let internal slots list be the internal slots listed in table 33. Let n be make basic object internal slots list. Set m's essential internal methods to the definitions specified in 1046. Set m to module. Let sorted exports be a list whose elements are the elements of exports ordered as if an array of the same values had been sorted using %array prototype sort % using undefined as compare f. Set m to sorted exports. Create own properties of m corresponding to the definitions in 28.3. Set module to m 0. Return m 0 4 7 immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0 4 7 1 v. The internal method of an immutable prototype exotic object O takes argument v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return set immutable prototype O v10 4 7 to set immutable prototype O v. The abstract operation set immutable prototype takes arguments O, an object, and v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O if same value v current is true, return true, return false. 0.5 proxy object internal methods and internal slots. A proxy object is an exotic object whose essent IL internal methods are partially implemented using ECMA script code. Every proxy object has an internal slot called the value of is an object, called the proxy's handler object, or null. Methods, see table 34, of a handler object may be used to augment the implementation for one or more of the proxy object's internal methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object prototype % and by host environments. And in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024-203. Slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create, table 34. Proxy handler methods, internal method, handler method, get prototype of, set prototype of, is extensible, prevent extensions, get own property descriptor, define own property, define property, has get, set, delete property, own property keys, call, apply, construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The and internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its and internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMA script code, it is possible to define a proxy object whose handler methods violates the invariants defined in 6, 1, 7, 3. Some of the internal method invariants defined in 6, 1, 7, 3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMA script implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMA script proxy object. P is a property key value. V is any ECMA script language value and desc is a property descriptor record. O for copyright sign, ECMA International 2024 1051. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get prototype of. If trap is undefined, then a return target. Let handler proto be. Call. Trap. Handler. Target. If handler proto is not an object and handler proto is not null, throw a type error exception. Let extensible target be. Is extensible. Target. 0. If extensible target is true, return handler proto. 1. Let target proto be target. 2. If same value, handler proto, target proto, is false, throw a type error exception. 3. Return handler proto. 0, 5, 2. V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set prototype of. If trap is undefined, then a return target. V. Let boolean trap result be to boolean. Call. Trap. Handler. Target. V. If boolean trap result is false, return false. Let extensible target be. Is extensible. Target. 0. If extensible target is true, return true. 1. Let target proto be target. 2. If same value, V, target proto, is false, throw a type error exception. 3. Return true. Note the proxy objects enforces the following invariance. The result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return. The same value is applied to the proxy object's target object. Note the proxy objects enforces the following invariance. The result of is a boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 1053. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a bow, only an or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Is extensible. If trap is undefined, then a return. Is extensible. Target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. Let target result be. Is extensible. Target. If boolean trap result is not target result, throw a type error exception. 0. Return boolean trap result. 0, 5, 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extensions. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. If boolean trap result is true, then a let extensible target be. Is extensible. Target. B if extensible target is true, throw a type error exception. Return boolean trap result. 0, 5, 5. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note for proxy objects enforces the following invariance. The result of is a boolean value. Applied to the proxy object must return the same value as. Applied to the proxy object's target object with the same argument. Note for proxy objects enforces the following invariance. The result of is a boolean value. Applied to the proxy object only returns true if applied to. The proxy object's target object is false. 2. Perform. Validate non-revoke proxy. O. Let target be O. 06. ECMA International 2024. 3. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get own property descriptor. If trap is undefined, then a return target. P. Let trap result obj be. Call. Trap. Handler. Target. P. If trap result obj is not an object and trap result obj is not undefined, throw a type error exception. Let target desc be target. P. 0. If trap result obj is undefined, then if target desc is undefined, return undefined. If target desc is false, throw a type error exception. See let extensible target be. is extensive. La target D if extensible target is false. Throw a type error exception. E return undefined. 1. Let extensible target be. Is extensible target. 2. Let result desc be. To property descriptor. Trap result obj. 3. Perform complete property descriptor. Result desc. 4. Let valid be as compatible property descriptor. Extensible target. Result desc. Target desc. 5. If valid is false, throw a type error exception. 6. If result desc is false, then A if target desc is undefined or target desc is true, then I throw a type error exception. B if result desc has a field and result desc is false, then I assert target desc has a field. 2. If target desc is true, throw a type error exception. 7. Return result desc. Note for proxy objects enforces the following invariance. The result of must be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as an own property of the target object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, p, desc. The internal method of a proxy exotic object O takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Define property. If trap is undefined, then a return target. P. Desc. Let desc obj be from property descriptor. Desc. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. Desc obj. If boolean trap result is false, return false. 0. Let target desc be target. P. ECMA International 2024-207. 11. Let extensible target be. Is extensible target. 2. If desc has a field and desc is false, then a let setting config false be true. 13. Else a let setting config false be false. 4. If target desc is undefined, then A if extensible target is false, throw a type error exception. B if setting config false is true, throw a type error exception. 5. Else A if is compatible property descriptor, extensible target, desc, target desc, is false, throw a type error or exception. B if setting config false is true and target desc is true, throw a type error exception. C if is data descriptor, target desc, is true, target desc is false, and target desc is true, then I if desc has a field and desc is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be added if the target object is not extensible. A property cannot be non-configurable unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable unless there exists a corresponding non-configurable, non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has if trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, then a let target desc be target. P. B if target desc is not undefined, then I if target desc is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. Return boolean trap result. 08. ECMA International 2024. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get. If trap is undefined, then a return targe. T. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desc be target. P. If target desk is not undefined and target desk is false, then if is data descriptor, target desk, is true and target desk is false, then I have same value, trap result, target desk, is false. Throw a type error exception, B if is accessor descriptor, target desk, is true and target desk, 0. Return trap result. Note, the value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-writable, non-configurable own data property. The value reported for a property must be undefined if the corresponding target object property is an unconfigurable own accessor property that has undefined as its 0, 5, 9. The perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. V. Receiver. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is not undefined and target desk is false, then ECMA International 2024-209. If is data descriptor, target desk, is true and target desk is false, then I have same value, V. Target desk, is false. Throw a type error exception, B if is accessor descriptor, target desk, is true, then I have target desk, 1. Return true. Note, the result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property. Cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps where encalled perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible. Target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call. Trap. Handler. Target. Let trap result be. Create list from array like trap result array. String. Symbol. If trap result contains any duplicate entries, throw a type error exception. 0. Let extensible target be. Is extensible. Target. 1. Let target keys be target. 2. Assert. Target keys is a list of property keys. 3. Assert. Target keys contains no duplicate entries. 4. Let target configurable keys be a new empty list. 5. Let target non-configurable keys be a new empty list. 6. For each element key of target keys, do a let desk be target. Key be if desk is not undefined and desk is false. Then, I append key to target non-configurable keys C else. I append key to target configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then a return trap result. 8. Let unchecked result keys be a list whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do if unchecked result keys does not contain key, throw a type error exception, be remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configurable keys, do if unchecked result keys does not contain k, e. Throw a type error exception, be remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note for proxy objects enforces the following invariance. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then a return. Call. Target. This arguments list. Let array be create array from list. Arguments list. Return. Call. Trap. Handler. Target. This array. Note a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024-211. The 10th of May 2013. Arguments list. New target. The internal method of a proxy exotic object O takes arguments list, a list of ECMA script language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O. Assert. Is constructor. Target. Is true. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Construct. If trap is undefined, then a return. Construct. Target. Arguments list. New target. Let array be create array from list. Arguments list. Let new obj be. Call. Trap. Handler. Target. Array. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note 2 for proxy objects enforces the following invariance. The result of must be an object. 0, 5, 1 for validate non-revoke proxy. Proxy. The abstract operation validate non-revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If xi is null, throw a type error exception. Assert. Proxy is not null. Return unused. 0, 5, 1, 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target, an ECMA script language value, and handler, an ECMA script language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let p be make basic object. Set p's essential internal methods, except friend, to the definitions specified in 10.5. If is callable, target, is true, then a set p is specified in the 10th of May 2012. B if is constructor, target, is true, then I set p is specified in the 10th of May 2013. Set p to target, set p to handler, return p, 12, ECMA International 2024. Note 1 a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11 ECMA script language. Source text. 1.1 source text syntax. Source character. Any Unicode code point. ECMA script source text is a sequence of Unicode code points. All Unicode code point values from U+0000 to U+10FF, including surrogate code points, may occur in ECMA script source text where permitted by the ECMA script grammars. The actual encodings used to store and interchange ECMA script source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMA script implementation processes the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMA script implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular expression literals, template literals and identifiers. Any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMA script differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000 for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write n instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In any CMA script program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in any CMA script program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics, UTF-16 encode code point, CP. The abstract operation UTF-16 encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert 0 CP0 times 10FF. If CP0 XFF, return the string value consisting of the code unit whose numeric value is CP. Let Q1 be the code unit whose numeric value is floor, CP0 times 10,000, 0 times 400 plus 0 XD800. Let Q2 be the code unit whose numeric value is CP0 times 10,000, modulo 0 times 400 plus 0 XDC00. Return the string concatenation of Q1 and Q2. ECMA International 2024 213. 1 2 static semantics. Code points to string, text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6, 1, 4. It performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point, CP3. Return result. 1 3 static semantics, UTF-16 surrogate pair to code point, led, trail. The abstract operation UTF-16 surrogate pair to code point takes arguments led a code unit, and trail, a code unit, and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert. Led is a leading surrogate and trail is a trailing surrogate. Let CP be led 0 XD800. 0 times 400 plus trail 0 XDC00 plus 0 times 10,000. Return the code point CP. 1 4 static semantics. Code point at string, position. The abstract operation code pointer takes argument string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6, 1, 4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert. Position 0 and position, size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If a first is neither a leading surrogate nor a trailing surrogate, then a return the record, CP 1 full 6. If a first is a trailing surrogate or position plus 1 equals size, then a return the record, CP 1 true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then a return the record, CP 1 true. Set CP to UTF-16 surrogate pair to code point, first, second, 0. Return the record, CP 2 false. 1 5 static semantics. String to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6, 1, 4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position, size. Let CP be code point at string, position, be append CP to code points. C set position to position plus CP. Return code points. 14. ECMA International 2024. 1 6 static semantics. Parse text, source text, goal symbol. The abstract operation parse text takes arguments source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMA script grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation defined, but at least one must be present. Note to see also clause 17. 1.2 Types of source code. There are 4 types of ECMA script code. Global code is source text that is treated as an ECMA script. The global code of a particular script does not include any source text that is parsed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMA script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is parsed to supply the value of the internal slots, C10.2, of an ECMA script function object. The function code of a particular ECMA script function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text matched by the binding identifier, if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse followed by an early errors parse might report the syntax error and not proceed to the early errors parse. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024-215. Text that is parsed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1. Function code is generally provided as the bodies of function definitions, 15.2, arrow function definitions, 15.3, method definitions, 15.4, generator function definitions, 15.5, async function definitions, 15.8, async generator function definitions, 15.6, and async arrow functions, 15.9. Function code is also derived from the argument. a syntax error if assignment target type of left-hand side expression is not simple. 3.1.5. To runtime semantics. Evaluation. Assignment expression. Left-hand side expression equals assignment expression. 82. If left-hand side expression is neither an object literal nor an array literal, then a letter of B. Evaluation of left-hand side expression. B is anonymous function definition, assignment expression, and is identifier ref of left-hand side expression are both true. Then I let val B. Named evaluation of assignment expression with argument ref. C else I let ref B. Evaluation of assignment expression. 2. Let val B. Get value ref D perform. Put value ref. Reval. Return reval. Let assignment pattern be the assignment pattern that is covered by left-hand side expression. ECMA International 2024. 3. Let ref B. Evaluation of assignment expression. Let val B. Get value ref. Perform. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N T, capital E, V, A, L, U, A, T, of assignment pattern with argument reval. Return reval. Assignment expression. Left-hand side expression. Assignment operator. Assignment expression. Let ref B. Evaluation of left-hand side expression. Let val B. Get value ref. Let ref B. Evaluation of assignment expression. Let val B. Get value ref. Let assignment op text be the source text matched by assignment operator. Let op text be the sequence of Unicode code points associated with assignment op text in the following table. Assignment op text equals percent plus equals and equals. Let R B. Capital A P P L Y. Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital O P E R. Val. Op text. Reval. Perform. Put value ref. R. Return R. Assignment expression. Left-hand side expression and equals assignment expression. Let ref B. Evaluation of left-hand side expression. Let val B. Get value ref. Let bool be to boolean val. If bool is false, return val. If is anonymous function definition, assignment expression, is true and is identifier ref of left-hand side expression is true, then a let val B. Named evaluation of assignment expression with argument ref. Else a let ref B. Evaluation of assignment expression. B let reval B. Get value ref. Perform. Put value ref. Reval. Return reval. Assignment expression. Left-hand side expression equals assignment expression. Let ref B. Evaluation of left-hand side expression. Let val B. Get value ref. Let bool be to boolean val. If bool is true, return val. If is anonymous function definition, assignment expression, is true and is identifier ref of left-hand side expression is true, then a let val B. Named evaluation of assignment expression with argument ref 6. Else a let ref B. Evaluation of assignment expression. B let reval B. Get value ref. ECMA International 2024 283 7. Perform. Put value ref. Reval. Return reval. Assignment expression. Left-hand side expression equals assignment expression. Let ref B. Evaluation of left-hand side expression. Let val B. Get value ref. If val is neither undefined nor null, return val. If is anonymous function definition, assignment expression, is true and is identifier ref of left-hand side expression is true, then a let val B. Named evaluation of assignment expression with argument ref. Else a let ref B. Evaluation of assignment expression. B let reval B. Get value ref. Perform. Put value ref. Reval. Return reval. 3.1.5. 3. Capital A P P L Y. Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital O P E R. Val. Op text. Reval. B abstract operation. Capital A P P L Y. Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital O P E R takes arguments val, any CMA script language value, optext, comma percent, plus, or, and reval, any CMA script language value, and returns either a normal completion containing either a string, a begint, or a number, or a throw completion. It performs the following steps when called. If optext is plus, then a letter from B. To primitive, val, be a letter from B. To primitive, reval, see if prim is a string or reprim is a string, then I let lstrb. To string, prim 2. Let rstrb. To string, reprim 3. Return the string concatenation of lstr and rstr, d set val till prim, e set reval to reprim. Note, at this point, it must be a numeric operation. Letter num b. To numeric, val, letter num b. To numeric, reval, if type, num, is not type, renum. Throw a type error exception. If num is a big int, then, note when this expression occurs within strict mode code, it is a runtime error if ref in step 1d, 2 is an unresolvable reference. If it is, a reference error exception is thrown. Additionally, it is a runtime error if the ref in step 8, 7, 6 is a reference to a data property with the attribute value, false, to an accessor property with the attribute value, abcd. Let if optext is, return, begint, exponentiate, num, renum. If optext is comma return, begint, divide, num, renum. If optext is percent, return, begint, remainder, num, renum. If optext is, return, begint, and signed right shift, num, renum. Operation be the abstract operation associated with optext and type, num. In the following table, 84, ECMA International 2024, optext type, num. Operation, number, exponentiate number, multiply begint, multiply number, divide number, remainder number, add, percent plus, number big int number, optext type, num plus big int, number big int, number big int, number big int, comma number big int, number big int, number big int. Operation, big int, add number, subtract big int, subtract number, left shift big int, left shift number, signed right shift big int, signed right shift number, and signed rig, ht shift number, bitwise and big int, bitwise and number, bitwise or big int, bitwise or number, bitwise or big int, bitwise or return operation, num, renum. Note 1, no hint is provided in the calls to primitive in steps 1a and 1b. All standard objects except dates handle the absence of a hint as if number were given. Dates handle the absence of a hint as if string were given. Exotic objects may handle the absence of a hint in some other manner. Note 2, step 1c differs from step 3 of the is less than algorithm by using the logical or operation instead of the logical and operation. 3, 1, 5, 4, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, left operand, optext, right operand. The abstract operation, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, takes arguments left operand, a parse node, optext, a sequence of Unicode code points, and right operand, a parse node, and returns either a normal completion containing either a string, a big int, or a number, or an abrupt completion. It performs the following steps when called. Letter FB. Evaluation of left operand. Letter val B. Get value. Ref. Letter FB. Evaluation of right operand. Letter val B. Get value. Ref. Return. Capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, val, optext, val, 3, 1, 5. 5. Destructuring assignment supplemental syntax. In certain circumstances when processing an instance of the production, assignment expression, left-hand side expression equals assignment expression. The interpretation of left-hand side expression is refined using the following grammar. Assignment pattern, yield, await, object assignment pattern yield await. Array assignment pattern yield await. ECMA International 2024 285. Object assignment pattern. Yield await. Assignment dress property yield await. Assignment property list yield await. Assignment property list yield await. Assignment dress property yield await opt. Array assignment pattern. Yield await. Eligible assignment dressed element yield await opt. Assignment element list yield await. Assignment element list yield await. Eligible assignment dressed element yield await opt. Assignment dress property. Yield await. Dart. Destructuring assignment target yield await. Assignment property list. Yield await. Assignment property yield await. Assignment property list yield await. Assignment property yield await. Assignment element list. Yield await. Assignment elision element yield await. Assignment element list yield await. Assignment elision element yield await. Assignment elision element. Yield await. Elision assignment element yield await. Assignment property. Yield await. Identifier reference yield await. Initializer. Class in yield await opt. Property name yield await. Assignment element yield await. Assignment element. Yield await. Destructuring assignment target yield await. Initializer. Class in yield await opt. Assignment dressed element. Yield await. Dart. Destructuring assignment target y. Yield await. Destructuring assignment target. Yield await. Left-hand side expression yield await. 3, 1, 5, 5, 1 static semantics. Early errors. Assignment property. Identifier reference initializer opt. It is a syntax error if assignment target type of identifier reference is not simple. Assignment dress property. Destructuring assignment target. It is a syntax error if destructuring assignment target is either an array literal or an object literal. Destructuring assignment target. Left-hand side expression. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. 86. Copyright sign. ECMA International 2024. It is a syntax error if assignment target type of left-hand side expression is not simple. 1, 3, 1, 5, 5. To runtime semantics. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T. The syntax directed operation. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T, takes argument value, any CMA script language value, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Object assignment pattern. Perform. Require object coercible. Value. Return unused. Object assignment pattern. Assignment property list. Assignment property list. Perform. Require object coercible. Value. Perform. Capital P, R, O, P, E, R, T, Y. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment property list with argument value. Return unused. Object assignment pattern. Assignment dress property. Perform. Require object coercible. Value. Let excluded names be a new empty list. Return. Capital R, E, S, T, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, of assignment dress property with arguments value and excluded names. Object assignment pattern. Assignment property list. Assignment dress property. Perform. Require object coercible. Value. Let excluded names be. Capital P, R, O, P, E, R, T, Y, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment property list with argument value. Return. Capital R, E, S, T, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I G N M E N T capital E V A of assignment dress property with arguments value and excluded names. Array assignment pattern. Let iterator record B. Get iterator value sync return. Iterator close. Iterator record. Normal completion unused. Array assignment pattern. Elision. Let iterator record B. Get iterator value sync. Let result be completion. Iterator destructuring assignment evaluation of elision with argument. Iterator record. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Elision launch assignment rest element. Let iterator record B. Get iterator value sync. If elision is present, then let status be completion. Iterator destructuring assignment evaluation of elision with argument iterator record. B if status is an abrupt completion, then I assert its iterator record is true. 2. Return status. Let result be completion. Iterator destructuring assignment evaluation of assignment rest element with argument iterator record. ECMA International 2024 287. 4. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Assignment element list. Let iterator record B. Get iterator value sync. Let result be completion. Iterator destructuring assignment evaluation of assignment element list with argument iterator record. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Assignment element list. Elision launch assignment rest element opt. Let iterator record B. Get iterator value sync. Let status be completion. Iterator destructuring assignment evaluation of assignment element list with argument iterator record. If status is an abrupt completion, then if iterator record is false, return. Iterator close. Iterator record. Status. B return status. If elision is present, then assert status to completion. Iterator destructuring assignment evaluation of elision with argument iterator record. B if status is an abrupt completion, then I assert iterator record is true. 2. Return status. If assignment rest element is present, then assert status to completion. Iterator destructuring assignment evaluation of assignment rest element with argument iterator record. If iterator record is false, return. Iterator close. Iterator record. Status. Return status. 3. 1 5 5 3 runtime semantics. Capital P R O P E R T Y. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N. The syntax directed operation. Capital P R O P E R T Y. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N takes argument value, any CMA script language value, and returns either a normal completion containing a list of property keys or an abrupt completion. It collects a list of all destructured property keys. It is defined piecewise over the following productions: assignment property list, assignment property list, assignment property. Let property names be capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N of assignment property list with argument value. Let next names be capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N of assignment property with argument value. Return the list concatenation of property names and next names. Assignment property identifier reference initializer opt. Let P be string value of identifier reference. Let ref B. Resolve binding. P let V be jet value. P if initializer is present and V is undefined. Then if is anonymous function definition initializer is true. Then I set v2. Named evaluation of initializer with argument P be else I let default value be. Evaluation of initializer 2. Set v2. Get value. Default value. Perform. Put value. Ref. V. Return P. 88. ECMA International 2024. Assignment property. Property name. Assignment element. Let name be Evaluation of property name. Perform. Capital K, E, Y, E, D, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, of assignment element with arguments value and name. Return name. 3, 1, 5, 5. For runtime semantics. Capital R, E, S, T, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A. The syntax-directed operation. Capital R, E, S, T, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, takes arguments value, an ECMA script language value, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Assignment rest property. Destructuring assignment target. Lasler FB. Evaluation of destructuring assignment target. Let rest objb ordinary object create. Percent object prototype percent. Perform. Copy data properties. Rest obj. Value. Excluded names. Return. Put value. Ref. Rest obj. 3, 1, 5, 5. 5 runtime semantics. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N. The syntax-directed operation. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, takes argument iterator record, an iterator record, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Assignment element list. Assignment elision element. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment elision element with argument iterator record. Assignment element list. Assignment element list. Assignment elision element. Perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment element list with argument iterator record. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment elision element with argument iterator record. Assignment elision element. Assignment element. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment element with argument iterator record. Assignment elision element. Elision assignment element. Perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Return. capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment element with argument iterator record. Elision. If iterator record is false, then a let next be completion, iterator step, iterator record. B if next is abrupt completion, set iterator record to true. C return if abrupt. Next. D if next is false, set iterator record to true. Return unused. Elision. Elision. Perform. Capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of elision with argument iterator record. If iterator record is false, then a let next be completion, iterator step, iterator record. B if next is an abrupt completion, set iterator record to true. EGMA International 2024 289. C return if abrupt. Next. D if next is false, set iterator record to true 3. Return unused. Assignment element. Destructuring assignment target initial is eropt. If destructuring assignment target is neither an object literal nor an array literal, then elect if B. Evaluation of destructuring assignment target. Let value be undefined. If iterator record is false, then elect next B. Iterator step value. Iterator record. B if next is not done, then I set value to next. If initializer is present and value is undefined, then A if is anonymous function definition, initializer, is true and is identifier ref of destructuring assignment target is true, then I let VB. Named evaluation of initializer with argument ref B else. I let default value B. Evaluation of initializer 2. Let VB. Get value. Default value else a let VB value. If destructuring assignment target is either an object literal or an array literal, then a let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target be return. Capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A L U A T, of nested assignment pattern with argument V. Return. Put value. Ref. V. Assignment rest element. Destructuring assignment target. If destructuring assignment target is neither an object literal nor an array literal, then elect ref B. Evaluation of destructuring assignment target. Let A be. Array create. 0. Let 0. Repeat. While iterator record is false, elect next B. Iterator step value. Iterator record. B if next is not done, then I perform. Create data property or throw A. To string n. Next 2. Set n to n plus 1. If destructuring assignment target is neither an object literal nor an array literal, then a return. Put value. Ref. A. Let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target. Return. Capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A L U A T, of nested assignment pattern with argument A. 3, 1, 5, 5, 6 runtime semantics, capital K E Y E D, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V. The syntax directed operation, capital K E Y E D, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V. Takes arguments value, an ECMA script language value, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Assignment element. Destructuring assignment target initial is eropt. If destructuring assignment target is neither an object literal nor an array literal, then elect ref B. Evaluation of destructuring assignment target. Let VB. Jet. Value. Property name. If initializer is present and V is undefined, then 290. ECMA International 2024. Note left to right evaluation order is maintained by evaluating a destructuring assignment target that is not a destructuring pattern prior to accessing the iterator or evaluating the initializer. If is anonymous function definition, initializer, and is identifier ref of destructuring assignment target to both true. Then, I let RHS value be. Named evaluation of initializer with argument ref be else. I let default value be. Evaluation of initializer 2. Let RHS value be. Get value, default value, else. A let RHS value be v. If destructuring assignment target is eat, her an object literal or an array literal. Then, a let assignment pattern be the assignment pattern that is covered by destructuring assignment target. Be return. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T, of assignment pattern with argument RHS value. Return. Put value, ref. RHS value 3.16, operator, syntax, expression, in, yield, await, assignment expression in yield await, expression in yield await, assignment expression in yield await, 1316, 1 runtime semantics, evaluation, expression, expression, assignment expression, let ref be. Evaluation of expression, perform. Get value, ref, let ref be. Evaluation of assignment expression, return. Get value, ref, for ECMA script language. Statements and declarations syntax. Statement, yield, await, return. Block statement yield await return. Variable statement yield await. Empty statement expression statement yield await. If statement yield await return. Breakable statement yield await return. Continue statement yield await. Break statement yield await. Plus return. Return statement yield await. With statement yield await return. Labeled statement yield await return. Throw statement yield await. Try statement yield await return. Debugger statement. Note get value must be called even though its value is not used because it may have observable side effects. ECMA International 2024 291. Declaration. Yield. Await. Hoistable declaration yield await. Default. Class declaration yield await. Default. Lexical declaration. Plus in yield await. Hoistable declaration. Yield. Await. Default. Function declaration yield await default. Generator declaration yield await default. Async function declaration yield await default. Async generator declaration yield await default. Breakable statement. Yield. Await. Return. Iteration statement yield await return. Switch statement yield await return. 4.1 statement semantics. 4. 1. 1 runtime semantics. Evaluation. Hoistable declaration. Generator declaration. Async function declaration. Async generator declaration. Return empty. Hoistable declaration. Function declaration. Return. Evaluation of function declaration. Breakable statement. Iteration statement. Switch statement. Let new label set be a new empty list. Return. Labeled evaluation of this breakable statement with argument new label set. 4.2 block syntax. Block statement. Yield. Await. Return. Block yield await return. Block. Yield. Await. Return. Statement list yield await return opt. Statement list. Yield. Await. Return. Statement list item yield await return. Statement list yield await return. Statement list item yield await return. Statement list item. Yield. Await. Return. Statement yield await return. Declaration yield await. 92. ECMA International 2024. 142. 1 static semantics. Early errors. Block. Statement list. It is a syntax error if the lexic, ally declared names of statement list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of statement list also occurs in the are declared names of statement list. 4. 2. 2 runtime semantics. Evaluation. Block. Return empty. Block. Statement list. Let old env be the running execution context's lexical environment. Let block env the new declarative environment. Old env. Perform block declaration instantiation. Statement list. Block env. Set the running execution context's lexical environment to block env. Let block value be completion. Evaluation of statement list. Set the running execution context's lexical environment to old env. Return block value. Statement list. Statement list item. Let SLB. Evaluation of statement list. Let S be completion. Evaluation of statement list item. Return. Update empty. S. SL. 4. 2. 3 block declaration instantiation. Code. env. The abstract operation block declaration instantiation takes arguments code. A parse node. And env. A declarative environment record. and returns unused code is the parse node corresponding to the body of the block. env is the environment record in which bindings are to be created. It performs the following steps when called. Let declarations be the lexically scoped declarations of code. Let private env be the running execution context's private environment. For each element D of declarations, do a for each element dn of the bound names of D, do ECMA International 2024-293. Note 1. No matter how control leaves the block, the lexical environment is always restored to its former state. Note 2. The value of a statement list is the value of the last value producing item in the statement list. For example, the following calls to the eval function all return the value 1, eval, 1, eval, 1, eval, 1, var a. Note when a block or case block is evaluated, a new declarative environment record is created and bindings for each block scope variable, constant, function, or class declared in the block are instantiated in the environment record. If this constant declaration of D is true, then perform env create a mutable binding, dn, true, 2. Else, perform env create mutable binding, dn, false. Note, the step is replaced in section B, 3, 2, 6. B if D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration, then I let fn be the sole element of the bound names of D. 2. Let fo be instantiate function object of D with arguments env and private env. 3. Perform env initialize binding, fn, fo. Note, the step is replaced in section B, 3, 2, 6. Return unused. 4.3 declarations in the variable statement. 4, 3, 1. Syntax. Lexical declaration. In. Yield. Await. Let or const binding list and yield await. Let or const. Let const binding list. In. Yield. Await. Lexical binding and yield await. Capital B. Binding list and yield await. Lexical binding and yield await. Lexical binding. In. Yield. Await. Binding identifier yield await. Initializer and yield await opt. Binding pattern yield await. Initializer and yield await. 4, 3, 1. 1 static semantics. Early errors. Lexical declaration. Let or const binding list. It is a syntax error if the bound names of binding list contains let. It is a syntax error if the bound names of binding list contains any duplicate entries. Lexical binding. Binding identifier initializer opt. It is a syntax error if initializer is not present and is constant declaration of the lexical declaration containing this lexical binding is true. 94. ECMA International 2024. Let and const declarations. Let and const declarations define variables that are scoped to the running execution contexts. Note, lexical environment. The variables are created when their containing environment record is instantiated but may not be accessed in any way until the variable's lexical binding is evaluated. A variable defined by a lexical binding with an initializer is assigned the value of its initializer's assignment expression when the lexical binding is evaluated, not when the variable is created. If a lexical binding in a let declaration does not have an initializer, the variable is assigned the value undefined when the lexical binding is evaluated. 1, 4, 3, 1. 2 runtime semantics. Evaluation. Lexical declaration. Let or const binding list. Perform. Evaluation of binding list. Return empty. Binding list. Binding list. Lexical binding. Perform. Evaluation of binding list. Return. Evaluation of lexical binding. Lexical binding. Binding identifier. Let LHS be. Resolve binding. String value of binding identifier. Perform. Initialize reference binding. LHS. Undefined. Return empty. Lexical binding. Binding identifier initializer. Let binding id be string value of binding identifier. Let LHS be. Resolve binding. Binding id. If is anonymous function definition, initializer, is true, then a let value be. Named evaluation of initializer with argument binding id. Else a let RHS be. Evaluation of initializer, be let value be. Get value, RHS. Perform. Initialize reference binding, LHS, value. Return empty. Lexical binding. Binding pattern initializer. Let RHS be. Evaluation of initializer. Let value be. Get value, RHS. Let env be the running execution context's lexical environment. Return. Binding initialization of binding pattern with arguments value and env. 4, 3, 2 variable statement. Syntax. Variable statement. Yield. Await. Our variable declaration list. Plus and yield await. A static semantics rule ensures that this form of lexical binding never occurs in a const. Note, declaration. A var statement declares variables that are scoped to the running execution contexts. Note, variable environment. Our variables are created when their containing environment record is instantiate, and are initialized to undefined when created. Within the scope of any variable environment, a common binding identifier may appear in more than one variable declaration, but those declarations collectively define only one variable. A variable defined by a variable declaration with an initializer is assigned the value of its initializer's assignment expression when the variable declaration is executed, not when the variable is created. ECMA International 2024 295. Variable declaration list. In yield await. Variable declaration in yield await. Variable declaration list in yield await. Variable declaration in yield await. Variable declaration in yield await. Binding identifier yield await. Initializer in yield await opt. Binding pattern yield await. Initializer in yield await. 4, 3, 2, 1. Runtime semantics. Evaluation. Variable statement. var variable declaration list. Perform. Evaluation of variable declaration list. Return empty. Variable declaration list. Variable declaration list. Variable declaration. Perform. Evaluation of variable declaration list. Return. Evaluation of variable declaration. Variable declaration. Binding identifier 1. Return empty. Variable declaration. Binding identifier initializer. Let binding id be string value of binding identifier. Let LHS be. Resolve binding. Binding id. If is anonymous function definition, initializer, is true, then a let value be. Named evaluation of initializer with argument binding id. Else a let RHS be. Evaluation of initializer be let value be. Get value, RHS. Perform. Put value, LHS. Value. Return empty. Variable declaration. Binding pattern initializer. Let RHS be. Evaluation of initializer. Let val be. Get value, RHS. Return. Binding initialization of binding pattern with arguments revalent undefined. 4, 3, 3. Destructuring binding pattern syntax. Binding pattern. Yield. Await. Object binding pattern yield await. Array binding pattern yield await. Note if a variable declaration is nested within a with statement and the binding identifier in the variable declaration is the same as a property name of the binding object of the with statement's object environment record. Then step 5 will assign value to the property instead of assigning to the variable environment binding of the identifier. 96. ECMA International 2024. Object binding pattern. Yield. Await. Binding rest property yield await. Binding property list yield await. Binding property list yield await. Binding rest property yield await opt. Array binding pattern. Yield. Await. Elegant binding rest element yield await opt. Binding element list yield await. Binding element list yield await. Elegant binding rest element yield await opt. Binding rest property. Yield. Await. Dart. Binding identifier yield await. Binding property list. Yield. Await. Binding property yield await. Binding property list yield. Question mark await. Binding property yield await. Binding element list. Yield. Await. Binding elision element yield await. Binding element list yield await. Binding elision element yield await. Binding elision element. Yield. Await. Elegant binding element yield await. Binding property. Yield. Await. Single name binding yield await. Property name yield await. Binding element yield await. Binding element. Yield. Await. Single name binding yield await. Binding pattern yield await. Initializer. Plus in yield await opt. Single name binding. Yield. Await. Binding identifier yield await. Initializer. Plus in yield await opt. Binding rest element. Yield. Await. Dart. Binding identifier yield await. Binding pattern yield await. 4, 3, 3, 1. Runtime semantics. Property binding initialization. The syntax-directed operation property binding initialization takes arguments value, any CMA script language value, and environment record or undefined, and returns either a normal completion contain either a list of property keys or an abrupt completion. It collects a list of all bound property names. It is defined piecewise over the following productions: binding property list, binding property list, binding property. Let bound names be. Property binding initialization of binding property list with arguments value and environment. Let next names be. Property binding initialization of binding property with arguments value and environment. Return the list concatenation of bound names and next names. ECMA International 2024 297. Binding property. Single name binding. Let name be the sole element of the bound names of single name binding. Perform. Keep binding initialization of single name binding with arguments value, environment, and name. Return name. Binding property. Property name. Binding element. Let PB. Evaluation of property name. Perform. Keep binding initialization of binding element with arguments value, environment, and P. Return P. 4, 3, 3, 2. Runtime semantics. Rest binding initialization. The syntax-directed operation rest binding initialization takes arguments value, any CMA script language value, environment and environment record or undefined, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: binding rest property, binding identifier. Let LHS be. Resolve binding. String value of binding identifier. Environment. Let rest objb ordinary object create. Percent object prototype percent. Perform. Copy data properties. REST OBJ. Value. Excluded names. If environment is undefined, return. Put value. LHS. REST OBJ. Return. Initialize reference binding. LHS. REST OBJ. 4, 3, 3, 3 runtime semantics. Keep binding initialization. The syntax-directed operation keep binding initialization takes arguments value, any CMA script language value, environment and environment record or run, defined, and property name, a property key, and returns either a normal completion containing a new store and abrupt completion. It is defined piecewise over the following productions. Binding element, binding pattern initializer opt, let VB, jet, value, property name. If initializer is present and v is undefined, then let default value be. Evaluation of initializer, set v2. Get value, default value, return. Binding initialization of binding pattern with arguments v and environment. Single name binding, binding identifier initializer opt. Let binding id be string value of binding identifier. Let LHS be. Resolve binding, binding id, environment. Let vb, jet, value, property name. If initializer is present and v is undefined, then if is anonymous function definition, initializer, is true, then I set v2. Named evaluation of initializer with argument binding id, be else. Note when undefined is passed for environment, it indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 98. ECMA International 2024. I2. Let default value be. Evaluation of initializer. Semfia2. Get value. Default value. 5. If environment is undefined, return. Put value. LHS. V. Return. Initialize reference binding. LHS. V. 4.4 empty statement syntax. Empty statement. 4. 4. 1 runtime semantics. Evaluation. Empty statement. 1. Return empty. 4.5 express. X argument label set. A list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Breakable statement, iteration statement. Let STMT result be completion. Loop evaluation of iteration statement with argument label set. If STMT result is a break completion, then if STMT result is empty, then if STMT result is empty, set STMT result to normal completion, undefined. 2. Else. Set STMT result to normal completion. STMT result. Return STMT result. Breakable statement. Switch statement. Let STMT result be completion. Evaluation of switch statement. If STMT result is a break completion, then if STMT result is empty, then if STMT result is empty, set STMT result to normal completion, undefined. 2. Else. Set STMT result to normal completion. STMT result. Return STMT result. Note 1. A breakable statement is one that can be exited via an unlabeled break statement. Labeled statement. Label identifier. Labeled item. Let label be the string value of label identifier. Let new label set be the list concatenation of label set and label. Let STMT result be completion. Labeled evaluation of labeled item with argument new label set. If STMT result is a break completion and STMT result is label, then A set STMT result to normal completion. STMT result 5. Return STMT result. Labeled item. Function declaration. Return. Evaluation of function declaration. Statement. Block statement. Variable statement. Empty statement. Expression statement. If statement. Continue statement. Break statement. Return statement with statement. Throw statement. Try statement. Debugger statement. Return. Evaluation of statement. Note 2. The only 2 productions of statement which have special semantics for labeled evaluation are breakable statement and labeled statement. ECMA International 2024 319. 14.14 Throw statement syntax. Throw statement. Yield. Await. Throw. No line terminator here. Expression. Plus in yield await. 4. 1 4. 1 runtime semantics. Evaluation. Throw statement. Throw expression. Let x per f be. Evaluation of expression. Let x per value be. Get value. X per f. Return. Throw completion. X per value. 4.15 Three statement syntax. Try statement. Yield. Await. Return. Try block yield await return. Catch yield await return. Try block yield await return. Finally yield await return. Try block yield await return. Catch yield await return. Finally yield await return. Catch. Yield. Await. Return. Catch. Catch parameter yield await. Block yield await return. Catch block yield await return. Finally. Yield. Await. Return. Finally block yield await return. Catch parameter. Yield. Await. Binding identifier yield await. Binding pattern yield await. 4. 1 5. 1 static semantics. Early errors. Catch. catch parameter, block. It is a syntax error if bound names of catch parameter contains any duplicate elements. It is a syntax error if any element of the bound names of catch parameter also occurs in the lexically declared names of block. It is a syntax error if any element of the bound names of catch parameter also occurs in the are declared names of block. Note an alternative static semantics for this production is given in B. 3.4. Note, the try statement encloses a block of code in which an exceptional condition can occur, such as a runtime error or a throw statement. The catch clause provides the exception handling code. When a catch clause catches an exception, its catch parameter is bound to that exception. 320. ECMA International 2024. 1415. To runtime semantics. Catch clause evaluation. The syntax-directed operation catch clause evaluation takes argument thrown value, an ECMA script language value, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Catch parameter, block. Let old env be the running execution context's lexical environment. Let catch env be new declarative environment. Old env, for each element arg name of the bound names of catch parameter, do a perform catch env create mutable binding, arg name, false. Set the running execution context's lexical environment. Catch env, let status be completion, binding initialization of catch parameter with arguments thrown value and catch env, if status is an abrupt completion, then A set the running execution context's lexical environment to old env, B return status. Let B be completion, evaluation of block. Set the running execution context's lexical environment to old env, return. B catch block, return. Evaluation of block. 415. 3 runtime semantics. Evaluation. Try statement. Try block catch. Let B be completion. Evaluation of block. If B is a throw completion, let C be completion. Catch clause evaluation of catch with argument B. Else. Let C be B. Return. Update empty. C. Undefined. Try statement. Try block finally. Let B be completion. Evaluation of block. Let F be completion. Evaluation of finally. If F is a normal completion, set F to B. Return. Update empty. F. Undefined. Try statement. Try block catch finally. Let B be completion. Evaluation of block. If B is a throw completion, let C be completion. Catch clause evaluation of catch with argument B. Else. Let C be B. Let F be completion. Evaluation of finally. If F is a normal completion, set F to C. Return. Update empty. F. Undefined. Note no matter how control leaves the block, the lexical environment is always restored to its former state. ECMA International 2024 321. 14.16 The debugger statement syntax. Debugger statement. Debugger. 416. 1 runtime semantics. Evaluation. Debugger statement. Debugger. If an implementation-defined debugging facility is available and enabled, then a perform an implementation-defined debugging action. B return a new implementation-defined completion record. Else a return empty. 5 ECMA script language. Functions and classes. 5.1 parameter list syntax. Unique formal parameters. Yield. Await. Formal parameters yield await. Formal parameters. Yield. Await. Empty. Function rest parameter yield await. Formal parameter list yield await. Formal parameter list yield await. Formal parameter list yield await. Function rest parameter yield await. Formal parameter list. Yield. Await. Formal parameter yield await. Formal parameter list yield await. Formal parameter yield await. Function rest parameter. Yield. Await. Binding rest element yield await. Formal parameter. Yield. Await. Binding element yield await. 5. 1. 1 static semantics. Early errors. Unique formal parameters. Formal parameters. 22. Copyright sign. ECMA International 2024. Note evaluating a debugger statement may allow an implementation to cause a breakpoint when run under a debugger. If a debugger is not present or active, this statement has no observable effect. Note various ECMA script language elements cause the creation of ECMA script function objects. 10.2. Evaluation of such functions starts with the execution of their internal method. 10. 2. 1. It is a syntax error if bound names of formal parameters contains any duplicate elements. Formal parameters. Formal parameter list. It is a syntax error if this simple parameter list of formal parameter list is false and bound names of formal parameter list contains any duplicate elements. 5. 1. 2 static semantics. Contains expression. The syntax-directed operation contains expression, takes no arguments and returns a boolean. It is defined piecewise over the following productions. Object binding pattern. Binding rest property. 1. Return false. Object binding pattern. Binding property list. Binding rest property. 1. Return contains expression of binding property list. Array binding pattern. Elegant. 1. Return false. Array binding pattern. Elegant binding rest element. 1. Return contains expression of binding rest element. Array binding pattern. Binding element list. Elegant. 1. Return contains expression of binding element list, array binding pattern, binding element list, eligible binding rest element. Let us be contains expression of binding element list. If is true, return true. Return contains expression of binding rest element, binding property list, binding property list, binding property. Let us be contains expression of binding property list. If is true, return true. Return contains expression of binding property, binding element list, binding element list, binding elision element. Let us be contains expression of binding element list. If is true, return true. Return contains expression of binding G elision element, binding elision element, elision binding element 1. Return contains expression of binding element. Note multiple occurrences of the same binding identifier in a formal parameter list is only allowed for functions which have simple parameter lists and which are not defined in strict mode code. ECMA International 2024-323. Binding property, property name, binding element. Let us be as computed property key of property name. If is true, return true. Return contains expression of binding element, binding pattern initializer 1. Return true, single name binding identifier 1. Return false, single name binding identifier initializer 1. Return true, binding rest element, binding identifier 1. Return false, binding rest element. Binding pattern. Return contains expression of binding pattern, formal parameters, empty, 1. Return false, formal parameters, formal parameter list. Function rest parameter. If contains expression of formal parameter list is true, return true. Return contains expression of function rest parameter, formal parameter list, formal parameter list. Formal parameter. If contains expression of formal parameter list is true, return true. Return contains expression of formal parameter. Arrow parameters. Binding identifier 1. Return false. Arrow parameters. Capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Let formals be the array formal parameters that is covered by capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Return contains expression of formals. A arrow binding identifier, return false, 5, 1. 3 static semantics is simple parameter list. The syntax directed operation is simple parameter list takes no arguments and returns a boolean. It is defined piecewise over the following productions. Binding element, binding pattern, return false 324. ECMA International 2024. Binding element, binding pattern initializer 1. Return false, single name binding identifier 1. Return true, single name binding identifier initializer 1. Return false, formal parameters, empty, 1. Return true, formal parameters, function rest parameter 1. Return false, formal parameters, formal parameter list, function rest parameter 1. Return false, formal parameter list, formal parameter list, formal parameter. If a simple parameter list of formal parameter list is false, return false. Return is simple parameter list of formal parameter, binding element. Return is simple parameter list of binding element. Arrow parameters, binding identifier, return true. Arrow parameters, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Let formals be the array formal parameters that is covered by capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S. capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Return is simple parameter list of head 5 1. For static semantics has initializer. The syntax-directed operation has initializer takes no arguments and returns a boolean. It is defined piecewise over the following productions: binding element, binding pattern, return false. ECMA International 2024 325. Binding element, binding pattern initializer 1. Return true, single name binding, binding identifier 1. Return false, single name binding, binding identifier initializer 1. Return true, formal parameter list, formal parameter list. Formal parameter. If his initializer of formal parameter list is true, return true. Return has initializer of formal parameter. 5 1. 5 static semantics. Expected argument count. The syntax-directed operation expected argument count takes no arguments and returns an integer. It is defined piecewise over the following productions: formal parameters, empty, function rest parameter, return 0, formal parameters, formal parameter list, function rest parameter, return expected argument count of formal parameter list, formal parameter list. Formal parameter. If his initializer of formal parameter is true, return 0, return 1, formal parameter list, formal parameter list, formal parameter. Let count be expected argument count of formal parameter list. If his initializer of formal parameter list is true or has initializer of formal parameter is true, return count plus 1, arrow parameters, binding identifier 1, return 1, arrow parameters, capital C O V E R, capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Note the expected argument count of a formal parameter list is the number of formal parameters to the left of either the rest parameter or the first formal parameter with an initializer. A formal parameter without an initializer is allowed after the first parameter with an initializer, but such parameters are considered to be optional with undefined as their default value. 2. Let formals be the arrow formal parameters that is covered by capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Return expected argument count of formals. 26. ECMA International 2024. Property set parameter list. Formal parameter. If his initializer of formal parameter is true, return 0, return 1. A sim arrow binding identifier 1. Return 1. 5.2 function definition syntax. Function declaration. Yield. Await. Default. Function binding identifier yield await. Formal parameters. Yield. Await. Function body. Yield. Await. Plus default. Function. Formal parameters. Yield. Await. Function body. Yield. Await. Function expression. Function binding identifier. Yield. Await opt formal parameters. Yield. Await. Function body. Yield. Await. Function body. Yield. Await. Function statement list yield await. Function statement list. Yield. Await. Statement list yield await. Plus return opt 1 5 2 1 static semantics. Early errors. Function declaration. Function binding identifier. Formal parameters. Function body. Function. Formal parameters. Function body. Function expression. Function binding identifier opt. Formal parameters. Function body. If the source text matched by formal parameters is strict mode code, the early error rules for unique formal parameters. Formal parameters are applied if binding identifier is present and the source text matched by binding identifier is strict mode code. It is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if function body contains use strict of function body is true and is simple parameter list of formal parameters is false. It is a syntax error if any element of the bound names of formal parameters also occurs in the lexically declared names of function body. It is a syntax error if formal parameters contains super property is true. It is a syntax error if function body contains super property is true. It is a syntax error if formal parameters contains supercall is true. It is a syntax error if function body contains supercall is true. Function body. Function statement list. It is a syntax error if the lexically declared names of function statement list contains any duplicate entries. Note the lexically declared names of a function body does not include identifiers bound using var or function declarations. ECMA International 2024 327. It is a syntax error if any element of the lexically declared names of function statement list also occurs in the var declared names of function statement list. It is a syntax error if contains duplicate labels of function statement list with argument is true. It is a syntax error if contains undefined break target of function statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E a function statement list with arguments and is true. 5. 2. Static semantics. Function body contains use strict. The syntax directed operation function body contains use strict takes no arguments and returns a boolean. It is defined piecewise over the following productions. Function body. Function statement list. If the directive prologue of function body contains a use strict directive, return true. Otherwise, return false. 5. 2. 3 runtime semantics. Evaluate function body. The syntax directed operation evaluate function body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. Function body. Function statement list. Perform. Capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I function object arguments list. Return. Evaluation of function statement list. 5. 2. For runtime semantics. Capital I N S T A N T I A T E capital O R D I N A R Y capital F U N C T I O N capital O B J. The syntax directed operation. Capital I N S T A N T I A T E capital O R D I N A R Y capital F U N C T I O N capital O B J takes argument CMV, an environment record, and private ENV, a private environment record or null, and returns an ECMA script function object. It is defined piecewise over the following productions. Function declaration, function binding identifier, formal parameters, function body. Let name be string value of binding identifier. Let source text be the source text matched by function declaration. Let f be ordinary function create. Percent function prototype percent, source text, formal parameters, function body, non-lexical this, env, private env, perform set function name, f, name, perform make constructor, f, return f, function declaration, function, formal parameters, function body. Let source text be the source text matched by function declaration. Let f be ordinary function create, percent function prototype percent, source text, formal parameters, function body, non-lexical this, env, private env, perform set function name, f, default, perform make constructor, f, return f, 328, ECMA International 2024. An anonymous function declaration can only occur as part of an export default declaration. Note, and its function code is therefore always strict mode code. 152. 5 runtime semantics. Capital I N S T A N T I A T E capital O R D I N A R Y capital F U N C T I O N capital E X P. The syntax directed operation. Capital I N S T A N T I A T E capital O R D I N A R Y capital F U N C T I O N capital E X P takes optional argument name, a property key or a private name, and returns an ECMA script function object. It is defined piecewise over the following productions: function expression, function, formal parameters, function body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by function expression. Let closure be ordinary function create. Function prototype source text, formal parameters, function body, non-lexical is, env, private env, perform set function name, closure, name, perform make constructor, closure, return closure, function expression, function binding identifier, formal parameters, function body, assert, name is not present, set name to string value of binding identifier. Let outer env be the running execution context's lexical environment. Let funky env be new declarative environment. Outer env, perform funky env create immutable binding. Name, false. Let private env be the running execution context's private environment. Let source text be the source text matched by function expression. Let closure be ordinary function create. Function prototype source text, formal parameters, function body, non-lexical is. Funct env, private env, perform set function name, closure, name 0, perform make constructor, closure 1, perform func env initialize binding, name, closure 2, return closure 5, 2, 6 runtime semantics, evaluation, function declaration, function binding identifier, formal parameters, function body 1. Return empty. Note 1 an alternative cement. Ix is provided in B 3.2. Function declaration, function, formal parameters, function body 1. Return empty. Function expression, function binding identifier, formal parameters, function body 1. Return capital I N S T A N T I A T E capital O R D I N A R Y, capital F U N C T I O N, capital E X P, a function expression. Note the binding identifier in a function expression can be referenced from inside the function expression's function body to allow the function to call itself recursively. However, unlike in a function declaration, the binding identifier in a function expression cannot be referenced from and does not affect the scope enclosing the function expression. Note 2 a prototype property is automatically created for every function defined using a function declaration or function expression to allow for the possibility that the function will be used as a constructor. ECMA International 2024-329. Function statement list. Empty. 1. Return undefined. 5.3 arrow function definitions syntax. Arrow function in yield await. Arrow parameters yield await. No line terminator here equals concise body in capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N yield await. Concise body in look ahead. Expression body in await. Function body yield await. Expression body in await. Assignment expression in yield await. Supplemental syntax. When processing an instance of the production, arrow parameters yield await. Capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N yield await. The interpretation of capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N is refined using the following grammar. Arrow formal parameters yield await. Unique formal parameters yield await. 5, 3, 1 static semantics. Early errors. Arrow function. Arrow parameters equals concise body. It is a syntax error if arrow parameters contains yield expression is true. It is a syntax error if arrow parameters contains await expression is true. It is a syntax error if concise body contains use strict of concise body is true and is simple parameter list of arrow parameters is false. It is a syntax error if any element of the bound names of arrow parameters also occurs in the lexically declared names of concise body. Arrow parameters. Capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N must cover an arrow formal parameters 1 5 3 2 static semantics. Concise body contains use strict. The syntax directed operation concise body contains use strict takes no arguments and returns a boolean. It is defined piecewise over the following productions: concise body, expression body, return false. 30. ECMA International 2024. Arrow parameters: yield, await, binding identifier yield await, concise body, function body, return function body contains use strict of function body. 5 3 3 runtime semantics. Evaluate concise body. The syntax directed operation evaluate concise body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA-esque script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions: concise body, expression body, perform. Capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I function object, arguments list, return. Evaluation of expression body. 5 3 4 runtime semantics. Capital I N S T A N T I A T E capital A R R O W capital F U N C T I O N capital E X P R E S. The syntax directed operation. Capital I N S T A N T I A T E capital A R R O W capital F U N C T I O N capital E X P R E S takes optional argument name, a property key or a private name, and returns an ECMA script function object. It is defined piecewise over the following productions: arrow function, arrow parameters equals, concise body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by arrow function. Let closure be ordinary function create. Percent function prototype percent, source text, arrow parameters, concise body, lexical this, env, private env, perform set function name, closure, name, return closure. An arrow function does not define local bindings for arguments, super, this, or new target. Note, any reference to arguments, super, this, or new target within an arrow function must resolve to a binding in a lexically enclosing environment. Typically this will be the function environment of an immediately enclosing function. Even though an arrow function may contain references to super, the function object created in step 5 is not made into a method by performing make method. An arrow function that references super is always contained within an on-arrow function, and the necessary state to implement super is accessible via the env that is captured by the function object of the arrow function. 5 3 5 runtime semantics. Evaluation. Arrow function, arrow parameters equals, concise body, return, capital I N S T A N T I A T E capital A R R O W capital F U N C T I O N capital E X P R E S of arrow function. Expression body. Assignment expression. Let x per f be. Evaluation of assignment expression. Let x per value be. Get value, x per f. Return completion record. Return, x per value. Empty. ECMA International 2024 331. 15.4 Method definition syntax. Method definition. Yield, await. Class element name yield await. Unique formal parameters. Yield, await. Function body. Yield, await. Generator method yield await. Async method yield await. Async generator method yield await. Get class element name yield await. Function body. Yield, await. set class element name yield await, property set parameter list, function body, yield, await, property set parameter list, formal parameter, yield, await, 154, 1 static semantics, early errors, method definition, class element name, unique formal parameters, function body. It is a syntax error if function body contains use strict if function body is true and is simple parameter list of unique formal parameters is false. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically declared names of function body. Method definition, set class element name, property set parameter list. Function body. It is a syntax error if bound names of property set parameter list contains any duplicate elements. It is a syntax error if function body contains use strict if function body is true and is simple parameter list of property set parameter list is false. It is a syntax error if any element of the bound names of property set parameter list also occurs in the lexically declared names of function body. 5, 4, to static semantics. Has direct super. The syntax directed operation has direct super takes no arguments and returns a boolean. It is defined piecewise over the following productions. Method definition, class element name, unique formal parameters, function body. If unique formal parameters contain supercall is true, return true. Return function body contains supercall. Method definition, get class element name, function body, 1. Return function body contains supercall. Method definition, set class element name, property set parameter list. Function body. If property set parameter list contains supercall is true, return true. Return function body contains supercall. Generate a method, class element name, unique formal parameters, generate a body. 2. If unique formal parameters contains supercall is true, return true. Return generate a body contains supercall. 32. ECMA International 2024. Async generate a method, async class element name, unique formal parameters, async generate a body. If unique formal parameters contains supercall is true, return true. Return async generate a body contains supercall. Async method, async class element name, unique formal parameters, async function body. If unique formal parameters contains supercall is true, return true. Return async function body contains supercall. 5, 4, 3 static semantics. Special method. The syntax directed operation special method takes no arguments and returns a boolean. It is defined piecewise over the following productions. Method definition, class element name, unique formal parameters, function body, return false. Method definition, generate a method, async generate a method, get class element name, function body, set class element name, property set parameter list, function body, return true. 5, 4, 4 runtime semantics, define method. The syntax directed operation define method takes argument object, an object, and optional argument function prototype, an object, and returns either a normal completion containing a record with fields, an ECMA script function object, or an abrupt completion. It is defined piecewise over the following productions. Method definition, class element name, unique formal parameters, function body, let proc key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. If function prototype is present, then a let prototype be function prototype 5. Else, a let prototype be %function prototype %. Let source text be the source text matched by method definition. Let closure be ordinary function create, prototype, source text, unique formal parameters, function body, non-lexical this, env, private env, perform make method, closure, object, return the record, closure. ECMA International 2024 333, 154, 5 runtime semantics, method definition evaluation. The syntax directed operation method definition evaluation takes arguments object, an object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It is defined piecewise over the following productions. Method definition, class element name, unique formal parameters, function body, let method def be. Define method of method definition with argument object, perform cert function name, method def, return. Define method property, object, method def, enumerable, method definition, get class element name, function body, let proc key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the source text matched by method definition. Let formal parameter list be an instance of the production formal parameters. Empty. Let closure be ordinary function create. %function prototype source text. Formal parameter list. Function body. Non-lexical this. env. Private env. Perform make method. Closure. Object. Perform cert function name. Closure. Prop key. Get. If prop key is a private name, then a return private element. Accessor. Undefined 10. else. Let desc be the property descriptor, enumerable, true, be perform. Define property or throw, object, prop key, desc, see return unused. Method definition, set class element name, property set parameter list. Function body, let prop key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the source text matched by method definition. Let closure be ordinary function create. Percent function prototype percent. Source text. Property set parameter list. Function body. Non-lexical this. env. Private env. Perform make method. Closure. Object. Perform set function name. Closure. Prop key. Set. If prop key is a private name, then a return private element. Accessor T. Undefined. Let desc be the property descriptor. Enumerable. True. Be perform. Define property or throw. Object. Prop key. Desc. See return unused. Generate a method. Class element name. Unique formal parameters. Generate a body. Let prop key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the source text matched by generate a method. Let closure be ordinary function create. Percent generate a function prototype percent. Source text. Unique formal parameters. Generate a body. Non-lexical this. env. Private env. Perform make method. Closure. Object. Perform set function name. Closure. Prop key. Let prototype be ordinary object create. Percent generate a function prototype percent. 34. ECMA International 2024. 9. Perform. Define property or throw. Closure. Prototype. Property descriptor. Prototype. True. False. False. 0. Return. Define method property. Object. Prop key. Closure. Enumerable. Async generate a method. Async class element name. Unique formal parameters. Async generate a body. Let prop key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the source text matched by async generate a method. Let closure be ordinary function create. Percent async generate a function prototype percent. Source text. Unique formal parameters. Async generate a body. Non-lexical this. env. Private env. Perform make method. Closure. Object. Perform set function name. Closure. Prop key. Let prototype be ordinary object create. Percent async generate a function prototype percent. Perform. Define property or throw. Closure. Prototype. Property descriptor. Prototype. Writable. True. False. False. 0. Return. Define method property. Object. Prop key. Closure. Enumerable. Async method. Async class element name. Unique formal parameters. Async function body. Let prop key be. Evaluation of class element name. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by a sync method. Let closure be ordinary function create. Percent async function prototype percent. Source text. Unique formal parameters. Async function body. Non-lexical this. env. Private env. Perform make method. Closure. Object. Perform set function name. Closure. Prop key. Return. Define method property. Object. Prop key. Closure. Enumerable. 5.5 Generate a function definition syntax. Generate a declaration. Yield. Await. Default. Function binding identifier yield await. Formal parameters. Plus yield. Await. Generate a body. Plus default. Function. Formal parameters. Plus yield. Await. Generate a body. Generator expression. Function binding identifier. Plus yield. Await. Formal parameters. Plus yield. Await. Generate a body. Generate a method. Yield. Await. Class element name yield await. Unique formal parameters. Plus yield. Await. Generate a body. Generate a body. Function body. Plus yield. Await. Yield expression. In. Await. Yield. Yield. No line terminator here. Assignment expression in. Plus yield await. Yield. No line terminator here. Assignment expression in. Plus yield await. ECMA International 2024 335. Note 2 Yield expression cannot be used within the formal parameters of a generator function because any expressions that are part of formal parameters are evaluated before the resulting generator is in a reasonable state. Note 3 Abstract operations relating to generators are defined in 2.7, 5, 3, 1, 5, 5, 1 Static semantics. Early errors. Generator method. Class element name. Unique formal parameters. Generator body. It is a syntax error if has direct super generator method is true. It is a syntax error if unique formal parameters contains yield expression is true. It is a syntax error if function body contains use strict of generator body is true and is simple parameter list of unique formal parameters is false. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically declared names of generator body, generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, generator expression, function binding identifier formal parameters, generator body. If the source text matched by formal parameters is strict mode code, the early error rules for unique formal parameters are applied. If binding identifier is present and the source text matched by binding identifier is strict mode code, it is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if function body contains use strict of generator body is true and is simple parameter list of formal parameters is false. It is a syntax error if any element of the bound names of formal parameters also occurs in the lexically declared names of generator body. It is a syntax error if formal parameters contains yield expression is true. It is a syntax error if formal parameters contains super property is true. It is a syntax error if generator body contains super property is true. It is a syntax error if formal parameters contains super call is true. It is a syntax error if generator body contains super call is true. 5. To runtime semantics. Evaluate generator body. The syntax-directed operation evaluate generator body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns a throw completion or a return completion. It is to find piecewise over the following productions. Generator body. Function body. Perform. Capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, function object, arguments list, let GB, ordinary create from constructor, function object, percent generator function prototype percent, generator brand, set G to empty, perform generator start, G, function body, return completion record, return, G, empty, 36, ECMA International 2024. Note 1. The syntactic context immediately following yield requires use of the capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, lexical goal. 155. 3 runtime semantics. Capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital O, B. The syntax-directed operation. Capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital O, B, takes arguments env, an environment record, and private env, a private environment record or null, and returns an ECMA script function object. It is defined piecewise over the following productions. Generator declaration, function binding identifier, formal parameters, generator body, let name be string value of binding identifier, let source text be the source text matched by generator declaration, let f be ordinary function create, percent generator function prototype percent, source text, formal parameters, generator body, non-lexical this, env, private env, perform cert function name, f, name, let prototype be ordinary object create, percent generator function prototype percent, perform, define property or throw, f, prototype, property descriptor, prototype, true, false, return f, generator declaration, function, formal parameters, generator body, let source text be the source text matched by generator declaration, let f be ordinary function create, percent generator function prototype percent, source text, formal parameters, generator body, non-lexical this, env, private env, perform cert function name, f, default, let prototype be ordinary object create, percent generator function prototype percent, perform, define property or throw, f, prototype, property descriptor, prototype, true, false, false, return F, 5, 5, for runtime semantics, capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital E, X, the syntax-directed operation, capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital E, X, takes optional argument name, a property key or a private name, and returns an ECMA script function object. It is defined piecewise over the following productions: generator expression, function, formal parameters, generator body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by generator expression. Let closure be ordinary function create. Generator function prototype source text, formal parameters, generator bod, y, non-lexical this, env, private env, perform set function name, closure, name, let prototype be ordinary object create, generator function prototype perform, define property or throw, closure, prototype, property descriptor, prototype, writable, true, false, false, return closure, generator expression, function binding identifier, formal parameters, generator body, assert, name is not present, set name to string value of binding identifier, let outer env be the running execution context's lexical environment, let funky env be new declarative environment, outer env, perform funky env create immutable binding, name, false, let private env be the running execution context's private environment, let source text be the source text matched by generator expression, an anonymous generator declaration can only occur as part of an export default declaration, note, and its function code is therefore always strict mode code, ECMA International 2024 337, 8. Let closure be ordinary function create, generator function prototype source text, formal parameters, generator body, non-lexical this, funct env, private env, perform set function name, closure, name 0. Let prototype be ordinary object create, generator function prototype 1. Perform, define property or throw, closure, prototype, property descriptor, prototype, true, false, false 2. Perform func env initialize binding, name, closure 3. Return closure 5, 5 runtime semantics, evaluation, generator expression, function binding identifier opt, formal parameters, generator body 1. Return, capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital E, X, of generator expression, yield, return, yield, undefined, yield expression, yield assignment expression, let X per F be, evaluation of assignment expression, let value be, get value, X per F, return, yield, value, yield expression, yield assignment expression, let generator kind be get generator kind, let X per F be, evaluation of assignment expression, let value be, get value, X per F, let iterator record be, get iterator, value, generate kind, let iterator be iterator record, let received be normal completion, undefined, repeat. Note the binding identifier in a generator expression can be referenced from inside the generator expression's function body to allow the generator code to call itself recursively. However, unlike in a generator declaration, the binding identifier in a generator expression cannot be referenced from and does not affect the scope enclosing the generator expression. 38. ECMA International 2024. A, B. If received as a normal completion, then I let in a result B. Call. Iterator record. Iterator record. Received 2. If generator kind is a sync, set in a result 2. Await. In a result 3. If in a result is not an object, throw a type error exception. I've let done B. Iterator complete. In a result V. If done is true, then return. Iterator value. In a result V. If generator kind is a sync, set received to completion, async generator yield. Iterator value. In a result 7. Else. Set received to completion, generator yield. in a result. Else if received is a throw completion, then I2 let throw be. Get method, iterator, throw. If throw is not undefined, then 2, 3, 5 let in a result be. Call, throw, iterator, received. If generator kind is async, set in a result 2. Await, in a result. Note, exceptions from the inner iterator throw method are propagated. Normal completions from an inner throw method are processed similarly to an inner next. If inner result is not an object, throw a type error exception. Let done be. Iterator complete, in a result. 15.6 syntax. If done is true, then return. Iterator value, in a result. If generator kind is async, set received to completion, async generator yield. Iterator value, in a result. Else, set received to completion, generator yield, in a result. 3. Else, note, if iterator does not have a throw method, this throw is going to terminate the yield loop. But first we need to give iterator a chance to clean up. Let close completion be completion record, normal, empty, empty. If generator kind is async, perform. Async iterator close, iterator record, close completion. Else, perform. Iterator close, iterator record, close completion. Note, the next step throws a type error to indicate that there was a yield protocol violation. Iterator does not have a throw method 6. Throw a type error exception. See else. I assert. Received is a return completion. 2. Let return be. Get method. Iterator. Return. 3. If return is undefined, then set value to received. If generator kind is async, then a set value to. Await. Value. Return completion record. Return. Value. Empty. I've. Let in a return result be. Call. Return. Iterator. Received. Via. If generator kind is async, set in a return result. 2. Await. In a return result. V. If in a return result is not an object, throw a type error exception. 7. Let done be. Iterator complete, in a return result. 8. If done is true, then set value to. Iterator value, in a return result. Return completion record, return, value, empty. 9. If generator kind is async, set received to completion, async generator yield.
Iterator value, inner return resultat.
X else, set received to completion, generator yield, in a return result. Async generator function definitions. Async generator declaration, yield, await, default, async. No line terminator here. Function binding identifier yield await. Formal parameters, plus yield, plus await, comma async generator body, plus default, async. No line terminator here. Function, formal parameters, plus yield, plus await, async generator body, async generator expression, async. No line terminator here. Function binding identifier, plus yield, plus await opt. Formal parameters, plus yield, plus await, async generator body, async generator method, yield, await, async. No line terminator here. Class element name yield await. Unique formal parameters, plus yield, plus await, async generator body, async generator body, function body, plus yield, plus await. ECMA International 2024. 39. Note 1 yield expression and await expression cannot be used within the formal parameters of an async generator function because any expressions that are part of formal parameters are evaluated before the resulting async generator is in a resumable state. Note 2 abstract operations relating to async generators are defined in 2.7, 6, 3, 1.5, 6, 1 static semantics, early errors, async generator method, async class element name, unique formal parameters, async generator body. It is a syntax error if has direct super of async generator method is true. It is a syntax error if unique formal parameters contains yield expression is true. It is a syntax error if unique formal parameters contains await expression is true. It is a syntax error if function body contains use strict of async generator body is true and is simple parameter list of unique formal parameters is false. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically declared names of async generator body, async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, async generator expression, async function binding identifier opt, formal parameters, async generator body. If the source text matched by formal parameters is strict mode code, the early error rules for unique formal parameters. Formal parameters are applied if binding identifier is present and the source text matched by binding identifier is strict mode code. It is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if function body contains use strict of async generator body is true and is simple parameter list of formal parameters is false. It is a syntax error if any element of the bound names of formal parameters also occurs in the lexically declared names of async generator body. It is a syntax error if formal parameters contains yield expression is true. It is a syntax error if formal parameters contains await expression is true. It is a syntax error if formal parameters contains super property is true. It is a syntax error if async generator body contains contains super property is true. It is a syntax error if formal parameters contain super call is true. It is a syntax error if a sync generator body contains super call is true. 5, 6, to runtime semantics. Evaluate a sync gene, rate a body. The syntax-directed operation evaluate a sync generator body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns a throw completion or a return completion. It is defined piecewise over the following productions: a sync generator body, function body, perform, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, function object, arguments list. Let generator be ordinary create from constructor, function object, percent a sync generator function prototype percent, a sync generator context, set generator to empty, perform a sync generator start, generator, function body, return completion record, return, generator, empty, 40, ECMA International 2024, 156, 3 runtime semantics, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, the syntax-directed operation, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, takes argument CNV, an environment record, and private env, a private environment record or null, and returns an ECMA script function object. It is defined piecewise over the following productions: a sync generator declaration, a sync function binding identifier, formal parameters, a sync generator body. Let name be string value of binding identifier. Let source text be the source text matched by a sync generator declaration. Let f be ordinary function create, percent a sync generator function prototype percent, source text, formal parameters, a sync generator body, non-lexical this, env, private env, perform cert function name, f, name. Let prototype be ordinary object create, percent a sync generator function prototype percent, perform. Define property or throw, f, prototype, property descriptor, prototype, true, false, false, return f. Let outer env be the running execution context's lexical environment. Let funky env be new declarative environment. Outer env perform funky env create immutable binding. Name false. An anonymous async generated declaration can only occur as part of an export default. Note declaration. ECMA International 2024 341 6. Let private env be the running execution context's private environment. Let source text be the source text matched by a sync generator expression. Let closure be ordinary function create. %async generator function prototype %source text. Formal parameters. Async generator body. Non-lexical this. Funct env. Private env perform cert function name. Closure. Name 0. Let prototype be ordinary object create. %async generator function prototype %1. Perform. Define property or throw. Closure. Prototype. Property descriptor. Prototype. Writable. True. False. False. 2. Perform func env initialize binding. Name. Closure. 3. Return closure. 5. 6. 5 runtime semantics. Evaluation. Async generator expression. Async function binding identifier opt. Formal parameters. Async generator body. Return. Capital I N S T A N T I A T E capital A S Y N C capital G E N E R A T O R capital F U N C T of async generator expression. 5.7 Class definition syntax. Class declaration. Yield. Await. Default. Class binding identifier yield await. Class tail yield await. Class default. Class tail yield await. Class expression. Yield await. Class binding identifier yield await op. Class tail yield await. Class tail yield await. Class heritage yield await op. Class body yield await opt. Class heritage yield await. Extends left hand side expression yield await. Class body yield await. Class element list yield await. Class element list yield await. Class element yield await. Class element list yield await. Class element yield await. Class element yield await. Method definition yield await. Static method definition yield await. Field definition yield await. Static field definition yield await. Class static block. Note the binding identifier in an async generator expression can be referenced from inside the async generator expression's async generator body to allow the generator code to call itself recursively. However, unlike in an async generator declaration, the binding identifier in an async generator expression cannot be referenced from and does not affect the scope enclosing the async generator expression. 42. ECMA International 2024. Field definition. Yield await. Class element name yield await. Initializer. Class in yield await opt. Class element name yield await. Property name yield await. Private identifier class static block. Static. Class static block body. Class static block body. Class static block statement list. Class static block statement list. Statement list. Yield. Class await. Return op. Note a class definition is always strict mode code. 5. 7. 1 static semantics. Early errors. Class tail. Class heritage art. Class body. It is a syntax error if class heritage is not present in the following algorithm returns true. Let constructor be constructor method of class body. If constructor is empty, return false. Return has direct super of constructor. Class body. Class element list. It is a syntax error if prototype property name list of class element list contains more than one occurrence of constructor. It is a syntax error if private bound identifiers of class element list contains any duplicate entries, unless the name is used once for a getter and once for a setter and in no other entries, and the getter and setter are either both static or both non-static. Class element. Method definition. It is a syntax error if prop name of method definition is not constructor and has direct super of method definition is true. It is a syntax error if prop name of method definition is constructor and special method of method definition is true. Class element. Static method definition. It is a syntax error if has direct super of method definition is true. It is a syntax error if prop name of method definition is prototype. Class element. Field definition. It is a syntax error if prop name of field definition is constructor. Class element. Static field definition. It is a syntax error if prop name of field definition is either prototype or constructor. Field definition. Class element name initializer opt. It is a syntax error if initializer is present and contains arguments of initializer is true. Copyright sign. ECMA International 2024 343. It is a syntax error if initializer is present and initializer contains supercall is true. Class element name. Private identifier. It is a syntax error if string value of private identifier is constructor. Class static block body. Class static block statement list. It is a syntax error if the lexically declared names of class static block statement list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of class static block statement list also occurs in the var declared names of class static block statement list. It is a syntax error if contains duplicate labels of class static block statement list with argument is true. It is a syntax error if contains undefined break target of class static block statement list with argument is true. It is a syntax error if capital CONTAINS capital UNDEFINED capital CONTINUE capital TARGE of class static block statement list with arguments, and is true. It is a syntax error if contains arguments of class static block statement list is true. It is a syntax error if class static block statement list contains supercall is true. It is a syntax error if class static block statement list contains await is true. 5, 7, 2 static semantics. Class element kind. The syntax directed operation class element kind takes no arguments and returns constructor method, non-constructor method, or empty. It is defined piecewise over the following productions. Class element. Method. Definition. If prop name of method definition is constructor, return constructor method. Return non-constructor method. Class element. Static method definition. Field definition. Static field definition. Return non-constructor method. Class element. Class static block. Return non-constructor method. Class element. Return empty. 5, 7, 3 static semantics. Constructor method. The syntax directed operation constructor method takes no arguments and returns a class element pars no door empty. It is defined piecewise over the following productions. Class element list. Class element. If class element kind of class element is constructor method, return class element. Return empty. Class element list. Class element list. Class element. 2. Let head be constructor method of class element list. If head is not empty, return head. 44. ECMA International 2024. 3. If class element kind of class element is constructor method, return class element. Return empty. 5, 7, 4 static semantics. Is static. The syntax directed operation is static takes no arguments and returns a boolean. It is defined piecewise over the following productions. Class element. Method definition. Return false. Class element. Static method definition. Return true. Class element. Field definition. Return false. Class element. Static field definition. Return true. Class element. Class static block. Return true. Class element. Return false. 5, 7, 5 static semantics. Non-constructor elements. The syntax directed operation non-constructor elements takes no arguments and returns a list of class element pars nodes. It is defined piecewise over the following productions. Class element list. Class element. If class element kind of class element is non-constructor method, then a return class element. Return a new empty list. Class element list. Class element list. Class element. Let list be non-constructor elements of class element list. If class element kind of class element is non-constructor method, then a append class element to the end of list 3. Return list. Note early error rules ensure that there is only one method definition named constructor and that it is not an accessor property or generator definition. ECMA International 2024 345. 1, 5, 7, 6 static semantics. Prototype property name list. The syntax directed operation prototype property name list takes no arguments and returns a list of property keys. It is defined piecewise over the following productions. Class element list. Class element. Let prop name be prop name of class element. If prop name is empty, return a new empty list. If the static of class element is true, return a new empty list. Return prop name. Class element list. Class element list. Class element. Let list be prototype property name list of class element list. Let prop name be prop name of class element. If prop name is empty, return list. If the static of class element is true, return list. Return the list conc. Attenation of list and prop name. 5, 7, 7 static semantics. All private identifiers valid. The syntax directed operation all private identifiers valid takes argument names, a list of strings, and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of all private identifiers valid. For each child node child of this parse node, do A if child is an instance of a non-terminal, then I if all private identifiers valid of child with argument names is false, return false 2. Return true. Member expression. Private identifier. If names contains the string value of private identifier, then a return all private identifiers valid of member expression with argument names. Return false. Call expression. Private identifier. If names contains the string value of private identifier, then a return all private identifiers valid of call expression with argument names. Return false. Optional chain. Private identifier. If names contains the string value of private identifier, return true, return false. Optional chain. Optional chain. Private identifier. If names contains the string value of private identifier, then a return all private identifiers valid of optional chain with argument names. Return false. Class body. Class element list. 2. Let new names be the list concatenation of names and private bound identifiers of class body. Return all private identifiers valid of class element list with argument new names. 46. ECMA International 2024. Relational expression. Private identifier in shift expression. If names contains the string value of private identifier, then a return all private identifiers valid of shift expression with argument names. Return false. 5, 7, 8 static semantics. Private bound identifiers. The syntax-directed operation private bound identifiers takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Field definition. Class element name initializer opt. Return private bound identifiers of class element name. Class element name. Private identifier. Return a list whose sole element is the string value of private identifier. Class element name. Property name. Class element. Class static block. Return a new empty list. Class element list. Class element list. Class element. Let names 1 be private bound identifiers of class element list. Let names 2 be private bound identifiers of class element. Return the list concatenation of names 1 and names 2. Method definition. Class element name. Unique formal parameters. Function body. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Generate a method. Class element name. Unique formal parameters. Generate a body. Async method. Async class element name. Unique formal parameters. Async function body. Async generate a method. Async class element name. Uniquef. Formal parameters. Async generate a body. Return private bound identifiers of class element name. 5, 7, 9 static semantics. Contains arguments. The syntax-directed operation contains arguments, takes no arguments and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following. Default definition of contains arguments. For each child node child of this parse node. Do A if child is an instance of a non-terminal, then I if contains arguments if child is true. Return true to. Return false. ECMA International 2024 347. Identifier reference. Identifier. If the string value of identifier is arguments, return true. Return false. Function declaration. Function binding identifier. Formal parameters. Function body. Function. Formal parameters. Function body. Function expression. Function binding identifier opt. Formal parameters. Function body. Generate a declaration. Function binding identifier. Formal parameters. Generate a body. Function. Formal parameters. Generate a body. Generator expression. Function binding identifier opt. Formal parameters. Generate a body. Async generate a declaration. Async function binding identifier. Formal parameters. Async generate a body. Async function. Formal parameters. Async generate a body. Async generator expression. Async function binding identifier opt. Formal parameters. Async generate a body. Async function declaration. Async function binding identifier. Formal parameters. Async function body. Async function. Formal parameters. Async function body. Async function expression. Async function binding identifier opt. Formal parameters. Async function body. Return false. Method definition. Class element name. Unique formal parameters. Function body. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Generate a method. Class element name. Unique formal parameters. Generate a body. Async generate a method. Async class element name. Unique formal parameters. Async generate a body. Async method. Async class element name. Unique formal parameters. Async function body. Return contains arguments of class element name. The 5th of July 2010 runtime semantics. Class field definition evaluation. The syntax-directed operation class field definition evaluation takes argument home object, an object, and returns either a normal completion containing a class field definition record or an abrupt completion. It is defined piecewise over the following productions. Field definition. Class element name initializer opt. 2. Let name be. Evaluation of class element name. If initializer is present, then 48. ECMA International 2024. ABCDE. Let formal parameter list be an instance of the production formal parameters. Empty. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Capital L. At source text be the empty sequence of Unicode code points. Let initializer be ordinary function create. Function prototype source text. Formal parameter list. Initializer. Non-lexical this. env. Private env. F perform make method. Initializer. Home object. Set initializer to name, else let initializer be empty. Return the class field definition record, name, initializer. Note the function created for initializer is never directly accessible to ECMA script code. The 5th of July 2011 runtime semantics, capital C, L, A, S, S, capital S, T, A, T, I, C, capital B, L, O, C, K, capital D, E, F, I, N, I, T, I, O, N, capital E, V, A, L. The syntax-directed operation, capital C, L, A, S, S, capital S, T, A, T, I, C, capital B, L, O, C, K, capital D, E, F, I, N, I, T, I, O, N, capital E, V, A, L, takes argument home object, an object, and returns a class static block definition record. It is defined piecewise over the following productions: class static block, static, class static block body. Let lex be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the empty sequence of Unicode code points. Let formal parameters be an instance of the production formal parameters, empty. Let body function be ordinary function create, percent function prototype percent, source text, formal parameters, class static block body, non-lexical this, lex, private env, perform make method, body function, home object, return the class static block definition record, body function. Note the function body function is never directly accessible to ECMA script code. The 15th of July 2012 runtime semantics, evaluate class static block body. The syntax-directed operation evaluate class static block body takes argument function object, an ECMA script function object, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions: class static block body, class static block statement list, assert. Function object is a synthetic function created by capital C, L, A, S, S, capital S, T, A, T, I, C, capital B, L, O, C, K, capital D, E, F, I, N, I, T, I, O, N, capital E, V, A, L. Step 5. Perform. Capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I. Function object. Return. Evaluation of class static block statement list. The 5th of July 2013 runtime semantics, class element evaluation. The syntax-directed operation class element evaluation takes argument object, an object, and returns either a normal completion containing either a class field definition record, a class static block definition record, a private element, or unused, or an abrupt completion. It is defined piecewise over the following productions: class element, field definition, static field definition, return. Class field definition evaluation of field definition with argument object, class element, method definition, static method definition, return. Method definition evaluation of method definition with arguments object and false, class element, class static block, return. Capital C, L, A, S, S, capital S, T, A, T, I, C, capital B, L, O, C, K, capital D, E, F, I, N, I, T, I, O, N, capital E, V, A, L, of class static block with argument object. Copyright sign, ECMA International 2024 349. Class element 1. Return unused. The 5th of July 2014 runtime semantics, class definition evaluation. The syntax-directed operation class definition evaluation takes arguments class binding, a string or undefined, and class name, a property key or a private name, and returns either a normal completion containing a function object or an abrupt completion. Note freeze of specification. Private methods and accessors are included alongside private fields in the slot of class instances. However, any given object has either all or none of the private methods and accessors defined by a given class. This feature has been designed so that implementations may choose to implement private methods and accessors using a strategy which does not require tracking each method or accessor individually. For example, an implementation could directly associate instance private methods with their corresponding private name and track, for each object, which class constructors have run with that object as their this value. Looking up an instance private method on an object then consists of checking that the class constructor which defines the method has been used to initialize the object, then returning the method associated with the private name. This differs from private fields, because field initializers can throw during class instantiation. An individual object may have some proper subset of the private fields of a given class, and so private fields must in general be tracked individually. It is defined piecewise over the following productions: class tail, class heritage art, class body art. Let env be the lexical environment of the running execution context. Let class env be new declarative environment, env. If class binding is not undefined, then a perform class env create a mutable binding. Class binding, true. Let outer private environment be the running execution context's private environment. Let class private environment be new private environment, outer private environment. If class body is present, then a for each string dn of the private bound identifiers of class body. Do I if class private environment contains a private name pn such that pn is dn, then assert. This is only possible for get a set of pairs too. Else, let name be a new private name whose is dn. Append name to class private environment. If class heritage is not present, then a let protoparent be percent object prototype percent. B let constructor parent be percent function prototype percent. Else. 50. ECMA International 2024. A B C D E F. Set the running execution context's lexical environment to class env. Note: the running execution context's private environment is outer private environment when evaluating class heritage. Let superclass ref be completion, evaluation of class heritage. Set the running execution context's lexical environment to env. Let superclass be get value superclass ref. If superclass is null, then I2. Let protoparent be null. Let constructor parent be percent function prototype percent. G else if is constructor superclass is false, then I throw a type error exception. H else I let protoparent be get superclass prototype 2. If protoparent is not an object and protoparent is not null, throw a type error exception. 3. Let constructor parent be superclass. Let proto be ordinary object create protoparent 0. If class body is not present, let constructor be empty 1. Else, let constructor be constructor method of class body 2. Set the running execution context's lexical environment to class env. 3. Set the running execution context's private environment to class private environment. 4. If constructor is empty, then a let default constructor be a new abstract closure with no parameters that captures nothing and performs the following steps when called. I let args be the list of arguments that was passed to this function by or 2. If new target is undefined, throw a type error exception. 3. Let f be the active function object. If f is derived, then note: this branch behaves similarly to constructor, args, super, args. The most notable distinction is that while the aforementioned DCMA script source text observably calls the @iterator method on %array prototype %, this function does not. Let func be f if this constructor, func, is false. Throw a type error exception. Let result be construct, func, args, new target, v else. Note: this branch behaves similarly to constructor. Let result be ordinary create from constructor, new target, %object prototype %v. Perform. Initialize instance elements. Result f7. Return result. B let f be create built-in function, default constructor 0, class name, the current realm record, constructor parent 5. Else a let constructor info be define method of constructor with arguments proto and constructor parent. B let f be constructor info. C perform make class constructor f. D perform set function name f. Class name 6. Perform make constructor f. False. Proto 7. If class heritage is present, set f to derived 8. Perform. Define method property proto constructor f. False 9. If class body is not present, let elements be a new empty list 0. Else let elements be non-constructor elements of class body 1. Let instance private methods be a new empty list 2. Let static private methods be a new empty list 3. Let instance fields be a new empty list 4. Let static elements be a new empty list 5. For each class element of elements, do if is static of e is false, then I let element be completion, class element evaluation of e with argument proto b else. I let element be completion, class element evaluation of e with argument f. See if element is an abrupt completion, then I set the running e execution context's lexical environment to env. 2. Set the running execution context's private environment to outer private environment. 3. Return element d set element to an element e if element is a private element, then I assert element is either method or accessor. 2. If the static of e is false, let container be instance private methods. 3. Else, let container be static private methods. If container contains a private element, pay such that pay. Then, ECMA International 2024 351 1. Assert. Element and pay are both accessor. If element a let combined be private element, accessor. Else a let combined be private element, accessor. Element pay v else. Append element to container. F else if element is a class field definition record, then I if is static of E is false. Append element to instance fields. 2. Else. Append element to static elements. G else if element is a class static block definition record, then I append element to static elements. 6. Set the running execution context's lexical environment to env. 7. If class binding is not undefined, then I perform class env initialize binding. Class binding F8. Set F to instance private methods. 9. Set F to instance fields. 0. For each private element method of static private methods, do I perform private method or accessor add F. Method 31. For each element record of static elements, do if element record is a class field definition record, then I let result be completion. Define field F. Element record. B else. I assert. Element record is a class static block definition record. 2. Let result be completion. Call. Element record. F. See if result is an abrupt completion. Then, I set the running execution context's private environment to out a private environment. 2. Return result. 2. Set the running execution context's private environment to out a private environment. 3. Return F. The 5th of July 2015 runtime semantics. Capital B, I, N, D, I, N, G, capital C, L, A, S, S, capital D, E, C, L, A, R, A, T, I, O, N, capital E, V, A, L, U, A, T. The syntax directed operation. Capital B, I, N, D, I, N, G, capital C, L, A, S, S, capital D, E, C, L, A, R, A, T, I, O, N, capital E, V, A, L, U, A, T, takes no arguments and returns either a normal completion containing a function object or an abrupt completion. It is defined piecewise over the following productions. Class declaration. Class binding identifier class tail. Let class name be string value of binding identifier. Let value be. Class definition evaluation of class tail with arguments class name and class name. Set value to the source text match by class declaration. Let env be the running execution context's lexical environment. Perform. Initialize bound name. Class name. Value. env. Return value. Class declaration. Class classed tail. Let value be. Class definition evaluation of class tail with arguments undefined and default. Set value to the source text match by class declaration. Return value 352. ECMA International 2024. Class declaration. Class tail only occurs as part of an export declaration and note, establishing its binding is handled as part of the evaluation action for that production. C16 2 3 7. The 15th of July 2016 runtime semantics. Evaluation. Class declaration. Class binding identifier class tail. Perform. Capital B, I, N, D, I, N, G, capital C, L, A, S, S, capital D, E, C, L, A, R, A, T, I, O, N, capital E, V, A, L, U, A, T. Of this class declaration. Return empty. Class expression. Class tail. Let value be. Class definition evaluation of class tail with arguments undefined and set value to the source text match by class expression. Return value. Class expression. Class binding identifier class tail. Let class name be string value of binding identifier. Let value be. Class definition evaluation of class tail with arguments class name and class name. Set value to the source text match by class expression. Return value. Class element name. Private identifier. Let private identifier be string value of private identifier. Let private env rec be the running execution context's private environment. Let names be private env rec. Assert. Exactly one element of names is a private name whose is private identifier. Let private name be the private name and names whose is private identifier. Return private name. Class static block statement list. Empty. 1. Return undefined. 5.8 Async function definition syntax. Async function declaration. Yield. Await. Default. Async. No line terminator here. Function binding identifier yield await. Formal parameters. Yield plus await. Async function body plus default. Async. No line terminator here. Function. Formal parameters. Yield plus await. Class declaration. Class tail only occurs as part of an export declaration and is never, note, directly evaluated. Async function body. Async function expression. Async. No line terminator here. Function binding identifier. Yield plus await opt. Formal parameters. Yield plus await. Async function body. Async method. Yield await. Async. No line terminator here. Class element name yield await. Unique formal parameters. Yield plus await. Async function body. Async function body. Function body. Yield plus await. ECMA International 2024. 53. Await expression. Yield. Await unary expression yield. Plus await. Note 1. Await is passed as a keyword of an await expression when the await parameter is present. The await parameter is present in the top level of the following contexts. Although the parameter may be absent in some contexts depending on the non-terminals, such as function body, in an async function body, in the formal parameters of an async function declaration, async function expression, async generator declaration, or async generator expression. Await expression in this position is a syntax error via static semantics. In a module, when script is the syntactic goal symbol, await may be parsed as an identifier when the await parameter is absent. This includes the following contexts. Anywhere outside of an async function body or formal parameters of an async function declaration, async function expression, async generator declaration, or async generator expression, in the binding identifier of a function expression, generator expression, or async generator expression. 158. 1 static semantics, early errors, async method, async class element name, unique formal parameters, async function body. It is a syntax error if function body contains use strict if async function body is true and is simple parameter list of unique formal parameters is false. It is a syntax error if has direct super of async method is true. It is a syntax error if unique formal parameters contains await expression is true. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically declared names of async function body, async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, async function expression, async function binding identity opt, formal parameters, async function body. It is a syntax error if function body contains use strict if async function body is true and is simple parameter list of formal parameters is false. It is a syntax error if formal parameters contains await expression is true, if the source text matched by formal parameters is strict mode code. The early error rules for unique formal parameters. Formal parameters are applied if binding identifier is present and the source text matched by binding identifier is strict mode code. It is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if any element of the bound names of formal parameters also occurs in the lexically declared names of async function body. It is a syntax error if formal parameters contains super property is true. It is a syntax error if async function body contains super property is true. It is a syntax error if formal parameters contains super call is true. It is a syntax error if async function body contains super call is true. 54. ECMA International 2024. Note to unlike yield expression, it is a syntax error to omit the operand of an await expression. You must await something. 158. To runtime semantics, instantiate async function object. The syntax-directed operation instantiate async function object takes argument CNV, an environment record, and private env, a private environment record or null, and returns an ECMA script function object. It is defined piecewise over the following productions: async function declaration, async function binding identifier, formal parameters, async function body. Let name be string value of binding identifier. Let source text be the source text matched by async function declaration. Let f be ordinary function create. Async function prototype. Source text. Formal parameters. Async function body. Non-lexical this. env. Private env. Perform cert function name. F. Name. Return f. Async function declaration. Async function. Formal parameters. Async function body. Let source text be the source text matched by async function declaration. Let f be ordinary function create. Async function prototype. Source text. Formal parameters. Async function body. Non-lexical this. env. Private env. Perform cert function name. F. Default. Return f. 5, 8, 3 runtime semantics. Capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital F, U, N, C, T, I, O, N, capital E, X, P, R, E, S. The syntax-directed operation. Capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital F, U, N, C, T, I, O, N, capital E, X, P, R, E, S, takes optional argument name, a property key or a private name, and returns an ECMA script function object. It is defined piecewise over the following productions: async function expression, async function, formal parameters, async function body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by async function expression. Let closure be ordinary function create. Async function prototype source text, formal parameters, async function body, non-lexical this, env, private env, perform set function name, closure, name, return closure, async function expression, async function binding identifier, formal parameters, async function body, assert, name is not present, set name to string value of binding identifier. Let outer env be the lexical environment of the running execution context. Let funky env the new declarative environment. Outer env perform funky env create immutable binding. Name false. Let private env be the running execution context's private environment. Let source text be the source text matched by async function expression. Let closure be ordinary function create. Async function prototype source text, formal parameters, async function body, non-lexical this, func env, private env, perform set function name, closure, name 0, perform func env initialize binding, name, closure 1. Return closure. Note the binding identifier in an async function expression can be referenced from inside the async function expression's async function body to allow the function to call itself recursively. However, unlike in a function declaration, the binding identifier in a async function expression cannot be referenced from and does not affect the scope enclosing the async function expression. ECMA International 2024 355 158 for runtime semantics. Evaluate async function body. The syntax-directed operation evaluate async function body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns a return completion. It is defined piecewise over the following productions: async function body. Let promise capability be new promise capability, promise percent. Let dec result be completion, function declaration instantiation, function object, arguments list. If dec result is an abrupt completion, then a perform call promise capability undefined dec result 4. Else a perform async function start promise capability function body return completion record return promise capability empty 5 runtime semantics evaluation async function expression async function binding identifier formal parameters async function body return capital I N S T A N T I A T E capital A S Y N C capital F U N C T I O N capital E X P R E S of async function expression. Await expression, await unary expression. Let x per f be evaluation of unary expression. Let value be get value x per f. Return await value 5.9 async arrow function definition syntax. Here equals async concise body in capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R yield await async concise body in async concise body in look ahead expression body in plus await async function body async arrow binding identifier yield binding identifier yield plus await capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R yield await member expression yield await arguments yield await supplemental syntax when processing an instance of the production async arrow function capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R equals async concise body. The interpretation of capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R is refined using the following grammar: async arrowhead, async, no line terminator here, arrow formal parameters, yield, plus await, 56, ECMA International 2024, async arrow function, in, yield, await, async, no line terminator here, async arrow binding identifier yield, no line terminator here, equals 159, 1 static semantics, early errors, async arrow function, async arrow binding identifier equals, async concise body. It is a syntax error if any element of the bound names of async arrow binding identifier also occurs in the lexically declared names of async concise body. Async arrow function, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R equals async concise body, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R must cover an async arrowhead. It is a syntax error if capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R contains yield expression is true. It is a syntax error if capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R contains await expression is true. It is a syntax error if any element of the bound names of capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R also occurs in the lexically declared names of async concise body. It is a syntax error if capital A S Y N C, capital C O N C I S E, capital B O D Y, capital C O N T A I N S, capital U S E, capital S T R of async concise body is true and is simple parameter list of capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R is false. 5, 9, 2 static semantics, capital A S Y N C, capital C O N C I S E, capital B O D Y, capital C O N T A I N S, capital U S E, capital S T R. The syntax directed operation, capital A S Y N C, capital C O N C I S E, capital B O D Y, capital C O N T A I N S, capital U S E, capital S T R, takes no arguments and returns a boolean. It is defined piecewise over the following productions: async concise body, expression body, return false, async concise body, async function body, return function body contains use strict of async function body 159. 3 runtime semantics, Evaluate to sync concise body. The syntax-directed operation evaluate to sync concise body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns a return completion. It is defined piecewise over the following productions: a sync concise body, expression body, let promise capability be, new promise capability, promise percent, let decl result be completion, function declaration instantiation, function object, arguments list. If decl result is an abrupt completion, then a perform, call, promise capability, undefined, decl result 4, else a perform async function start, promise capability, expression body, return completion record, return, promise capability, empty, 5, 9, for runtime semantics, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital A, R, R, O, W, capital F, U, N, C, T, I, O, N, capital E. The syntax-directed operation, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital A, R, R, O, W, capital F, U, N, C, T, I, O, N, capital E, takes optional argument name, a property key or a private name, and returns an ECMA script function object. It is defined piecewise over the following productions: a sync arrow function, a sync arrow binding identifier equals, a sync concise body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by a sync arrow function. Let parameters be a sync arrow binding identifier. Let closure be ordinary function create. Percent async function prototype percent, source text, parameters, async concise body, lexical this, env, private env, perform set function name, closure, name, return closure, ECMA International 2024 357, async arrow function, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, equals, async concise body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by a sync arrow function. Let head be the async arrow head that is covered by capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Let parameters be the array formal parameters of head. Let closure be ordinary function create. Percent async function prototype percent, source text, parameters, async concise body, lexical this, env, private env, perform set function name, closure, name, return closure, 5, 9, 5 runtime semantics, evaluation, async arrow function, async arrow binding identifier equals, async concise body, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, equals, async concise body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital A, R, R, O, W, capital F, U, N, C, T, I, O, N, capital E, of async arrow function 15.10 tail position calls, 5, 1, 0, 1 static, semantics, is in tail position, call. The abstract operation is in tail position takes argument call, a call expression parse node, a member expression parse node, or an optional chain parse node, and returns a boolean. It performs the following steps when called. If the source text matched by call is non-strict code, return false. If call is not contained within a function body, a concise body, or an async concise body. Return false. Let body be the function body. Concise body, or async concise body that most closely contains call. If body is the function body of a generator body, return false. If body is the function body of an async function body, return false. If body is the function body of an async generator body, return false. If body is an async concise body, return false. Return the result of has call in tail position of body with argument call. 5, 1, 0, 2 static semantics, has call in tail position. The syntax directed operation has call in tail position takes argument call, a call expression parse node, a member expression parse node, or an optional chain parse node, and returns a boolean. Note tail position calls are only defined in strict mode code because of a common non-standard language extension, C10, 2, 4, that enables observation of the chain of caller contexts. Note one call is a parse node that represents a specific range of source text. When the following algorithms compare call to another parse node, it is a test of whether they represent the same source text. Note 2, a potential tail position call that is immediately followed by return get value of the call results is also a possible tail position call. A function call cannot return a reference record, so such a get value operation will always return the same value as the actual function call result. 58. Copyright sign, ECMA International 2024. It is defined piecewise over the following productions. Statement list item. Let has be has call in tail position of statement list with argument call. If has is true, return true. Return has call in tail position of statement list item with argument call. Function statement list, empty. Statement list item, declaration, statement, variable statement, empty statement, expression statement, continue statement, break statement, throw statement, debugger statement, block. Return statement, return, labeled item, function declaration, for in of statement. 4. Left-hand side expression of assignment expression statement. 4. var for binding of assignment expression statement. 4. For declaration of assignment expression statement. Case block. Return false. If statement. If expression statement else statement. Let has be has call in tail position of the first statement with argument call. If has is true, return true. Return has call in tail position of the second statement with argument call. If statement. If expression statement. Do while statement. Do statement while. Expression while statement. W while. Expression statement for statement. 4. Expression not statement. 4. var variable declaration list. Expression not statement. 4. Lexical declaration expression not statement for in of statement. 4. Left hand side expression in expression statement. 4. var for binding in expression statement. 4. For declaration in expression statement. ECMA International 2024 359. With statement. With expression statement. Return has call in tail position of statement with argument call. Labeled statement. Label identifier. Labeled item. Return has call in tail position of labeled item with argument call. Return statement. Return expression. Return has call in tail position of expression with argument call. Switch statement. Switch. Expression. Case block. Return has call in tail position of case block with argument call. Case block. Case clause assopt. Default clause case clause assopt. Let has be false. If the first case clauses is present, set has to has call in tail position of the first case clauses with argument.
Chatbot's going in a circle. I don't want to like actually figure anything out. At least not right now. If I keep, I don't know. Chatbot sucks. It's giving me functions to use. And each time it gives me a whole new set of parameters. And it backtracks and it goes forward. It doesn't know what the fuck it's doing. Except like right now with the quads, whatever the fuck it's called. Stupid triangles. It's black, whatever. Nothing. But I still have the old one. That works. Well, what's this? Okay, so it does still work. So, this works. It's actually running faster. So, updating this fixed some of the stuff. In the old window. Because it's running smoother or whatever. I don't even know, it's a stupid pipeline or some shit. I attach different things to different stuff and I change it or something. I gotta like really actually figure it out now. Where's the mouse? It's not clicking. So I don't know. This works better. So it still works. Except the old mode. That is the old mode. Except the new mode. Something's wrong with it. Because this is black. There's nothing in there. Oh, this is so annoying. It's probably like one stupid setting. Chatbot's not helping at all. I'm gonna have to like find a tutorial or actually Google it. Because Chatbot isn't no freaking help. So I don't know. Only like a little bit left. And this window should pop up with the image in it. Just like the old mode. If this works, I don't know. There's something that's off and I can't find it. I've attached every stupid piece. I've checked it. I've carefully renamed it. I haven't spotted what's off. Yeah, no, it's really frustrating. So I don't know, I'm gonna let the stream run on for 10 more minutes. Because it doesn't always send the whole stream. So if I let it run on for 10 more minutes, it might end up sending the whole stream. And I don't know. I'll get next stream, whatever. Peace. I'll be another day behind. I need time to stop moving. If time stopped moving, that would save me a lot of time. But no, it keeps ticking. Till next stream. Peace.
One zero five six p desk. The internal method of a proxy exotic object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Define property. If trap is undefined, then a return target. P. Desk. Let desk obj be from property descriptor. Desk. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. Desk obj. If boolean trap result is false, return false. 0. Let target desk be target. P. ECMA International 2024 207. 11. Let extensible target be. Is extensible. Target. 2. If desk has a field and desk is false, then a let setting config false be true. 13. Else, a let setting config false be false. 4. If target desk is undefined, then A if extensible target is false, throw a type error exception. B if setting config false is true, throw a type error exception. 5. Else, A if is compatible property descriptor, extensible target, desk, target desk, is false, throw a type error exception. B if setting config false is true and target desk is true, throw a type error exception. C if is data descriptor, target desk, is true, target desk is false, and target desk is true. Then, if desk has a field and desk is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariance. The result of is a Boolean value. A property cannot be added. If the target object is not extensible, a property cannot be non-configurable, unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable, unless there exists a corresponding non-configurable, non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7, P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has if trap is undefined, then a return target. P. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. If Boolean trap result is false, then a let target desk be target. P. B. If target desk is not undefined, then I target desk is false. Throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. Return Boolean trap result. 08. ECMA International 2024. Note for proxy objects enforces the following invariance. The result of is a Boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get. If trap is undefined, then a return target. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desk be target. P. If target desk is not undefined and target desk is false, then if is data descriptor, target desk, is true and target desk is false, then I have same value, trap result, target desk, is false. Throw a type error exception. B. If is accessor descriptor, target desk, is true and target desk. 0. Return trap result. Note, the value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-writable, non-configurable own data property. The value reported for a property must be undefined if the corresponding target object property is an unconfigurable own accessor property that has undefined as its. 0, 5, 9. The perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined, then a return target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. V. Receiver. If Boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is not undefined and target desk is false, then ECMA International 2024-209. If is data descriptor, target desk, is true and target desk is false, then I have same value. V. Target desk, is false. Throw a type error exception. B. If is accessor descriptor, target desk, is true, then I have target desk. 1. Return true. Note, the result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property. Cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its. 0, 5, 1, 0. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. If Boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note for proxy objects enforces the following invariance. The result of is a Boolean value. A property cannot be reported as deleted